Distinguished participants, ladies and gentlemen, a very good morning to all of you and welcome back again to the third IUFRO Acacia Webinar Conference from Kuching, Sarawak, Malaysia. I'm Anya Ambrose and I will be your MC again for today's sessions. Ladies and gentlemen, we have now come to the third and the last day of the webinar. We have indeed gained a lot of insight, knowledge, as well as valuable networking, although the conference is conducted virtually. And again, on behalf of the organizing committee, we would like to express our deepest appreciations to all fellow participants attending this conference. Thank you very much to all of you. Without any further delay, it is now my pleasure to invite again Ms. Annie Ting, the Chief Executive Officer of Sarawak Timber Associations, to continue her role as the moderator for today's sessions on high value-added timber product. Please welcome Ms. Annie. Hi, Ms. Annie.
Hi, morning.
Morning.
Thank you. Welcome everyone. For the session 4, the high value added timber product. I have received a revised program from the organizing committee that yesterday, unfortunately, we are not able to get connect to Dr. Lamara. But today we are grateful that he is able to join us either through the pre-recording video or personally present visually to present his presentation. So this morning session, we will have 4 presentations. First, I would like to invite the invited speaker, Mr. Jamshad Mohtar. He will present the effect of the pre-pressed veneer to laminated acacia hybrid veneer lumber, strength and performance. He is currently a senior lecturer with 22 years of experience working as educator and researcher in University Malaysia Sabah. He got a master's degree in wood industry technology and graduated from UPM in 2000. The area of his specialization and interest related to biomass composite property and utilization and wood industry energy characteristics And currently, his research works focus on the development on green products from biocomposite from cultivated Acacia mesozoum and Acacia hybrid and oil palm trunk. With this brief introduction, I will now invite Mr. Janshan to start your presentation whenever you are ready. Thank you. Mr. Janshan, are you around?
Yeah, I'm around, yeah.
Good.
Can you see my slide presentation?
We can.
Okay.
But you may need to put in the slide mode.
Yeah, I tried.
Okay. Thank you. You need to press the slide mode. This is a. I think the slide mode is just next to the phone side. You put the next one.
Sorry. This bar not still appears.
Oh.
Yeah. I cannot click the slide presentation.
Would you want the secretariat to help you?
Yeah, sure.
Secretariat, would you be able to help on the slide? You may need to cross sharing. Secretariat, are you there? Anyone there?
Yeah, Miss Sunny, you are here. We need you to stop share your slide.
Okay.
Yeah. Okay. Okay. Now you can start your 20 minutes presentation.
All right. Okay. Thank you. Thank you, Miss Moderator, Miss Anything, CEO Sarawak Timber Association. I hope you can hear my voice clearly, right?
Yeah, very clearly. Your voice.
Okay. I try my best to end this presentation within 20 minutes or less. Yeah, it's more better. Okay. Very good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. It's an honor to me for today to deliver a presentation with the topic of my presentation is effect of the pre-pressed veneer to the laminated acacia hybrid veneer lumber strength performance. Next, please. In this presentation, I will cover a few main points, include the discovery of acacia hybrid in Sabah, the acacia hybrid general characteristic, the importance of pre-pressed veneer treatment, and also I will cover the objective of the LFVL study related on strength performance. And finally, I will cover the strength performance evaluation of laminated acacia veneer lumber. Next. So as we know that the acacia hybrid is the genetic crossbreed between Acacia mesozoum and Acacia auriculaformis. This moderate hardwood species is a member of the Leguminosae family. As we know that the Acacia hybrid was first discovered in Ulukukut, Sabah in 1971. Yeah, according to Raffles, 1987. For the next slide. Meanwhile, in Peninsular Malaysia, the acacia hybrid was found in 1989. But some other sources also claim that Hebron and Shim, they were claimed that acacia hybrid also was found in this Suk district, Sabah, but in 1972. So this makes this very good discovery of acacia hybrid in Sabah itself. Yeah. So from the other research from the other preview research, they emphasize that the Acacia hybrid is a crossbreeding between Acacia mengium and Acacia oryxiformis that would produce a hybrid species superior to its mother tree. And according to the Lorilla 1992, Acacia hybrid is bred through tissue culture, stem cutting technique, and natural crossbreeding. So in my study, I used the sample Acacia hybrid is based on the natural crossbreeding between Acacia mengium and Acacia oryxiformis. Next. Why we study the Acacia hybrid? Because the general characteristic, for example, for the plantation species, is one of the fast-growing species, whereby the growth rate of Acacia hybrid was double of its parental species, which is 22 meter cubic per hectare per year. Yeah. And the growth rate of 12 cubic meter per hectare per year only as described by other researchers like Martin. And besides, Acacia hybrid also has a better straightness of stem level and excellent sources of timber with higher density and shape of logs almost round the parent trees. Acacia hybrid also has natural defects such as knots, holes, but is removed during manufacturing process. And this makes the edibility of Acacia hybrid is observed to be a result from its 2 until 2 times more rhizobium nodules than its parent species, as reported by Carr in 2006. Among the most notable characteristic of Acacia hybrid is its higher resistance towards disease, in particular heartroot, a major disease frequently attacking Acacia mengium. This was found by Lidin Carr in 2000. Next. There are several techniques of method of wood treatment that are intended to enhance durability, improve dimensional stability, and minimize strength defect, such as veneer full cell treatment or veneer kiln drying, or heat treatment, and so on. Next. So what is the prepressed veneer treatment? The technique of prepressed veneer had been started over a century ago, according to the Masters 2011. So in this research, a laser non-mechanical treatment, which is compression technique, was adapted to desalinify the veneer for the manufacturing of LVL panel. According to Chang 2012, mechanical compression treatment, which is more economical and environmentally friendly, is claimed can increase wood density and the strength by reducing the void volume of the wood. Next. Through the mechanical treatment, the LVL can have a better properties, such as a more effective thermal conductivity, improve the glue bonding of the wood veneer due to better surface characteristic, and reduce glue assumption, and also decline the pressure of hot press used in the final stage of the laminating process. Next. So the study on the mechanical properties of prepressed veneer of Acacia hybrid have been carried out yet for where the research is done. And because we know that since LVL has the potential to replace solid wood in all type of application, then this mechanical treatment is particularly very significant. By this research, the effect of prepressed Acacia hybrid veneer on the mechanical properties of LVL will be able to be known in depth. Thus, the result of this study can be used to make the LVL stronger and quality in various uses. Next. So the main purpose of the study was to determine the mechanical properties, which is static bending and compression, strength, of the pre-pressed 10 years old Acacia hybrid veneer alluvial panel. There is a three main objective in this study. First, to evaluate the mechanical properties of the pre-pressed veneer alluvial panel made up of the different tree trunk portion. The second objective is to determine the mechanical properties of the pre-pressed veneer alluvial made up of different ply number. And the third objective is to investigate the influence of pre-pressed veneer on the mechanical properties of the alluvial panel. Next. So in this study, the Acacia hybrid ages 10 years old was harvested from Acacia hybrid forest plantation in Ulukukut. Here is northern region of Sabah. This one, in Kota Belud, Ulukukut and Kota Belud. In East Malaysia, this is Peninsular Malaysia, Sarawak, and this is Sabah. So 5 sample trees of 10 years old were chosen from the planting area for each diameter class, and the tree is free from any defect, pest, and disease. Next. So each tree will cut into a 3 log portion to represent the basal portion, middle portion, and the top portion. Both sapwood and hardwood from each sampling based on height are included in the study. These sample collections are conducted according to the standard determined by International Organization for Standardization, ISO standard 4471-1984. Next. So the Acacia hybrid veneer sample preparation is from the 10 years old cutting, tree cutting, and then debugging process. After debugging is rotary peeling for the standard size, industrial standard size, and then bring to the lab for cutting into a lab scale size, veneer cutting and cutting size. Next. And then the preparation of laminated Acacia hybrid veneer lumber is, in this study, will consist of 3 processing stages. First is veneer manufacturing, veneer manufactured through rotary peeling method. Second, veneer full strip treatment, veneer drying, and veneer pre-press treatment. I will talk about later about the veneer pre-press treatment. And the third stage is veneer layup and pressing, including glowing. And the final dimension of alluvial panels sample were 300 millimeter times 300 millimeter times 14 thickness millimeter for 7 ply, and there's a 5 ply and 3 ply. In this research, the pre-press of the Acacia hybrid veneer will carry out of 105 plus minus 2 degrees Celsius for the 30 second and at 5 megapascal as suggested by the Pablo 2012. For the next slide, we can see that there's the pre-press veneer treatment method applied for this study according to the Pablo 2012. And according to Pablo, when the temperature increased from 100 to 150 degrees Celsius, the strength of the plywood also increased. Besides that, Pablo also reported that a higher pressing pressure, the veneer will be smoother surface, hence higher bonding strength. However, higher temperature and higher pressure during the pre-pressing would mean a higher cost of production. In addition, the pre-pressing time was noticed to have least impact on the strength. 30 seconds of the pre-pressing would be optimum option in terms of costing and time consuming. Thus, Pablo 2012 suggested the 100 plus minus 3 degrees Celsius for 30 seconds, and at the 5 megapascal would increase the mechanical strength of the LVL panel most eventually. Next. This is the process fabrication for the LVL sample from the pre-press and then cold press for 20 minutes, and final is hot press for 6 minutes. This is the final sample for laminated acacia hybrid veneer lumber. This one is for 7 ply. Next. So after the sample is prepared, and the evaluation on the laminated acacia veneer lumber was undergo to test the mechanical properties. We know that the mechanical properties of the strength performance determine the ability of the sample to resist load apply. These properties are vital for different design application by identifying the use of product for either heavy-duty purposes, example, structural and building, or other light duties such as furniture, vehicle, and tool handles. The properties which were tested in this experiment include MOE and MOR in static bending test and maximum stress in compression strength parallel to the grain of the LVL. The testing sample were based on ASTM D1037-06A standard and tested using the machine, universal testing machine. Next. So as its result, from the static bending strength of LVL panel at different trunk. In this research, the basal portion and middle portion LVL show higher mechanical properties than top portion LVL of both pre-press and without pre-press veneer in the MOE and MOR for the static bending test, and also the compression strength. The top portion LVL panel has lower strength as set due to the large amount of crown form with shorter fiber and lower specific gravity than the basal portion of the tree stem. Yeah, the static bending strength MOE and MOR of the pre-press and without pre-press LVL panel sample at different portion and different ply layer was shown in table 1. There was significant difference found between the MOE MOR of the 3 different portions, basal, middle, and top portion, and 3 different ply layer, which is 3, 5, and 7 ply of LVL panel for both pre-pressed veneer LVL panel and without pre-pressed veneer LVL, or I will step after this WPP LVL panel. Next. So this table showing that result of the LVL panel for the for the bending strength for the basal, middle, and top portion, and different ply of the LVL 3 ply and 5 ply and 7 ply. So as I mentioned just now, there's a very significant difference between different number of ply in pre-pressed veneer lumber or without using the sample without pre-pressed veneer lumber. Next. This is the result shown that the MOE of the 3-ply LVL. The MOE of the 3-ply PP pre-pressed veneer for LVL, it had decreased from 11,456 Newton per millimeter square for basal portion to 7,721 Newton per millimeter square, an average of 3,735 Newton millimeter per square reduction in the MOE. Whereas for the without pre-press for 3-ply, approximately 2,436 Newton millimeter per square reduction had occurred in MOE from the basal portion to the top portion of the tree trunk. Next. Meanwhile, the MOE of the 5-ply LVL show the same trend of decline was also observed in the 5-ply pre-pressed veneer LVL as well as without pre-pressed veneer LVL panel. The 5-ply LVL recorded a reduction of 1,847 Newton millimeter per square for prepressed laminated vinyl lumber panel and 1,308 Newton millimeter per square for the without prepressed LVL panel. The reduction was found to decrease from the basal portion to the top portion of the trunk of the tree trunk portion. Next.
Mr. Jamsa,
Yes, yes.
you have 2 more minutes.
Okay. So I will fast. Okay. This is to show the difference of the result for MOE of the 7-ply. Okay. The trend is similar. Next. And for the MOR rupture, also the trending is recorded similar. There's a reduction from the basal portion to the top portion. Next. And also for the MOR, for the 5-ply LVL, yeah, it's observed that recorded reduction, yeah, from the basal to the top portion for the both prepressed veneer and without prepressed veneer. Next. And also recorded for the MOR for the 7-ply, yeah, is also conversely decrease the MOR from the basal portion to the top portion of the tree trunk. Next. So as a result, for the compression, table 2 show the compression strength of the prepressed veneer LVL and without prepressed veneer LVL at different trunk portion and different ply layer. Next. This is a table 2 for compression strength. There's very significant difference for the different ply of LVL and different using the veneer from the different trunk of portion for the prepressed veneer and without prepressed veneer. Next. So these are for the compression strength of the 3-ply, for the basal portion from 3-ply, middle, and the top portion. But this trend is almost similar, but compared to the without prepress, the prepressed veneer sample more higher than the performance of the compression strength more higher than the without prepressed veneer. Next. The compression strength of the 5-ply had decreased from 6,000 at the basal portion to 5,000. A total around 700 reduction was recorded. Next. And the compression strength of the 7-ply, as you can see, figure 3C, 7-ply PPLVL had a decline in its compression strength as shown in at the basal portion to the top portion, which recorded an average 5.28% reduction. Meanwhile, the 7 without prepressed veneer where an average 2,198 in reduction was recorded from the basal portion to the top portion of the tree trunk. Next. So we know what I've observed. We have finding from the research, what the factor influence the strength performance of the LVL is because the prepressed veneer LVL panel influence the strength performance at different strength performance of prepressed veneer LVL panel at different trunk portion. So we know that the basal portion and the middle portion level higher mechanical properties, whereby the top portion has lowest strength. According to the Burden 1964, due to the large amount of crown form with shorter fiber, lower specific gravity, the middle and basal portion of the tree stem is influenced to the strength performance. And according to the Zhang, the microfibril angle MFA of the S2 layer of the fiber cell will be higher. Microfiber angle will lead to a lower strength in MOR and MOE. Next.
Mr. Jamshad, can you make the sum out the final?
Okay. All right. All
slide?
right. So I can see that we can conclude that. Next. Bending strength of LVL mat from the LVL of veneer significantly different by different ply of different number of ply and different trunk of portion used to produce a LVL. Next. So as conclusion, the influence of pre-pressed veneer LVL on the strength performance is shown in table 3. Next. And the recommendation for pre-pressed veneer for in future study is more on study on the engineered wood product, because we know that Acacia hybrid is very perform in engineered wood product. This Acacia hybrid locks round. This is a laminated Acacia hybrid unfinished vinyl lumber. This is one of the potential uses utilization of the Acacia hybrid LVL. Next. And then for the next future research, extension research, for this one is like image of 10-year old Acacia hybrid vessel, and this study was done for fire testing using the Acacia hybrid. Maybe we can use this kind of method to study the pre-pressed veneer LVL on the strength performance. Next. Next. So this reference. Next. Next. And with all that, I'm very thank you to acknowledgement to Ministry of Higher Education in Malaysia for funded this grant, and very thankful to organizer Third IUFRO Acacia Conference 2020, and very many thanks to the Sarawak Forestry Department become a host for this year. Thank you very much.
Thank you, Mr. Jamshan. Sorry to cut off your presentation short. You have a very comprehensive presentation. It's actually very informative. Due to the time, unfortunately, I have to shorten your presentation. But hope that we can actually get your presentation. I think a lot of very useful information. So I will reserve the any question or clarifications till the Q&A session. Thank you, Mr. Jamshan, for your presentation. Thank you.
Welcome. Thank you.
I will now welcome the second invited speaker for this morning, Mr. Mohammad Saifu Sulaiman. He is from the University College of Technology, Sarawak. Currently, he has actually been an academician in engineering and technology school. As I have mentioned, that is in the University College of Technology, Sarawak for 4 years. And he developed his teaching and research skill, and also have a few research projects, mainly in wood science and non-wood products. His research area cover wood science, wood and non-wood property, biocomposite, and engineering products. With this brief introduction, I would like to invite Mr. Mohammad Saifu to make your presentation whenever you are ready.
Okay, thank you for our moderators, Miss anything. So can you hear me?
Yes, clearly.
Okay, now let me share for the slide presentations.
Yeah. You have 20 minutes time for your presentation.
Okay, right, thank you. All right, so can you find my slides presentations?
Yes.
Okay. Right, good morning and assalamualaikum to all of participants of IUFRO conference. Okay, so thank you to the organizer for invitations. I am Mohammad Saifu from the University College of Technology Sarawak, Sarawak. Okay, so today I would like to share parts of our research study in acacia species. It's about the experimental investigations on the effects of thermal treatments on the physical and mechanical properties of acacia hybrids. Okay, my slide, is it moving? Right, okay. This is our research outline for that about the objective and some introductions about the acacia species. Okay, so based on objective and introduction, there are main objective and overview of acacia species properties and their proper performance on wood treatments. And for the materials and methods, okay, so for the materials and methods, three methods are used for identify the physical properties and two main testing conduct in mechanical properties. And the thermal treatments was applied for the wood's durability. And for the result discussions, we will determine the effects of parameters used in research and to the physical and mechanical properties. And on the discussion part, we will discuss the suitability and performance of acacia properties due to the parameter use, right? And slide is it about our objective. Okay, so we have a three main objective was conducted with a few parameters are considered. Okay, the first objective is to determine the physical properties on the untreated specimen as a control purpose. And the second one is to investigate the physical properties of treated specimens based on their difference of portion, temperatures, and durations of thermal treatments. And the last one is it to justify the mechanical properties of a treated specimen according to the parameters decided. Right. So for the introduction part, as I mentioned in a previous slide before, we would like to share a few informations about the acacia species, especially on their prospect characteristic, treatment potentials, and also the applications of acacia hybrids. Okay, so the first one is acacia hybrid has a better prospect in a larger scale plantations due to the high adaptability to growth in a poor soil with no adverse effects on the environments. And the second one is the characteristics of the acacia hybrids. Okay, so the acacia hybrid is possesses better characteristics compared to the parent species, such as can be in a bigger size in diameters, stronger trunks, less branching system, and a less knot on the acacia hybrid itself. And the third one is the thermal treatments on the acacia hybrids. Okay, so the thermal treatment is one method used to modify properties of wood by improving the dimensional stability and resist to the biocorrosions. And the fourth one is the acacia hybrid has a promising potentials in a timber industry due to the intensive utilizations of the other acacia species, and has currently become a stable alternative choice for the timber plantation species itself. And of course, due to the investigation on the properties, we'll go into the application of the acacia hybrid itself. And the utilization include the furnitures making purpose door and without a window frame, parquet floorings, and toe components. Also recommended for the engineered wood products such as the LVL, glue lamps, shrimbles, and others composite type based on different raw material form. Okay, so as discussed in objective part, to realize the potentials and application of acacia woods, the study was focusing on their physical and mechanical properties due to the effect of the thermal treatments. Okay, so this is a few of materials and methods we have done in our part of investigations. Okay, so on the materials and methods part, the Acacia hybrid was investigated based on three main parameters used, which is different portions. Is it the bottoms, middle, and top? And the different temperatures of a study. Is it we use two different temperatures? Is it 160 degrees Celsius and 200 degrees Celsius? And different in durations of a treatment, which is 1 hour, 2 hours, and 3 hours of a duration for the treatments. Okay, so for the preparation parts, is it the lot with a diameter breast height at 40 cm were harvested and cut, and in this study the trees was harvested at 50 cm from the ground level and 50 cm below the first main branch, and 100 mm of this from the trunk from the tree selected portions was taken. And for the thermal treatments was conducted using the electric oil curing machines and the palm oil as a heat medium at the different temperatures and durations, as I mentioned before. Then the specimen were cut according to the ISO standard. All right, so as I mentioned before, we have a cover for physical properties and mechanical properties. And in part of physical properties, the study includes for the moisture content, density, and basic density was investigated. And for the moisture contents on the Acacia hybrids was conduct follow the standards specified in ISO standard. And then the second one is the density and basic density for the physical properties. Okay, so for the density and basic density, the specimen was tested according to the ISO standard, and with defined as a density is a mass per unit volume for the solid wood matter. And then the other parts of our objectives is the mechanical properties. Okay, so on the mechanical properties, the study also focuses on the performance of Acacia itself, and this is based on the strengths of the static bending and also the compression test. All right, for the static bending from the tangent surface of Acacia hybrids was carried out according to the ISO standards, as mentioned on the slide, and the study was determine the value of MOE and MOR value as a represented the strengths and of the modifications Acacia hybrids based on thermal treatments. All right, so this is as illustrated in 4 figures on the slide. It was represent for our research conduct in a field until the laboratory test. Okay, so for the first and a second figures are indicate for the random samples selected for the Acacia hybrids on the field of a study. Then the third figures are shown the thermal treatment with palm oil as a medium for the curing treatments, and the temperatures and durations will monitored using the panel control of the machine itself. And the last figures are highlighted that the sample cutting follow to the IO standards before our testing of physical and mechanical properties are conducted. All right, so this is for the results and discussions on the physical properties of Acacia hybrids. Okay, so here I would like to share the outputs of natural of Acacia hybrid physical properties and to investigate it on the effect of thermal treatment to the physical properties, especially on the moisture content, density, and basic density. All right, so this is physical properties of the Acacia hybrids on the for the untreated samples. Okay, so the untreated samples or green samples was taken to determine their properties of the moisture content, density, and basic density, and as a control result to measure the effectiveness of the step. Sorry. Okay, so the figure are represented. The green samples had the ranging at the 65% to the 75% of the moisture content at the different portion reading as represent on the graph below. And for the basic density and density highlighted the different ranges of the value, with a basic density was 66 to the 72 kilonewton per meter cube, and the density show the range was at 73 to the 76 kg per meter cube at the bottom, middle, and top respectively. And found that the high value indicate at the middle portion as represents in figures shown on the slide, right? And this is the study are focusing on the modifications of physical properties with use palm oil as a medium for the thermal treatment on the acacia hybrids. Okay, so based on the main indicators with the wood portion, temperatures, and durations, the density and moisture contents are determined on the study. And according to the figures shown on the slide, show that the value of moisture content was decreased proportionally. Thermal treatment applied with a ranging from 18 to 19% of moisture contents, and the differentiations value from 0.5 to the 5% between each parameter used. And then for the density indicated that slightly decreased according to the thermal treatment applied with a ranging around to the 6 to the 68 kg per meter cube, and the highest value of density in orders of all parameters factors are at the bottom portions. Okay, so as you know that the wood density varies great with any species at the tree due to a number of factors such as locations in a tree, locations with a range of species site, and the site conditions, which is the soil, water.
We lost the speaker. We lost the speaker, or?
Oh, sorry. So
okay.
Now you can hear me?
I can hear you again. Yeah.
Oh, okay. Sorry. All right. So now, we will discuss about the result and discussions on the mechanical properties of the acacia hybrids. Okay, so this is the third objective, what I mentioned before. This is a sharing part of investigations on the modifications on the mechanical properties for the acacia hybrids.
Mr. Mohammad, would you want to share your slide again? Now we can't see your slide.
Sorry, is it missing?
Thank you.
So now can you find my slide?
Yeah,
sharing?
can see your slide now. Yeah.
Okay, sorry for the technical problem.
Yes.
Right. Yeah. Okay, so this is a part of modifications of the mechanical properties on the acacia hybrids. Okay, so what I mentioned before, we have two main two main testing for the mechanical properties. Okay, so the highlight on the figures the two testing has been conducted in a study which are the static bending and also the compression test. For the static bending, the value of MOE and MOR was determined, and the rest testing was determined the compressive value of the modifications of Acacia hybrid itself. Okay, so let we go one by one for the result on the mechanical properties. All right, so the figures highlight that the high value of MOE in a static bending at a bottom portion with around to 9,749 Newton per meter cube for the followed by the top and a middle with respective value. And the strength of Acacia hybrids was identified that the decrease proportionals the treatment for the thermal treatments was applied, and clearly represent that on the figures the value are decreased when the decrease of the temperature from the 0 to the 200 degrees Celsius, and durations of a treatment at the 0 to the 3 hours. And the comparison value are indicated in the figures respectively shown on the slide. And according to the previous research, the strength varies within the among the species, and they also state that within any species and considers variations exist in a clear root strength, which is correspond to the variations of density itself. And other part is according to the previous research also that the strength varies within amount of species, and the wood strength which is correspond to the variations in a density and density strengths relationship for the properties. And also the strengths and the elasticity of woods can be influenced by the several factors such as the density, angles of grains present of not on the samples, and other anatomical features, moisture content, temperatures, time, and also defect on the sample itself. Right. Okay, so this is MOR value for the static bending. For the MOR on the slide show that the value for MOR was investigated for the with the highlighted the highest MOR value at the bottoms and above, followed by the top and middle portions. And the maximum fiber stress of the Acacia hybrid itself was determined with a decrease proportionally the thermal treatment was applied in a sample. And the comparison between value of indicate on the figures respectively. Support that by the many previous research believe that the decrease in strength properties can be explained by the rates of thermal degradations and losses of substance after the heat treatments. Then the decrease in strength is mainly due to the depolymerizations reactions of the wood polymer itself. And this is last part on the mechanical properties itself. Is it the compression test for the Acacia hybrids? Okay, so the mechanical properties of Acacia hybrids are determined based on a compression test also, and found that the highest compression value indicate at the bottom with around to the 78 Newton per meter cube, and followed by the middles and top portions respectively. And the ultimate strength of the Acacia hybrids under the compression test was determined decrease proportionally the treatment was applied on the sample itself, and the result was show the best ratio for the thermal treatments are at the 200 degrees Celsius and in 3 hours duration for the treatment itself. And this is a slightly similar with static bending for the based on the previous researchers believe that the compression strength value generally deteriorated with increase in temperatures or exposed to the time, and against the reductions on the strength of the heat-treated samples can be explained with a progressive degradations of the hemicellulose between the microfibrils on the sample itself. Right, so this is some conclusions can be concluded on the part of our research. That means that the thermal treatments will giving more stability to the acacia roots. Okay, so for the treatments, it can be separate into the four part. Is it the effects on mechanicals or under the thermal treatments, effect on physical properties under the thermal treatment, the weakness of the research and the strength of the research. Okay, for the mechanical properties under the treatments, the study found that the thermal treatments process did not achieve a desired outcome, such as getting a positive effect on mechanical properties of a treatment on the acacia hybrids. But on the physical properties, the thermal treatment gave a better effect on the physical properties in terms of faster time of wood dryings and high density that can be controlled on the control samples. And the fitness of the study is it that there are support by the analysis highlight that almost of a value strength assessment with a different level of temperatures and time durations show the lower values compared to the untreated sample size. But then the strength of the study is it the factors of a temperature and time durations of the thermal treatments were more influential toward the physical and mechanical properties of a treated acacia hybrids than the portion factors. So it can be concluded that the thermal treatments will give more stability on the acacia woods in terms of a good protective from the attack by fungi or not easy to absorb the moistures and good for the gluing process on the engineered wood manufacturing for the further studies on maybe for the glue lamp, LVLs, and others composite products based on acacia hybrid itself. Okay, so right, so I think that's all from me. Thank you to the moderators and the organizer of the conference. Okay, thank you.
Thank you, Mohammad Saifu, for your very relevant research work again on the acacia hybrid. I will again reserve the questions or clarifications to the question and answer session. Now, I would like to invite the third speaker for this morning, Miss Yani Joparadi. I hope I pronounced your name correctly. She is now currently attached with Sabah Softwood Berhad, and she is holding the position of Research and Development Manager and managing research and development at Softwood Berhad since 2023. A very experienced lady, and have been actively translating R&D outcome to operation practices. And she has 25 years of research and practical experience in forest plantation, management, and tree improvement, integrating genetics, silviculture, end-use property, and forest health in managing fast-growth tropical tree plantation species in the Malaysian state of Sabah. Her presentation will be on the compressing and pressural property on plantations grown Eucalyptus Paleta in Borneo, Malaysia, potential for structural and timber end use. Miss Yani, would like to invite you for your presentation whenever you are ready. And you have again 20 minutes for your presentation. We can't hear you, Miss Yani. You are not mute, but we can't hear you. Maybe you may want to check with your sound system.
Hello, can you hear me now?
Yes, yes. Okay.
Can I share my screen? I would like to share my screen first. Okay, can you see my screen?
Yes, maybe you need to on your slide mode.
Okay.
Yeah, good. Can see it now.
Okay, so okay, Assalamualaikum and very good morning to everyone. So happy to see everyone here today. Okay, so my presentation today is actually covers the general overview of the tree plantation as a source of timber for high-end utilization based on our evaluation on the mechanical wood properties of plantation-grown eucalyptus in Eucalyptus Paleta in Borneo. So I would like to start with an overview, but before that, because I think yesterday, so few presenters talk about the ceratocystis and the impact of ceratocystis on the acacia mangrove plantation. So in Sabah in particular, so we are in the transition of changing the species into Eucalyptus paleta. So it's also necessitated for us to review the end utilization of the species because the timber industry need wood to process. As the availability of mixed tropical hardwood logs declines from the natural forest, so it had shifted the supply chain reliance on the natural forest to supply from plantation. So therefore, the timber industry needs to adapt to changes in resource. And the industry itself, they should aware that to supply timber from plantation is relatively complex compared to the natural forest because of the complexity in the plantation management. So, but the logs from plantation are more uniform. That is the advantage. And in terms of value, they are lower per tree, but high volume per hectare. So the managing the tree plantation is totally new outlook. And I think the government required to foster timber industry based on plantation. And the most important, the timber industry people need to communicate with the growers. And what is the characteristic of the new resource? So to produce such end use, it may require single or dual species. And the timber from shorter rotation plantation usually have smaller diameter of trees and larger percentage of juvenile woods. And in terms of the wood properties, it's the variability occurs within tree spatial and between tree, but even high variation if we are managing a breeding population. So there is a huge variation between family and even within family. And the product quality come from the plantation management is very much influenced by how we manage the same. So it's it's more complex compared to the natural resource. And actually there is a lot of questions, research questions related to this new research, which is a plantation timber with regards to the solid wood production. And I would like to highlight here some of the fundamental questions that really need in laying the foundation for sustainable and profitable tree plantation, particularly in Borneo. So the growers wanted to know what is the key species to replace natural forest for solid wood products, and what is the key silviculture management. And the processor, they wanted to know what is the characteristic of the raw material supply. And we need to quantify and we need to characterize this raw material. The need figures to estimate what capital investment required in retooling the mill or reset up their operation. And the wood product itself. So we need to understand what is the properties of short rotation log and what is the variation in the wood quality. And the most important, I think, the breeders. To deploy improved planting material with wood quality traits, the breeder wanted to know how can future generation be selected from breeding trials to ensure the best planting material is available for deployment. So to address those questions, our team here in Borneo, the BFC, had initiated this project, which led by Dr. Roger Meader, and this project involved resource assessment, and also the second stage, we have improvement methodology in our breeding selection. But I'm not going to present all the findings for this project, but my presentation today will be focused on this mechanical performance. So what the literature say about the species in the region? So it has been used for pulp predominant for pulp and paper in Sumatra as a replacement for Acacia menjum. And some trial been done for been conducted in Vietnam for furniture, and little or no tree improvement for solid wood and engineered wood product. So in Sabah in particular, in terms of commercial planting, we have started in 2012 actually, in the commercial scale. And currently we have 16,000 hectare planted on the ground, and we have commencing and the pruning have commenced in 2016. And this is the first solid wood project being conducted, which is the basis of our BFC, solid wood project. And further work has been initiated as an extension of the our first solid wood project. And the assessment of Eucalyptus Paleta for mechanical performance is part and parcel of the solid wood project in aiming to understand and improve the knowledge base of Paleta grown in humid tropical environment. And this is our sampling site, and the map shows the Borneo Island contains Malaysian state of Sabah and Sarawak, and all samplings for this study occurred at 4 sites in Sabah. And you can see from the table there, we have 4 trial plots being sampled with various ages. And actually we have one study done in Sarawak to get some insight before we proceed with this more comprehensive project in Sabah. Okay, this is the information of the trial, and this is the sampling strategy that we have set to achieve multiple objectives of the solid wood project. But for this particular wood quality evaluation and for the assessment of the mechanical performance, the samples were prepared along with the sowing study. And from the sowing, so a total of 1,742 boards were prepared with that dimension there. And we have 4,800 clear wood test specimen with the respective dimension here for the mechanical testing. And you can see the diagram here shows the schematic random test specimen location from an individual log to allow us to understand the radial variation of the mechanical properties. So all the test specimens were run to failure, and MOE, modulus of elasticity, modulus of rupture, and compression strength were calculated. And the specimen were tested using the 100 kilonewton universal testing machine, which was manufactured in Taiwan. And specimen with 20 millimeter width and 60 millimeter length were assessed for compression parallel to the grain. And specimen with 320 millimeter length for 3-point bending test, which force applied onto tangential face as plank and radial face as joist. And you can see the diagram here shows the right position of force with respect to grain direction and growth rate of the wood. This is the result. So we start with the density because we have taken this in each pair of the log section up to 12 meter here. You see on the axis, the x-axis here, we have data up to 12 meter. And the density is one of important parameter to guide us on the utilization. And we can see from this graph, the mean basic density varies within tree and show to be influenced by the tree height here. But interesting here to see that the bottom log, I mean the butt log and the top log is not much different in terms of the density value, and tend to increase and plateau towards the crown here actually. And on the other graph, on the second graph, we can see the increase, and this is across the sampling site just now that I mentioned just now. So we can see increasing trend with age and irregular trend with age of KB. One site here due to poor growth performance and actually had different establishments. So this plot is actually suffered from high mortality. So that's why we can see the irregular trend here. And similar to the mechanical properties here, the three properties, the MOE, MOR, and the compression strength, we can see there's almost similar pattern to the density just now across the sampling site, and of course, definitely across ages as well. Yeah. And this is the summary of the mechanical testing data. The mean value of the mechanical strength from each of the sampling site, and also, I mean, with the respective age here, and you can see the MOR, MOE, MOR, and compression, as well as the basic density. And we compare the mean value with the Eucalyptus Paleta result conducted in Queensland previously on the 15 years old stain. And the result here you can see is comparable with what we obtained. And then the mean value also we compare with the Acacia Mangium on the 16 years old stain. And we found it a bit lower compared to the 7 years old stain of Eucalyptus Paleta. And definitely for the Laran or Kelampayan or Jabon. So 7 years old is a very is a very light wood, very low properties. And this is more interesting. We compare with the one of the important species, tropical species, which very important for the structural material here. And you can find, and I presume this is sample from natural forest, and you can see the result is also comparable with the older stain from Eucalyptus Paleta. So according to the Malaysian standard, they have a strength group system, and we found that Eucalyptus Paleta would be classified as strength group 2, indicating that plantation grown Eucalyptus Paleta in the tropics has potential for high end use application. So this is the information in terms of the radial variation of wood stiffness. As we know that wood stiffness is the elastic properties which measured as MOE, and is a very important properties when we design a product for structural material. And from this, we can see the heat map here showing the MOE of both position from pith to bark, and the y-axis here is represent actually the height of the tree. And this is the radial variation of wood stiffness within a single stem. And you can see the value, the color indicate here is the value of the MOE. And also the graph on the right side here, and you can see the position of the board within the log. So this information shows that stiffness is lowest near the pith in the lower part of the stem, and increase radially toward the bark and longitudinally up to the stem. And the implication is the structural base obtained from the outer wood, and the practical application at the operational level to get the right balance between volume and quality, so the operation can segregate veneer or sawn board for value. And okay, that is on a single stem. So how the variation look like across the population. So we see here This is the relative both position with respect to pith for each of the age of the stain, also the sampling side. And we can see from here, stiffness increasing with age and plateaued, enable growers to develop optimal rotation period to suit the product quality. So of course we see the irregular pattern here for the KB because of some noises. So the stiffness increasing from pith to bark and greater magnitude for 7 years old. You can see the 150H here is 7 years old stain, and you can see the magnitude change very rapid. And stiffness increase from bud log to the top, even though we can see because the line color here is actually represent the log section. So from here we can see some fluctuation, but the general trend shows that stiffness is increasing from bud log to the top. And actually this is typical trend of most species being studied by many researchers. But for Paleta, even in the juvenile core, are sufficiently high to meet specification for structural. So we can see the 7 years old stain here, the lowest near the pith, the MOE value is about 9. So what is the implication? So this information will tell that the increase the economic value of Eucalyptus Paleta raw log supply from plantation. So the growers can, we have the value, so the growers can demand for price. So and of course, we need to enhance the value of the products in order to increase tree plantation profitability. So all the while we are producing a commodity products, and for such high value species or high value timber, we need to set for final value so that the growers can get better price for the log. So they will ensure the sustainability of the supply from the tree plantation. And because the growers is happy because they get better price from their log. Okay, so I think our presenter yesterday have talked about engineered wood products, so I don't have to talk much on that. But by definition, actually, majority of the wood-based product that we have in the market are engineered wood product, and they are categorized under this category. So for the high value, the highest value engineered wood product actually can be obtained from this category. And high mechanical performance of Eucalyptus Paleta offers us a real opportunity to add value to the end product. And I think this is some of the example of the engineered product that has been explained yesterday. So I just quick through this slide. So we have glue lamp. This is a long span. Yeah, this is the CLT. So this is a multi-story building using CLT. This is more sophisticated design using LVL somewhere in the other part of the world. Yeah. And this is another wood engineered, composite engineered wood. And of course, yeah, next. So how was it? How was the Eucalyptus Paleta characteristic for solid wood application? So this is some of the findings that we had, found from our peeling study of unpruned material. So this is the volume recovery, the range of total volume recovery from the input volume. And this is the volume recovery of the face back veneer from the total input volume. And we found that recovery of clear veneer increased with the log diameter. So only core veneer was obtained from 7 years old stain due to knots. And there is a significant percentage of loss of value because of the presence of knots from green to dry. And again, end splits were the main contributor to the loss on splitting.
Miss Yani, you have 2 more minutes.
Okay. For the sawing performance, this is what the recovery that we get. And again, recovery loss on dry grade was due to major defects because of the large branch associated with wider spacing. And then again, end splits is the major contribution. So there is an issue limiting recovery, require implementation of silviculture treatment. And there is a critical need to commence pruning. Why the slide not move? Okay. So the occurrence of end splitting, so significant for Eucalyptus paleta, severity increase with storage time, and there is the influence of sowing pattern, and we also have anecdotal evidence in the some provenance are more prone to end split. And in fact, one of the speakers yesterday is supposed to present this information, but what we get from this, and this is the key finding from the study, that the end splitting is actually heritable. So based on the evidence that we have here, so I would like to conclude this presentation. So the increasing demand for solid wood products have provided a clear objective for improving the wood quality. And Eucalyptus paleta is capable of producing high value products such as appearance and structural plywood, flooring, framing, and engineered wood. So managing plantation for high value product will improve profitability per hectare, and we need to review downstream processing to facilitate a small log diameter. Growing Eucalyptus paleta to produce engineered wood offers profitable opportunity for individual company and sustainable national timber industry. So we know most of the FMU in Sabah, we may operate less than 20,000 hectares. So in order for them to manage tree plantation economically, they need to produce some kind of high value product for them to be more profitable. Why it cannot move? So then wood property issues require appropriate selection of genetic material and improvement in silviculture management. So increasing stem straightness and decreasing taper are key ingredients to improving lumber or veneer yield. For many products, knots need to be limited. The proportion of juvenile wood and compression wood need to be limited. So non-destructive methodology is required to deliver wood quality improvement. So before I end, I would like to acknowledge a group of people here. So for the Borneo Forestry Cooperative member in particular, and for the Research Center of Sabah Forest Department and Rakyat Berjaya for access to material, and Rajang Plywood in Simau Plywood Sendirian Berhad for wood processing, and my colleagues and management of Sabah Softwood, and BFC support scientists, Roger Meader, David Bowden, Mike Wingfield, Paul Warburton, Jeremy Bronner, and Paul McDonald, and huge thanks to University of Sunshine Coast for the opportunity for the postgraduate. Thank you very much for your attention.
Thank you, Ms. Yani, for again another very informative information on the eucalyptus. Due to the time, we are 20 minutes behind, so I would like to invite the last invited speaker, Dr. Ilham Mara. I hope you are online. And briefly introduce him. He is currently serving as a senior lecturer and a course coordinator of the mechanical engineering program at the Faculty of Engineering, Computing and Science at Swinburne University at Sarawak campus. His research interest involves polymer method, composite, energy and environment sustainability, and thermal flux system. And he have actually published more than 50 international journals and more than 18 book chapter and more than 20 conference paper. Very again another experienced researcher. Dr. Ilham Mara, are you online? Doctor, are you online?
Good morning, everyone. I'm Dr. Ilham Jaiman, Senior Lecturer, Faculty of Engineering, Computing and Science, Swinburne University of Technology, Sarawak campus, Kuching, Sarawak, Malaysia. Today, I would like to present a research on development of sustainable biocomposites made of acacia wood for electronics applications. These are my presentation outlines. It consists of introduction, natural fiber composites, flexible energy storage applications, commercial electronics, biomedical applications, novel intrinsically conductive polymers, conclusion, and then references. Introduction. Primary problem. Traditionally, dielectric materials are made from inorganic substances such as silicon dioxide and mica. These inorganic materials have higher thermal properties. Temperature requirements leads to an extreme end of processing temperature and brittle. So researchers are looking for an alternate material, that is polymers. Polymers are gaining wider use as dielectric materials due to easier processing, flexibility, able to tailor-made specific use, and better resistance to chemical attack. At the same time, coefficient of thermal expansion is relatively larger than ceramic materials and susceptible to atmospheric and hydraulic degradation. These are the drawbacks. At the same time, weakened mechanical properties. So researchers still looking for a new material that is called natural fibers reinforced polymer matrix composites. That synergistic property between natural fibers as well as polymer. Basically, currently, lot of industries, especially electrical and electronic industries, uses various kinds of dielectric materials, especially those materials are made of traditional dielectric materials based on silicon dioxide and mica, but these materials consumes lot of thermal energy. Okay, that is a drawback. At the same time, these materials are brittle. So researchers are gone for polymer matrix materials, polymer materials. Polymers are weak in mechanical strength. So currently researchers are working on natural fibers reinforced polymer matrix composites for dielectric materials. Natural fibers of all kinds have been used for various applications. When we can talk about natural fiber, it comes with the different varieties. All the natural fibers are used in various applications. For example, when we can take applications, natural fibers reinforced polymer matrix composites are used in a lot of industries like automobile industries, aeronautical industries, biomedical industries, sports industries, and then transport industries. Many we can say. One of the applications in which natural fibers have been found useful is dielectric. Currently, electrical and electronic industries, they use a lot of dielectric materials. So these natural fiber reinforced polymer matrix composites potential candidate for dielectric materials. Dielectric materials serves huge insulations, energy storage, high breakdown materials for transmission, and many more applications. Although the use of conventional materials such as ceramic and other substrates as a dielectric has reached a point where facts of sustainability have not properly met. When we can use ceramic, when we can use like mica, when we can use silicon dioxide, various kinds of traditional dielectric materials, they are not sustainable. They use a lot of pollution in terms of air pollution, water pollution, as well as soil pollution. So researchers are looking for biodegradable dielectric materials. That's what the play of natural fibers reinforced biodegradable, that is biopolymers. That is a point of research here. These are natural fiber composites. We can look at natural fiber composites. These are various natural fibers, bast fibers, leaf fibers, seed fibers, fruit fibers, and wood fiber. When we can talk about in our research here, acacia wood, because in Swinburne University of Technology Sarawak campus, we did a dielectric properties testing for various natural fibers as well as wood composite as well. So I will show you later on how we did, what are the publications we did based upon wood fibers based dielectric materials. And then grass and reed fibers. These are the matrix polymer, because we know composites is a combination of two distinct material. They have a different physical and chemical properties. One is called matrix, that major elements. Another one is called as reinforcement. In our case, we are using reinforcement is wood. For matrix, we use various kinds of plastics like thermoplastic, thermoset, as well as natural rubber. For example, you can look at thermoplastics here: phenolic, epoxy, polyester, polyamide, polyurethane. In case of thermoplastics, we got polypropylene, polyamide, polyethylene, polystyrene, polyvinyl chloride. And then we got natural rubbers like India rubber, modified starch, polylactic, cellulose ester, tannin, and then polyhydroxybutylene acid. So these are various matrix, as well as these are the various fibers we may use for natural fiber composite. Especially here, we are talking about acacia wood. Acacia wood got a lot of properties compared with other natural fibers, especially cellulose content. The cellulose content plays an important role in dielectric application. In Swinburne, we are using dielectric property testing based upon fabrication. All our testings are standard based upon American Society for Testing Materials. These are the standard mold we are using. These are hot compression molding machine, and then these are the precision LCR meter to measure dielectric, that is contacting type electrode device to measure dielectric of composite materials. These dielectric properties of composite precisions are measured with the HP impedance analyzer. LCR meter is capable of measuring up to frequency of 2 megahertz. The disc samples a diameter of 50 mm and a thickness of 5 mm. Diameter 50 mm and thickness of 5 mm. The specimens were analyzed using contacting electrode method. You can look at the picture. This is called contacting electrode mixtures. The diameter is 50 mm and the thickness is 5 mm. Contacting electrode method, which uses a rigid metal electrode. The measurements were done at varying frequencies ranging from 1 kilohertz to 1 megahertz, or we can go for 1 kilohertz to 2 megahertz also possible. We also follow according to standard measuring device like ASTM D15010 standard for dielectric measurements. As well as we are using standard dimension for specimen preparation as well. We use either compression molding machine, or we can use extrusion machine or injection molding machine. In Sulaiman, we got extrusion machine as well as hot compression molding machine. We use hot compression molding machine for most of the thermoplastic polymers to make composite materials. And then we use cold compression in case of other thermoset resins as well. These are the various dielectric materials applications. The sectors like energy storage and conversion, printed electronic circuits, flexible wearable device, power transmission, information storage, and soft robotics. So these dielectric materials are most of the applications in electrical and electronic industries. Dielectric application of natural fibers reinforced polymer composites. Natural fibers, great insulators, which mean that they can able to polarize when they are subjected to high electric field. As it know that there is a multiple polarization process involved, such as like any natural fiber got a property of insulator, so they can able to easily polarize. When you can easily polarize, they can able to store the charge. The polarization, different types of polarization takes place: atomic, ionic, spontaneous, space charge, and dipole polarization. So when we can apply electric field on natural fiber like acacia wood, they can get polarized so that they can able to store charges by means of this type of polarizations. Chemical treatments of wood like alkaline, silane, acetylation, peroxide, chloride, permanganate, and stearic acid are highly effective in increasing fiber surface toughness and introducing hydrophobicity one way or another, so that it can increase the dielectric constant value. Apart from this, other treatments which could give rise to better polarization, especially space charge and interfacial polarization, or isocyanide treatment and malination process. This process increases the polarization ability of natural fibers as well. These are natural fibers and their dielectric properties. You can example like jute, flax, hemp, canaf, loofah, cotton, bamboo, baka, silk, wool. You can look at this point wood. When we can talk about wood, generally acacia wood and other natural wood available in Sarawak forestry, the amount of dielectric is 7.1. We can compare with other natural fibers. This is the highest value because of the cellulose content. How natural? Because each and every natural fibers behaviors are different, depends upon their nature of growing. This wood, especially Sarawak wood, acacia wood, it contains 7.1. Its loss factor 0.35, and then relaxation frequency. So from this literature, what we know that wood contains high amount of dielectric constant. So this is a potential candidate for preparing electrical and electronic devices made of polymer matrix composites as well. For example, the first application where we can go for this type of natural fibers reinforced composites. This natural fiber, I mean here, it's a wood polymers composites as well. Flexible energy storage device ranges from electronic textiles, artificial electronic skins, military wear, and wearable electronics such as smart watches and distributed sensors. These type of flexible energy storage devices uses lot of dielectric materials. especially a lot of research going on towards use of conventional material to replace by natural fiber reinforced composite materials. For example, you can look at this flexible energy storage device at the current research stage are to offer high performance, optimum operation safety, and environmental safety. These energy storage devices must possess insulating dielectric layers, which allows moderate levels of shielding, and since they became used as human beings. For example, you can see natural fiber reinforced polymer composites comes to play where their lightweight and optimum dielectric properties allow them to potentially be applied in these applications. So what I want to say here, for flexible energy storage applications, natural fibers reinforced composite materials are replacing the conventional dielectric material usage. That's an important thing. And then for commercial electronics, when we can talk about commercial electronics, especially it comes to integrated circuits, batteries, and electrical breadboards. For all the devices, we are using a lot of dielectric materials. So flexible energy storage device and commercial electronic device also uses a lot of dielectric materials. However, composite materials are used for ceramic and polymer combinations, which does not permit sustainable material use as not cost effective, because the traditional materials are not sustainable. For example, you can take a mica, or you can take a silicon dioxide, or you can take any kind of ceramics. It consumes a lot of energy during their production. At the same time, they are brittle. At the same time, they are not sustainable. So we need to look for sustainable material. When you can choose natural fibers as well as biodegradable polymer, so it's completely environmental friendly material. So that most of the researchers are looking for natural fibers reinforced materials for dielectric. You can look at this point. Recent research has come up with solutions amp up dielectric properties and provide biodegradability at the same time. So they have to satisfy both dielectric property as well as biodegradability. Currently, these composites are used as insulators, plugs used in household, connectors, cables, and printed circuit boards. So natural fiber reinforced composites are replacing conventional materials in commercial electronics as well. Biomedical devices. A lot of biomedical application uses natural fiber reinforced composites, especially the technology. You can look at this point. As a new fabrication methods are emerging, like fused diffusion modeling, that is fused deposition modeling, FDM. This is a one kind of additive manufacturing or a 3D printing. These technologies are enabled to make different varieties of components. It is easy as well as flexible. Especially these devices are used in biomedicine and then paramedical industries. You can look at this point. Fused deposition modeling is very popular with the polymers as a configurations of FDP fabrications allow an even finish on the product. So we can able to make particular shape and size, even intricate shape, complicated shapes also possible by using this type of 3D printing. Or we can say additive manufacturing. These technologies enables to prepare natural fiber reinforced polymer composites as fabricated to focus on array of medical implants and devices made of assessing bone structures. Even for a bone plate replacement, we are using a lot of bone plates made of commercially natural fiber reinforced polymer composites, because previously the bone plates are made by using titanium and aluminum and stainless steel, but currently the researchers are doing with a lot of natural fiber composite materials. So these type of 3D printing technologies like additive manufacturing technologies enable to develop a lot of filament. The filament combination of natural fiber and polymers, they are used to prepare a lot of composites for dielectric application. You can look at, although fiber reinforced composite materials is a dielectric, it possesses relatively fewer breakdown strength and required further research to fully utilize the niche in which these composites can put into good use. So a lot of research is going on to develop new biomedical devices based upon natural fiber, that is wood-based natural fiber composite as well. Novel intrinsically conductive polymers, that is ICPs. Intrinsically conducting polymers are typically a synthetical metal. We can say actually it's a polymer, it's synthetical metal. As these possess properties of electrical, magnetic, and optical phenomena, same as metals and semiconductors. These ICPs behaves like a metal, but it contains a lot of electrical and magnetic optical properties. That properties are similar to metals and semiconductors. Their application must have low cost, high performance, and organic, which can be used in chemical detecting sensors. So this type of ICs are mostly used in chemical detecting sensors because it consists of properties like electrical, magnetic, as well as optical. That property is equivalent to metals and then semiconductors. Also, these dielectric composites reinforced by natural fibers have potential in bioactuators, chemical and electrochemical catalysts. So these ICPs are used in various applications, especially for bioactuators, chemical and electrochemical catalysts. The idea here to incorporate natural fibers into polymer matrix to arrange structures. So when we can mix the natural fiber, that is wood, with the polymer, we can arrange in a different way with a particular angle, long fiber, short fiber, chopped fiber. So this contributes to various kinds of dielectric phenomena, so that it uses various actuators as well as chemical and electrochemical catalysts as well. My conclusion, from these perspectives of sustainability, eco-friendly and safe matters, natural fibers reinforced polymer composites have a great potential in use as dielectric. Compared with synthetic or traditional materials, these natural fiber composite materials are sustainable, eco-friendly and safe matters. Some of the applications that have been seen here could great examples to prove that advancement of using conventional composites to novel dielectric composite is viable in future and technology-driven application. In future, a lot of researchers and scientists are working on replacing traditional dielectric materials by this type of wood-based or natural fiber-based composite materials. Although one were to critically analyze the exploration of technology for improving the performance and qualities of natural fiber reinforced composite, it requires tremendous efforts and research to move fabricate composite to a finished product. So it needs a lot of research as well as development activities to bring out to the particular shape and then size of this type of dielectric materials. Looking at the commercial point of view, novel composites will always stay an integral part of society and business as time and technology progress. This allows stakeholders like manufacturing industry, commodities, engineering and research fellows to flourish, as there will be always be new opportunities when natural fiber or wood-based composites are coming into the market. The recurring challenge to this research community is to make fully biodegradable polymer. That is an important fully biodegradable polymer composites or manufacturing polymer derivatives from bio-based materials. So currently researchers are looking for completely biodegradable polymer matrix composites so that it goes for zero environmental pollution with respect to water, with respect to air, with respect to soil, zero pollution. So that's called biodegradable polymers. Researchers are working on that. Furthermore, there are other facts of material science where natural fiber reinforced polymer composites can diversify their opportunities in additive manufacturing technologies where more challenges lie ahead. So what happened? Currently, the lot of techniques like additive manufacturing or 3D printing, these are the latest technologies. So these latest technologies also uses various types of natural fibers, reinforced composites, especially we can say with respect to Sarawak, a lot of woods are available, acacia wood. So this type of wood-based composite materials plays an important role for the development in future. These are references. These are the publications done by Sulaiman University with respect to dielectric materials. Recently in 2021, we published in Materials, Chemistry and Physics, Interfacial Polarization Effects on Dielectric Properties in Flux Reinforced Polypropylene, Strontium Titanate Composite. And then the second publication in Journal of Applied Polymer Science, Characterization Study of Flux Strontium Titanate Polypropylene Composite for Low Dielectric Application. And then we studied a comparative study of dielectric properties of hybrid natural fiber composites. And then we did an effect of chemical treatment on polarization dielectric properties of Kumpang wood reinforced epoxy composites. And then we did with a natural Borneo wood like Sarawak wood, dielectric properties of natural Borneo wood like Keranji, Kayu Malam, and then Kumpang. We have published in bioresearch as well. These are the various researches done in Sulaiman University. We are trying to establish to make a complete biocomposite materials, especially for dielectric application. Thank you very much.
Thank you, Doctor. Now, we are very behind the time. I think it's less than 10 minutes to the next session. So I will quickly open up to the Q&A session for only 5 minutes so that they have some few minutes to start the next session. Now, from the chat, from the chat, there is 2 questions for Miss Yani. I think that one is quite straightforward, whether your UTM have a testing sample. And another question is from the Doringo. Commented that Eucalyptus Paleta is very new in Sabah. So whether it will be a lot of unknown with regards to this species. So from their observation, there are problems with splitting knots, poor field performance, and would like to know your comment to this concern. Miss Yani?
Yeah, thank you, Miss Annie. I think the first question asking about the UTM machine, right?
Yes.
So, yeah, I think the UTM machine is available for testing, so we can facilitate for those who want to do the testing, so we can provide the service. And then the second question, which regards to the splitting. Yes, as I mentioned in my presentation just now, that splitting is very significant to Eucalyptus paleta, and I think there is an opportunity to minimize these incidents, so we can set long-term strategy and also the short-term strategy. So for the long-term strategy, from my presentation just now also, there is an opportunity for breeding selection to minimize these incidents. And also, I think for the short-term strategy, and this need to be done at the operational level, because we found that there is an influence of storage time in terms of the incident. So planning at the operational is crucial, particularly on the logistic parts when we arrange from the harvesting site to the operation. And at the harvesting operation as well, there is immediate activity that can minimize this, where we can put the S hook or something like that, and put the at the end of the at the end of the the grease. So okay, so for the knots, so as a highlight in my presentation, so pruning will help, would minimize the knots, and we will get a clear veneer from the prune trees. And with regards to the poor field performance, I think we need to apply base operational practice. So we already set a regime, appropriate regime for Eucalyptus paleta to be more productive. I think that's all.
Thank you, Miss Yani. Thank you. The next question is for Mohammad Saifu. Again, thank you for your interesting presentation. In terms of basic density and moisture mix proportion of tree is higher than the bottom and top. However, in terms of mechanical property, mid portion is lower except compression. Any further specific justification on this?
Okay, thank you for the good question actually. Okay, so what we know with clear belief by many researchers mentioned that the highest density will be highest in mechanical property itself. Okay, so this is what we know before. But then based on the research, it can be the result show that the middle portion is highest than density and moisture than the bottom or top, right? So as we know that the wood density, okay, so for the wood density and the moisture contents will be influenced by a few factors actually. This is such as for the locations in trees, locations with a range of species, site conditions such as soil, waters, and slope, and also genetic source itself. But then for the physicals and the mechanicals physical mechanical properties of the wood itself can be influenced by the porosity of preparations of density itself, and also for the organizations of the cell wall structures. Okay, so in this case, for the further study, we can look in for the what call is on the macrostructures analysis, so we can find that the what happened on the middle part of the acacia hybrids. Maybe is have the biggest, or what call is vascular bundle or parenchyma that influence the density itself. Okay, so maybe for the further study, we'll looking for the macrostructures on the acacia hybrids. Okay, so thank you.
Thank you, Mohammad, Saifu. Wait, Mr. Jamshan, you want to make a comment?
Yes, I'm commenting on the difference value of the compression by basal portion, medium, and middle and top. Actually, for testing or study involved solid wood specimen, they must be emphasized or more particular about the hardwood and sapwood must be isolated. They will not mix together. That's why there is more be variation in future study. Yeah, that's my comment. Yeah, all right, that's all. Okay.
Thank you, Mr. Jamsa, for further clarify the point. With this, unfortunately, I need to end this question and answer session because it's only 1 minute to the next session. Thanks the invited speaker for this morning, for them, and for very interesting presentation. And with this, I would like to pass back this session to the MC. Thank you, everyone.
Thank you. Just a note to thank you, Miss Annie, for your excellent job on facilitating these sessions. As always, you were impressively well prepared and extremely professional in the way you kept us all at the height of our attention throughout the session, pretty late in the afternoon yesterday and this early morning as well. Thank you as well to all presenters for these sessions, Dr. Jansah Mokhtar, Dr. Mohammad Saifu, and dear friend of mine from Sabah, Madam Yani Japaruddin, as well Dr. Elamaran Jayamani. Distinguished participants, ladies and gentlemen, before moving on to the next sessions on genetic and breeding, let me briefly introduce the moderator for these sessions. Associate Professor Dr. Ong Ken Huat have been with University Putra Malaysia, Bintulu Campus, Sarawak, for the past 18 years at the Department of Forestry, Faculty of Agricultural Science and Forestry, University Putra Malaysia. His research interests includes forest restorations, silviculture, and tree growth and yield. Please let us welcome Dr. Ong Ken Huat.
Thank you very much, our MC for this morning. Welcome to the conference again. I was informed actually this morning I will be actually moderating or the session chair for 5 speakers. Can I actually change a little bit the way this session will be run? Right after the presentation of each presenter, I will actually invite the audience to post questions or directly raise hand and ask questions. Then it will be faster and it will not accumulate until the end of the session at the noon time. Then if any of the presenter have to leave early because of the time difference between Malaysia and other countries, then it's easy for them. So again, I would like to remind all the presenter, although it's allocated 20 minutes, but with the introduction of yourself by me and also the technical difficulty probably will face. So can you limit your presentation to 15 minutes? I will remind you when the time comes, 3 minutes before the end of your presentation, so that you can write up your presentation early. So the first presenter will actually Dr. R.I. Arif Nisat Manto from Indonesia. He's currently a senior researcher at the Center of Forest Biotechnology and Tree Improvement. He was born in East Java in 1968, doing a lot of research on tree breeding, especially acacia and eucalyptus. 1994 until today. He got the master and doctorate degree of tree genetic and breeding from Kyushu University, Japan in 2002 and 2005 respectively. Published a lot of peer-reviewed papers in different journals. Until today, he already achieved 8 registered variety and 4 granted variety of plant protection variety for acacia and eucalyptus species. Active in many international collaboration projects. Recently, he got award from Innovation Award from the Ministry of Environment and Forestry Indonesia for the Innovative Researcher category in 2019. This morning, his paper will be on the genetic and breeding of tropical acacia in Indonesia. He will share about the challenges and rules for breeding strategy. Arif, the floor is yours. Thank you.
Okay, thank you very much. Can you hear me, Mr. Moderator? Hello? Can you hear me?
Yes. But it's echo. Somebody is actually open to.
No, I would like to share my presentation. Okay, can we start? Okay, thank you very much, Mr. Chairman. Yeah, it is an honor for me to be one of the speakers.
Are you opening two devices at one time?
Oh yeah. The one device for the backup only. Okay. Okay, that's okay.
Now okay.
Okay, thank you very much. Thank you very much, Mr. Chairman. And it is an honor for me to be one of the speakers in this IUFRO conference. And again, I would like to thank also for the organizing committee for inviting me as a speaker in this conference. Yeah, actually, I will already send a video for this presentation just for backup in case I have problem or technical issue during my presentation. Okay, yeah, the topic that I would like to talk today is about the genetic and breeding of tropical acacia in Indonesia, the notes of challenge and redesigning of breeding strategy. And before I start to talk, I would like to emphasize that the most of topic that I would like to present today is coming from our experience during more than 25 years in breeding of genetic and breeding of acacia practiced by Center of Forest Biotechnology in Indonesia. And yeah, this is the outline of our presentation. Yes, I would like to briefly introducing acacia species in Indonesia and the role of genetic and breeding on the productivity acacias and the challenges of genetic and breeding for sustainability acacia plantation and the approach in redesigning of genetic and breeding for acacias and our proposed redesigning breeding strategy and some additional information about the improved stand in the invasiveness issue and finally the conclusion. Okay, this is the briefly of the introduction of acacia species in Indonesia. Then there are three species that have been widely planted in Indonesia: Gasia mangium, Gasia crassicarpa, and Acacia altiformis. It is for the three main end products: pulp and paper, sawn timber, and biomass. And the species and site regime for this plantation is mostly in the dry land, about more than 65%. It's dominated by mangium plantation and small area for Acacia altiformis. But for the peatland area, fully dominated by the Acacia crassicarpa. And you can see in this map, it is historically of introducing Acacia species in Indonesia. It's coming from natural distribution in eastern part of Indonesia, like Papua, Papua New Guinea, and also northern part of Queensland, Australia, that introduced the plantation in the western part of Indonesia, including Sumatra Islands, Kalimantan Islands, and Java Islands. But recently, there are also some plantation established in Papua Island. And from the beginning of our genetic and breeding practice, we already explore and use more than 1,000 individual seed lot covering the 4 species of Acacia. And this is the genetic improvement framework for Acacia species practiced by CFBDI. They mostly be constant to the breeding population establishment, such as progeny trial, hybridization, and clonal tests, which is supported by many various activities like molecular marker, disease resistant, tissue culture with property, and many other activities. And this is, for example, our target of improvement for the Acacia, for PAL, that we would like to improve the growth and also good property to achieve the wood consumption about 3.5 to 4 meter cubic woods to producing 1 ton pulp. And this is the existing breeding strategy applied in Indonesia and also in most of the breeding system for Acacia. That basically, we use recurrent selection system. That's by using sublining system management. And we have set up about 4 to 5 sublining for the Acacia. And from this breeding system, some evidence and improved growth productivity has been realized. Based on provenance base, about the 20% of improvement, and also for seed orchard base across the 3 generations of breeding, there's average about a 5 to 10% improvement per generation. And also we already developed the interspecies hybridization between Acacia mendium and Acacia coriformis, which is promising productivity. There's about 70% overall than our second generation Acacia mendium. And as introduction by the chairman, that this year, the government in Indonesia has granted a plant protection variety for our Acacia hybrids. And this is the successive improvement from the breeding, from the first generation to the third generation. That we improved the single seam in the fifth generation, and we add some good strictness from the second generation. And we also add some the high wood density in the third generation. It takes about 2 to 12 12 years breeding process to complete this successive of improvement. But only breeding selection could be potentially applied to make a shorter of the breeding process. And constant to the decreasing of genetic resources for Acacia, we try establishing mixed generation breeding population. It's quite promising because we get some information from this trial about the growth. The founder's family coming from F0 is not always poor as compared to those from F1 and F2 generation. And some of them showing more productive in some case. And we already calculated in the final of selection that 15% of the top 20 families rank is coming from the founder's family. And you can see in this chart, we refer as a third generation plus, and you can see the growth from 1 year, 2 years, 3 years, and 4 years. And from this trial also, we try to get connectivity between the growth and wood property. There's improving growth and form trait that has been practiced in the first and second generation, provided a better wood density than unimproved one. But the successive improvement on DPH from F1 to F2 generation has reduced the relative increase of wood density by more than 50%. It must be constant on this wood property. So changing the selection criteria for our next breeding population is necessary by incorporating wood density and a broader genetic diversity in further successive generation of breeding. And to validation of our improvement, we already established a genetic gain trial in several sites. And we can get some information from this trial that about genetic environment interaction. For example, as has been reported in many studies that family by site interaction is significant for Acacia mendium. But in this trial, we verified that in the seed source level, seed source by site interaction is not significant. it means that the deployment of seed can be worldwide. And the other observation is about the connectivity between the intensity of selection that has been practiced during the breeding to the tree stand density. Then we get some result that's improved seed that has been produced from low intensity of selection was less tolerant to the inter-tree competition. But improved seed that has been produced from the high intensity of selection seed orchard, there's more tolerant to the inter-tree competition, and you can see in this chart. And in case of Acacia argyliformis, yes, now we enter with the second generation of breeding, and improvement is a little bit lower than the Acacia mangium, that about 4 to 6% of genetic gain. But in the second generation breeding, concerned to the sound timber purposes, we try to put some additional observation in the breeding population to access the family by tree density interaction. And you can see that the very density we tested in this breeding population. And for Acacia hybridization, the Acacia hybrid with the mangium and Acacia argyliformis, that we already improved the growth that I mentioned just before, but the 70% or higher than our second generation mangium. But we also observed about the potential of pulp property. There's some of clone that we already tested. The wood consumption is around 3.5 to 4 meter cubic wood for per ton pulp. Not only pulp property, but we also already observed about the potential dissolving pulp property. That the Acacia hybrid has good potential for dissolving pulp property. And one important point for this Acacia hybridization is related to the wood property, about the male and female effect on the two species. For example, if we use mangium as a male, so it tends to dominate the fiber dimension of the Acacia hybrid. I think this is quite good information to make some crossing between the mangium and Acacia argyliformis. And for Acacia tricarpa, it is much linear with Acacia argyliformis that estimated genetic gain in second generation is around 4%, 5%. But another attention from this Acacia tricarpa is how to optimize the side breeding testing and side plantation regime. I mean that breeding practice will be established in the dry land, but improved seed in Indonesia will be used for peatland. So it is a kind of thing to be considered for Acacia tricarpa breeding. And this is the challenges of genetic and breeding to the sustainability of Acacia plantation. And we note some challenges. First, for example, the pest and disease, as I've been presented by presenter yesterday also, that's particularly for serotoxis attack. And during the last 5 years under the Asia project, we already got a tolerant stock of Acacia mangium to ceratocystis, and you can see in this picture. This is not only tolerant, but it's also showing superior growth. That is quite a good chance for us to use this clone to be further deployed. But one more important point that we challenge is that maybe there is a genetic by isolates interaction, because we CFBTI already share the same genetic material to 3 partner companies to be inoculated by their own isolates. But as a result, there is an inconsistent of the genetic for the tolerance for those ceratocystis. I think this could challenge for the next program. We have to deploy the tolerance clone and to be comprehensively inoculated by the partner by using various of isolates. And another challenge is about the site regime, is particularly from the cycle of rotation harvesting. And in the peatland, from the groundwater level, that the new regulation now the groundwater level about the 40 centimeters. It's quite difficult for Brassicarpa to be grows well. And also the changing of climate change, because now we also that the very and there's big problem from the flowering of our acacia, maybe due to the climate change, less abundant of flower. and less random mating that opposed from the aborted of seeds, and the seed production must reduce recently. And also changes in the industrial manufacturing, and like green industry, circularity, and of a volume to value perspective that need for us for improving wood property and pulp property besides the growth. And the important also big challenge is about the natural genetic resources, because we have calculated that genetic resources for acacia has decreased, continuously decrease. But at the same time, we have diverse of trait to be genetically improved, because we have many challenges and problems. And the last is about the evasiveness issue. I think sometimes it's also become a problem for acacia planting. And this is the approach in redesigning of genetic and breeding for acacias. We note some justification for this approach. The first one is about the limitation of genetic resources, but the high and diverse and challenging phase now. And the limitation in genetic resources due to forest fragmented, especially on the natural distribution, it's quite difficult now to get genetic resources for acacia. And another one is an ineffective experimental design in the breeding population, dealing with saving genetic resources. And another, the impact of various of genetic and farm interaction also. And some adverse correlation among the growth, the property, and flora. And compromising among the survival rate, length of rotation, stand growth, wood property, and manufacturing and product. And this is an evidence that we've found during the breeding beds. Genetic and environmental interaction should be translated on the genetic level and family by-side interaction for it. It's significant for acacia. And significant also for family by tree density for crude shade. And this is our new finding, that there is a significant family by generation of breeding interaction for the crude shade. And you can see in this chart that this is the effect of breeding seedling orchard that we adopted now. There's the spacing is changes from the beginning to the final family selection. In the family selection, the spacing is much larger. As a result, improved seed can be maybe less productive if you plant it in the real spacing of plantation, very narrow spacing. And another important point is reducing of genetic resources. As I mentioned just before, the important point is the breeding seedling seed orchard. This three function for progeny testing, for seed orchard, for genetic base, but the critical activities in this breeding seed orchard about the selection and thinning. And according to our experience, there's more than 75 genetic resources lost during the thinning and removing unspecific genotypes. I think this seems to be a drawback of the breeding seedling orchard system. And how to solve this? Yes?
I think 3 more minutes.
Okay. I would like to speed up. This is our proposed breeding strategy. That's we propose the breeding population with no thinning to keep the sustainability of all genetic materials used in this breeding population. And you can see in this table, there's a comparison between our proposed strategy using seedling seed orchard base and the existing comparison breeding seedling orchard base. And you can see that in the breeding CSO base, BSO base, progeny trial is the first priority. Then after thinning converts to the seed orchard. But in our proposed strategy, as SO base, the first priority is seed orchard establishment that can be used to get information for progeny testing. But no thinning, this is important point. There is no thinning for our proposed concept. And this is some merits of the proposed strategy. And it's a double layer of progeny trial. It means there's connectivity between the grandparent and the grandchild. And also assessing based on the realized performance rather than predicted one. The flexibility in the experimental design, more simple in population management, more applicable in the case of a difference between the breeding testing and site of plantation, and also saving more genetic material and more genetic gain per genetic trial. And to support this SSO-based our proposed strategy, we use a single tripod configuration rather than multiple tripod. It is the flexibility of single tripod configuration that we can reserve post-blocking, and we can get accurate genetic parameter less thinning, and also efficient in use of genetic material, more selected trees, more seed production, and more saving genetic material. And we already simulated about the comparison between single tree plot and multi-tree plot. And the result that single tree plot can get 25 to 30 percent gain more than the multi-plot tree plot. And this is our last purpose strategy that to support the SSO base, we use the recycled genetic resources. We call it a mixed generation breeding population. So we can recall again our grand founders families. And but to support this the recycled genetic resource, we have to keep the pedigree control to reduce the inbreeding incident. And it is our another topic that's improved stand productivity related to the invasive nature. The point is that genetic inbreeding can limit the invasiveness issue because we can improve the growth. By improving the growth, so we can harvesting more earlier before reproductive phase appear. Another one, we can use management and spacing, spacing to all the canopy closure, to increasing implicit, and also some breeding. And it is our conclusion. In the past, the genetic and breeding practice have provided a significant role in the increased stand productivity for acacia plantation. However, the productivity would be meaningless due to current serious threat dealing with pest and disease attack and some limitation of the environment, such as wetland regime and the changes of perspective in manufacturing of in product as well. And the risk of genetic resources combined with an effective breeding strategy will become one of the key solutions for overcoming the such challenges of acacia medium. Last, thought in a redesigning of breeding strategy for acacia is necessary could be approached through conservative breeding selection by considering of breeding with no thinning, assessing the realized of progeny performance rather than the predicted one from the parent performance, and optimizing the available genetic material with an effective experimental design for stimulating seed productivity. I think there also. Thank you very much, Mr. Chairman.
Thank you for keeping to the time, Arif. There is one question from Iko Hadiyanto in the chat. Lack of infection rate of cerotosis in the validation trial in Central Java for resistant clone selected in nursery, perhaps due to longer dry season in the region. What do you think?
Okay, I will repeat the lack of infection rates of characteristic in the validation trial in Central Java for resistant clone selected in nursery, perhaps due to longer. Yes, no, yeah. Our stand in tolerant from tolerant clone in Java is not for validation. Validation has been practiced in the Sumatra Island, in the real of plantation. What we also established in Central Java is just for clone bank. We collected so many clone tolerant in the clone bank for further use. So validation has been practiced in the real of plantation, not in Central Java. Thank you. Okay, thank you very much for the answer. There is the second question. Are you have conclusion if we plant another acacia at one? Sorry, yeah, from Budiman. I'm not too sure what is the questions at one peta. As for example, Acacia agricoliformis and Crassicapa result from seed. I'm not too sure what is the. You have conclusion if we plant another acacia at one peta or I could understand this question.
I don't understand the question. Okay, anyway, we move to the third question. I'll allow this one from Professor Winnie. Sorry. What are the operational challenges to your redesigning breeding strategy?
Okay, thank you, Prof. Vicky. Yes, Actually, our proposed breeding strategy, we already established some trial in our research station. So that's why we have such kind of proposed breeding strategy. This breeding should be more conservative, not as commonly applied, adopted today by the breeding seeded orchard and doing some thinning and some removing the aspiration type. This is because in the advanced generation breeding, thinning is almost not necessary in our breeding population, based on our observation. Because in the advanced generation breeding, variation within family is smaller and smaller. In the one plot, multiple tree plot, sometimes we observe that almost similar performance. But if using breeding seeded orchard, we have to remove another tree because we have to retain only one tree, the best one. So based on this observation that we propose that actually the current adopted breeding can be improved for more conservancy, because genetic resources is very important for challenges our future problem maybe. Thank you,
Okay.
Prof.
Thank you very much, Arif, for the more very informative presentation. So now we move to the second presenter, Dr. Nguyen. Let me read his this one CV first. It's from Dr. Nguyen Duc Kin is from Vietnam. Currently based currently his position is a director of the Institute of Forest Tree Improvement and Biotechnology. So he's obtained his PhD degree in forestry in 1997, Master of Biology in 2002, PhD in Biology from Swedish Institute of Agricultural Sciences in 2009. He has 24 years of working experience in forest genetics and tree breeding. Much of the work have been dedicated to genetic improvement of fast-growing tree species, domestications of native tree species, and deployment of improved genetic material to commercial plantation. He currently also the leader for Acacia Genetic Improvement Program in Vietnam, also involved in supervising a number of master and PhD students in Vietnam, and work as a consultant for forest companies in Vietnam and other countries in Southeast Asia. This presentation today is entitled Recent Advancements in Acacia Breeding and Deployment for Wood Production. Without further ado, I would like to invite Dr. Nguyen Duc Kin to present his presentation. Please, Doctor. We can't hear you. You mute. You unmute. Yes, thank you.
Yep. You can hear me?
Now, yes, please.
Yes. Can you see my slide?
Yes, we can. Please continue.
Yes, okay. Yes. So thank you, Mr. Chairman, and the organizing committee to invite me as a invited speaker to this conference. So the topic of my talk today is the recent advance in acacia breeding and deployment for wood production, and I present it on behalf of my colleague who worked in acacia breeding in the last 5 years with me. So the point we will cover in this talk is first about some information about pure species breeding, hybrid breeding, polyploid breeding, and some work on breeding for serotosis tolerance, some work on molecular genetics, and some comment on future research. Before going to talk on breeding, I would like to give you some background of acacia in Vietnam. So acacia plantation in Vietnam is now about more than 2 million hectares, mainly planted in the north and the central coast of Vietnam. And it's constituted by mainly 3 species: Acacia manzum, Acacia hybrid between the manzum and auriculiformis, and Acacia auriculiformis. And half of the plantation is managed by small farmers. And but most of the acacia genetic improvement in Vietnam is mainly performed by Vietnamese Academy of Forest Sciences since 1990. So the volume has been the most important selection criterion in our breeding program, because the farmers mostly sell the wood based on the standing volume basis. On the chip mill, they also buy the wood at mill gate on rintan basis, and the sawmill, they buy the wood on the gate. They grade the wood by diameter. Regarding our few species breeding, so the method we are using now is recurrent selection for germ combining ability in open pollinated breeding population. So while we started with progeny giant of around 100 families from known bed provenance in Papua New Guinea and Australia, and within that progeny child, we tend to remove the worst family and inferior tree within the remaining family. So we select the best tree from wood family to collect the seed for next cycle breeding. And we are now under the 3rd breeding cycle of all 3 species. And because we are going to advanced generation, so maintaining the pedigree information is very important to minimize the level of related needs. So in our institute, we already set up the pedigree recording system for our main planting species. So we can check on the pedigree from the 3rd generation check back to the 4th generation, so we can minimize the level of related needs in our population. So according to our study, we found that most of our traits are under moderate to high heritability, whereas the basic density has a higher density, a higher heritability compared to growth and disease tolerant character. So our breeding program, we have greatly improved the volume production, but also we improved the stem form and brand form of our acacia. Especially, we can see in the picture where you can find that our Acacia brascapa and selected clone of auriculiformis has very straight stem and small branch. Regarding acacia hybrids, so in Vietnam, we've been successful with acacia hybrid breeding, where we started the acacia hybrid breeding in about nearly 30 years ago. And up to now, we already selected about 20 clones approved, but among 10 of them are used widely. And most of the hybrid we are using now is from natural hybrid. And we are using the tissue culture planted initiated from axillary buds from young sapling to be used as a head for cutting propagation. And that's why we can maintain the juvenility of the very old from clones selected about more than 20 years ago, but still maintain the juvenility and growth. And with the development of tissue culture technology, now people also start using the tissue culture plantlet directly for plantation. We are employing 4 selection and breeding method for acacia hybrids. From the beginning, we started with selection of Acacia hybrids from Plantation or from progeny child. In the second generation, we started with the set up the hybridizing orchard where we planted the wood clone of Acacia manzum and Acacia auriculiformis in the hybridizing orchard, and we collect the seed. And from in the seed, we sow in nursery and we select the hybrid seedling based on the morphology character. We also work on controlled pollination, and the new method we are start applying is a synthetic population, breeding population. So as we start going to the advanced generation of hybrid, we found that we can increase the growth of the newly selected clone of Acacia hybrid is better than the previously selected clone in so we can increase the growth rate of new Acacia hybrid now. The controlled pollination is it's not the main method of breeding.
Genetics, yeah.
But we use it as an amendment to putative hybrid, because when we found out that the reciprocal effects are not so important, and we can because if we let the species in the population, some parent chief could not contribute to the hybrid population. So controlled pollination can be used to consider as an option to increase the pest and disease tolerance, and also controlled pollination is very essential for polyploid breeding. So in the last 5 years, we started our polyploid breeding since nearly 20 years ago, and in the last 5 years we have achieved some great success in chiploid breeding program, where we have selected some very good clone of Acacia, chiploid Acacia hybrid, where the cross between the tetraploid Acacia manzum and diploid auriculiformis, and we found that we can increase the growth rate, but also we can increase the fiber length and reduces fertility. So you can see here, we have compared the fiber length of two Acacia, chiploid Acacia hybrid, and the fiber length of two Acacia diploid hybrid, Acacia hybrid. You can see that the fiber length of the chiploid is significantly longer than the diploid. And also the chiploid, when we expect that when we have the chiploid, we expect that the chiploid would not produce any flower, but it's not. The chiploid still produce flower, but the pollen viability is very poor or no germination at all, and we can collected the seed from only one clone, one chiploid clone, compared with very low success with the high abortion rate. And when we sow the seed of chiploid in the nursery, we found that the growth rate of the progeny is very inferior compared to the diploid seedling, and most of the tree could not survive in the field for up to 6 months. And similar to other countries, the ceratophytes is now becoming important in Vietnam. So we also work on improving the ceratophyte tolerance. So we have performed some inoculation trial in Acacia auriculiformis and Acacia hybrid to select to rank the clone for ceratophyte attack, and we found that there is significant difference between clone in disease index, where we can then in this chain, we already selected some clones that are highly tolerant, and we planted them in the field, and we hope in the next few years we can find some clone of having a high tolerance in the field. We also realized that the Acacia auricularis is very good. Is the tolerated species, so we want to use them in as a parent in hybrid breeding. So we already inoculated 85 family in the nursery, and we estimate we measure the listen length in the percent of total height from 2 to 4 weeks after inoculation, and we found that the very big, large variation between family, and we can select the family of high tolerance for breeding purpose, especially in hybrid breeding. We also have performed some work on the genomic breeding. In the last year, we started with a population of 400 clones of Acacia hybrids, and we used genome-wide scanning, and we already determined few SNPs that are highly associated with diameter and height in Acacia hybrid. And similarly, we also have determined some SNPs that are highly correlated with the disease tolerance in Acacia hybrid. But we can understand that for genomic breeding, we will not use them directly for selection of best tree or best tree but we are using them to screen in the nursery and also to reduce the number of clones in the testing site. So the testing is very important. So this method can be used as an amendment to increase the efficiency of the selection process. So regarding the future research, as Arif also mentioned, that we lost the genetic variation in advanced generation. So we have to increase the genetic diversity, especially this is very important in the age of the disease emerging. So, but we also have to minimize the level of repeated needs in breeding, advanced breeding population. And I believe that the genome sequencing of some main species will be very important for specialists like Acacia manzum and Acacia auricularis, that to provide a better understanding for future research. For example, the genome editing. So, but this requires a lot of funding, and also the international cooperation. We also have to work on novel polyploid, so we can create some polyploid to change the proportion of parental species, so we can understand to enhance the size adaptation and also disease resistance of the chiploid, and also work with advanced generation hybrid. So we have been done a good job in creating the wood clone for planting, but deliver the best germplasm to small grower. We have not done the job. We are not very satisfied with this, because in the commercial plantation, so lots of farmers, they still use the plant.
Excuse me, Dr. Nguyen. Excuse me, Dr. Nguyen. You have another 2 minutes to finish the presentation.
Okay. Yes. So lots of farmers still use the Acacia manzum from plantation. So this did reduce the productivity. Also, the small nursery, they are maintaining the cloning heads for longer time, because we set up that we can use that clonal head for 3 years, then have to change to the new clonal head from using the tissue culture plant, but they still use for 5-7 years. So that also reduce the seedling, the cutting quality. And seedling price improved stock also remain a big issue because the loss of it costs a lot. And supply of new and improved germplasm also very limited now. So this all this problem, this requires the collective effort of breeder, government support, and policy, commerce industry, and farmer are needed. We need all to work to overcome this issue. So on this occasion, I would like to thank my Acacia breeding collaborator, especially in Vietnamese Academy of Forest Sciences, the scientists in CSIRO in Australia, and University of Tasmania, who have been working quite very closely with us in our work. And also we thank Asia for longer support, for nearly 30 years support in Acacia breeding, and with CSIRO for lots of support in the last 25 years. And also I thank the Ministry of Agriculture and Rural Development of Vietnam for supporting us in the nearly 30 years. So thank you very much.
Thank you very much, Dr. Nguyen. The presentation is very informative, just like Arif. Both presentations complement each other, sharing different experience in Indonesia and Vietnam. There is a question for you. Is it possible planting acacia in big pot, not in a field, to make it control pollination easier? In the question and answer chat, the question is it possible planting acacia in big pot, but not in a field, to make the control pollination easier? Can you answer that, Dr. Nguyen?
Yes, we have started. We already started some. We can call the clone bank in the like we call mobile seed orchard. But it doesn't work. It doesn't work. It works with eucalyptus, but we found out that it doesn't work with acacia. So, but I believe that technically we can do that. But I haven't seen any successful example in Vietnam or in other countries. Maybe some of my colleagues in Indonesia or Malaysia can have some comment, but we haven't. It was not successful in our case.
Okay, thank you very much, Dr. Nguyen. Any more question for our colleague, our presenter from Vietnam, Dukin? Any questions? If no, thank you very much, Dr. Nguyen, for your presentation. Now we move to the third presenter for today, for this session. The third presenter will be Dr. Jeremy Browner. He's from United States of America. Currently held the position of assistant professor. He's currently based in Department of Plant Pathology, University of Florida, since 2019, with the responsibility in research and extension on tree health genetic resources. His research program is focused on developing disease-tolerant tree crops, and the extension program delivers this variety to a wide range of stakeholders. He worked with forest and tree crop manager in Florida and abroad to develop resistant breed of trees. His presentation title will be on breeding resilient trees. Without further ado, Jeremy, the floor is yours.
Thank you. Can you see my screen? Is that okay?
Yes, yes.
Okay, great. Yeah, thank you. It's nice to see a lot of old friends and hear about the progress that's being made. Great to hear Arif and Ken's talks just then. Excellent work from both of them. So, yeah, I'm going to talk today about developing resilient forests. Things are changing. Not sure why there it is. So developing resilient forests, developing for me is about improving productivity of forests and how they can help regional economies. And research for development is part of that, trying to not only increase the productivity of large companies, land holdings, but smallholders, and improving livelihoods is an important goal for me. So resilience and our ability to adapt to climate change and pests and diseases, that's basically the heart of the talk today. We're talking about cooperation and its importance, and then moving into some changing environments and pest and disease threats. So cooperation, fairly key part to doing what we're doing nowadays, dealing with new pests and diseases as they come into the forests, and just dealing with climate as it changes, and different environments that we're interacting as we expand plantation resources. We can cooperate and pool our resources to be more cost effective and efficient, create more capable people, and expand how much information we can pull out of the trials that we can establish. So cooperation through our sharing of resources really can enhance the ability to develop resilient forests. And when you pull together big groups of people, we can prove the value of cooperation. Hundreds of dollars for a hectare of resistant /pine. Long time ago, that was an estimate that a large cooperative effort was able to make, and was part of my early master's work. So understanding the significance of disease resistance and resilience, that can be done with cooperative efforts, but very difficult to do by yourself in isolation. So cooperation, the public sector, the sort of communist approach, and the corporates and the capitalist approach, they're both excellent, and they both achieve gains. And I think it's much better when we merge them and we put them together into partnerships. So that provides the best of both worlds. And a lot of times that's facilitated by placing cooperative structures inside of academia. There's lots of university-based cooperatives that go way back in this part of the world, here in Florida and all across the US and other areas. But nonprofit organizations such as the Borneo Forestry Cooperative, the Tree Breeding Australia, CAMCOR, those are becoming more common, and people are working together to develop resilient plantations. So one of the reasons cooperation is so important, Arif was talking about the erosion of genetic resources. If you're one group trying to manage genetic resources and you're thinning and pushing for productivity, it's much harder to maintain all of your genetic resources. Whereas if you're cooperating with a large group of people, different trials will bring different families to the top, and we can have larger pools of genetic diversity that aren't eroded as quickly as we did with the rest of our commercial crops that are now, extremely non-diverse after lots of generations. We still have the large diverse gene pools with our forest trees, and I think cooperation will help us keep it that way. So an example of cooperation with CAMCOR, some work we did collaboratively with CSIRO, looking at trials across the world. They had a huge network, lots of people and companies working together. And once we have that network, we can pull data together from lots of trials with lots of environments and all the environmental data underneath, and use our information from one individual local trial to infer how things work across the planet. So, for example, changing productivity across a site, or temperature or water availability. Different species, different families will change in how they react to that environmental change. So you can look at one variable at a time, or part of my work has been trying to visualize how this all happens at once. So for eucalyptus, you can start to, or for this CAMCOR pine trial, you start to see which populations that they planted around the world are responding to which environmental variables. And the environmental variables are classified by the way that the different species are reacting. So you can put it all into one visualization, understand whether or not there's responsive or non-responsive, adaptive, non-adaptive populations, how similar they are in their response to the environmental variables, how they cluster, how they group, which ones are similar, and how they respond to change in temperature, rainfall. And the important thing here is not what any population is doing, it's how cooperation is what makes this possible. When you work together with lots of in different trials, you can experience lots of different environments. Then we can start to understand how different populations should be pushed across the landscape to improve productivity or to make more resilient populations. And again, this works, it's not just pine trees, it's wheat, eucalyptus, anything where you have large cooperative trial networks, you can start to understand how different temperature, rainfall, and the environmental variables work. And then we can start looking across species and understanding the basic physiological principles that underpin that. A lot of this was done a while back, trying to understand the genetic regulation of physiology, water stress specifically, a tool we were trying to build to understand when we could deploy eucalypts from nurseries. On the way along, we were able to predict photosynthetic rate and other functional traits of eucalyptus and use that to predict these physiological traits in seedlings that we were able to drought, experience abiotic stress, and use that to identify genetic parameters and down at a plant level, understand the physiology of how it changes. Then we'll have lots of genetic parameters that would not be very informative if they weren't pulled together from large populations. So understanding how things respond to hydration and wilts and how the different physiological attributes are changing, what the genetic regulation is, something that's interesting and useful for understanding how to respond to change in the environment as it's happening. We can start to see where there's stable families where photosynthesis doesn't change, it just continues through droughts, either where they crash when there's photosynthetic responses to water availability, changes in the amount of genetic variation and when you can start to select for response to drought. Although we have this information on little populations, again, without cooperation to put it out in the landscape and to put it into a forest and to understand how it reacts on a planet, we don't have much information. We understand seedling reactions, but understanding how it changes as we move across into different environments. The important thing is to have trials. So large trial networks, such as what's been established in Borneo over the past decade or so. Lots of native species, lots of exotic species, and lots of trials. Similar trials going across Sarawak with a similar group of people. So hopefully within the region where you are now, we can have some other options that are available for the industry. Yanni spoke about the trials that we planted, one of the first networks, Paleta progeny trials. Really good examples of people pulling together information from large amount of families, genetic diversity established across many sites to identify populations that are going to increase the productivity, exactly what Kien was talking about, focusing on volume and trying to produce more wood for people to produce better products. Out of this work, genetic resources that were established led to a PhD completion. Yanni's excellent presentation earlier today, characterizing wood properties. All stems from this really well-designed cooperative progeny trial network that was designed with Eucalyptus Paleta in mind. In cooperation, you can expand from one organization to another, completely disconnected breeding populations using some molecular markers or DNA work, such as what Kien was talking about. An alternative way to use that is to provide connectivity across disconnected populations. Being able to pull together information from Malaysia and Laos and Vietnam in the single prediction models, and then using some statistics with the models and the rest of the statistics to bring together the pedigree information that Ken was talking about as such as an important role, pulling that together with the marker data. And so combining bits of marker data with the whole pedigree to infer relationships across the population. So something that was done in Southeast Asia with lots of different organizations, and moving from pedigree to markers, we're then able to move from one population to another. So a couple of trials in Laos, connecting up to trials in Malaysia and Vietnam are possible once we have markers across the parents and some of the individuals within the populations. Then it's able to infer how things will do in different regions. And if some program in Malaysia, for example, has an issue, they can rely on what is in Vietnam and the resources that are available there and work out how to collaborate with kin and people in other countries to bring up the diversity back in the populations, or to identify individuals that are more responsive to certain environmental variables. So you can start to see where there's correlations that are really great in some cases, some pairs of trials in similar environments, and pretty average in other ones. But understanding those correlations and responses between trials that were completely disconnected in the past lets us understand what we will gain or lose when we start to move new populations in new environments. So a lot of this is covered in some recent work that we've done with Eucalyptus in Australia. But I think the focus in Southeast Asia, putting together some of these amazing genetic resources that we have, should be a nice way to collaborate cooperatively on tree improvement. So in summary, trial networks are required. Cooperation is key to making those trial networks come together. Yes, have to have diversity across those trials, and really have to understand the environments well. So understanding that physiological plasticity and how things respond at a plant level and scaling up to stands and regions in the States, I think that'll be one way that we can respond to the change in the environment that we're seeing now. So working together with other people to connect these collaborative trial networks will let us respond more rapidly when change occurs. So yes, this requires cooperation. So moving on from responding to environmental changes, responding to biotic challenges. So Ceratocystis, for example, running through and destroying all the acacia plantations that we worked so hard to develop. Yeah, the response was plant Eucalyptus. It's a great species, not a problem. But in Brazil, Ceratocystis is a large problem in Eucalyptus, and rust has been discovered in wet tropics, and sometimes Eucalyptus just dies. So not sure exactly what the perfect answer is, but again, genetic diversity, you can start to clone things like this. When you have major outbreaks, if you have diversity, something will be able to come through. And that's what we've been seeing with some of the screening that has been done in different places in Southeast Asia in response to Ceratocystis and other diseases that have raised their heads. So the initial work of getting everything together from an old ACR trial, all the genetic diversity we could find in Sabah, and screening and understanding protocols in large trees was a great initial start, and it led to an amazing collaboration with Fabi and the folks in Sabah Softwoods and the Borneo Forestry Cooperative, which I think is going to lead in time to some more resilient breeds of acacia. So while we can find trees, they aren't rare, but they do exist, and it takes a lot of screening and a lot of effort to identify them. Luckily, we had the expertise of Mike Wingfield and his excellent presentation the other day about how exactly we should be moving forward with this. Was great to hear there's progress. So within some work we're doing to try and short circuit the Ceratocystis system and race ahead to clone something quickly, screening young seedlings to find something we could rapidly propagate. Yeah, it wasn't really successful because of the time lags involved in developing enough cuttings of each one to recapture those clones to get them back out into the landscape at scale. But it did provide a screening of some sorts that identified some material that has now been centralized in see at BTI and Pakanto, Arif's programs. And now there is some material that is able to withstand natural and inoculation pressure in Sumatra. So it's well, it's not a perfect system in any means. It has been able to identify some material with huge amounts of effort. I think the effort that also went in, collaborated and coordinated with Vietnam as part of the ACR project was great. Some of the learnings we brought from each other was amazing. Able to work across Vietnam and Indonesia at the same time with experts, different species, and bringing the resources together was excellent. Trying to understand the accuracy, what we're losing by going to less and less direct measurements of canker growth in large trees, phylos to seedlings to saplings to field trials. I think it's been done really well in Vietnam, and understanding what we're not capturing by looking at seedlings or looking only in the field. There's great comparisons here. A lot of germplasm has come back and forth between Indonesia and Vietnam to try and bring both the program's germplasm resources back up. So yeah, it's been a great experience between the two organizations, and working towards larger field trials for full validation has been a great experience.
Excuse me, Jeremy. You have
Yes.
another 2 minutes to complete your presentation.
Perfect. So yeah, just part of the responding to biotic threats, disease resistance is important, and it has been integrated into many different programs. I think it's been really refreshing to see disease resistance breeding coming in to all the programs as part of a risk management strategy. So yeah, other people have talked about it much more eloquently than I have, but basically I think it's responding by having genetic diversity, accurate phenotyping systems, and an ability to go through large populations. I think that's the one way to respond to disease incursions. And the systems we've put together, well, I think it's the team and the people. They're well placed to solve some of these problems. So yeah, cooperation, it's important. Think alternatively, and look beyond your estate boundaries to understand what's coming at you and how you can respond. Genomic connectivity is a benefit and can be used to increase the range of environments you can look through. And yeah, diseases are a problem, and they're going to keep coming. So having these teams of people that are trained to deal with them is excellent. So it's important to maintain the genetic diversity so we can increase selection intensity and work together to develop resilient breeds. So thank you very much. And I'll leave the time for any questions.
Thank you for the very informative presentation, and highlight that actually to do research, we have to have collaborative work around the world to achieve better result. There is a question from Professor Vicky. Ideally, realistically, how many resistant or tolerant clones will be required at any one time in designated areas?
Well, it depends on how we deploy those clones. I think Vietnam's gotten away with some really amazing few clones for a long time. If we're deploying the seed from those clones, it's going to take a while till we can have that back on the landscape at scale. So yeah, if we had something coming through a system like Dr. Kin's tissue culture system, I'd be comfortable with 20 because we'd lose some. But yeah, there's no magic number. 100 would be great, but man, that's going to be hard to do. So yeah, 10,
agree with you.
20.
The second question from Doringo. Do you foresee that Eucalyptus paleta will be the better species than Acacia in the long run from economy and pest disease perspective?
I'm not sure. I think like Chris Harwood said, we need both. Which one's better depends on the site. Eucalyptus paleta currently is surviving well. Acacia mangium is not. The hybrids If we had consistent propagation systems like the ones you have, Doreen, tissue culture to get them out where they're not physiologically aged, I think the hybrids are the future for acacias, and they will have a great place. But until we can prove they're resistant to ceratocystis, yeah, difficulty seeing how they go on scale.
Okay, any more questions from to Jeremy? You joined us from US, is it?
Yeah, yes, I did.
I think you
Wait, midnight, just.
Thank you for joining us from US. Any question? Any more questions? If no, thank you very much, Jeremy. We move to the next speaker, Dr. Rogers Arnold. He is currently holding position as associate research scientist and also head of silviculture R&D at the China Eucalyptus Research Center, Chinese Academy of Forestry, and also Stora Enso Guangxi Forestry. He grew up in Australia, studied forestry as an undergraduate in Australia, then as a postgraduate, master and PhD in USA. He has worked in New Zealand, US, Chile, Australia, Sri Lanka, Malaysia, and China, with project experience in several other Southeast Asia countries. From the mid-1990s, he worked as a research scientist with CSIRO, Australia Tree Seed Center for 12 years, based in Canberra, Australia. In 2006, he moved to China to work with April Forestry China up to 2009, when he joined the China Academy of Forestry and with the China Eucalyptus Research Center in Xinjiang, Guangdong Province. In this year, he moved to Beihai, Guangxi Province and joined Stora Enso Guangxi Forestry to lead their R&D program on eucalyptus and acacia. Over the past 6 years, he also worked as part-time for Samlim company in Sarawak, Malaysia, advising them on R&D and plantation silviculture. Without further ado, the floor is yours, Rogers.
Oh, many thanks. It's really great to be able to participate. Here we go. So,
introduce. The title is A Tale of Two Genera, Exotic Acacia and Eucalyptus Species in China. Sorry for that.
Yeah, that's all right. So hopefully you can now see my screen. Okay.
Yeah,
yep.
We can.
Okay. So I'm going to talk about the very interesting story of the content, the history of eucalypt and acacia introduction, domestication here in China, and really the R&D and other factors, how this came about, and then leading into more recent developments, what's happening here, and a view to the future of both species. And it continues to unfold and be a fascinating story. And eucalypts have been arrived here in China well over 100 years now. It was in the late 1800s when they were introduced really as amenity trees. And then they were planted in various applications, but it wasn't until around the mid-1900s, around 1950s, that the first serious plantations started. And all the early plantations were based on seed. The photo in the middle on the right, you can see, is very typical what early plantations look like. But after a lot of R&D, the first clonal plantations were actually established in the 1980s. And once people saw the superiority of going to hybrids and clones, by the early 2000s, really most of the commercial plantations were then using hybrid clonal stock. And then by 2020, the total area of eucalypt plantations have increased to over 5 million.
Sorry, Roger. Can you share your slide again?
Share again. Okay.
Yeah, because your slide is actually hang. I think you have to share again.
Okay. Try again. How was that? Oh, now it's frozen on me.
Oh, yes, it's okay. Yes.
Okay.
Yes.
So now I'll go to the next one on acacias. Acacias have a similar history to that here in China, of eucalypts here in China, rather. The first Australian acacias, or exotic acacias, truly exotic, were introduced in about 1930s. And they were soon being planted for fuel wood, and then realised the potential to get tannins from Acacia mearnsii, or black wattle. And also from Auriculaformis became very popular here for planting by roads and around villages and houses, mainly for fuel wood and shade and protection. And then in the late 1980s, early 1900s, Acacia mearnsii, the black wattle, was promoted, and people were very optimistic about its potential for producing tannin from the bark, as well as fuel wood and pulpwood. And then with increasing interest in producing more pulpwood, there was also a lot of interest in the 1990s and early 2000s in acacias for producing these as tropical acacias, Acacia mangum, Acacia auriculaformis, and Acacia crassicarpa, for producing pulpwood in large plantations. And then some of the big international pulp and paper companies started planting acacias as well as eucalypts. But then in 2008, interesting events occurred. There was a very big cold snap here in southern China that damaged a lot of existing acacia plantations. And coinciding with this was the emergence of the veneer industry. This is, I'll go into this a bit more, but basically, and countless veneer mills started buying eucalypt, small size eucalypt logs to peel for veneer, and they weren't interested in acacia. I'll show you why in a minute. And so the interest in acacias has waned very much over the last 10, 20 years, but just in the last couple of years, there is now a lot of interest, very strong interest in planting Acacia melanoxylon, or blackwood, for its high quality timber. And looking at the actual R&D effort that has sustained this development of both genera. So there was a lot of investment in R&D by China and Australia. This is under collaborative R&D, development assistance work. And there are a number of big, well, primarily ACR supported collaborative projects between Australia and China. But for each of these projects, the Chinese government, they enabled institutes in China to leverage that investment and also get a lot of more investment from the Chinese government. So the R&D was really well supported. And Australia very generously provided a lot of seed lots, research seed lots, more than 2,000 seed lots of over 100 taxa of acacia to include in trials and breeding programs here. And there was a very big area of acacia trials planted across southern China, a big network, including both tropical as well as some of the, well, subtropical temperate acacias. And you can see here on the right now, this is a 5-year-old stand of Acacia melanoxylon, looking quite impressive what they've achieved by doing a bit of clonal selection with Acacia melanoxylon. Now, the effort on eucalypts was very similar, really starting from 1978. There were more than 16 collaborative Chinese-Australian projects, major projects on breeding and silviculture and wood properties. And again, very substantial Chinese investment over this period on R&D and domestication of eucalypts. And Australia provided thousands and thousands of research seed lots to go into these in various trials and breeding populations. And that has provided a fantastic base up till today, where China is really very well endowed with eucalypt breeding populations and genetic diversity in their breeding populations of many species. And you can see the transformation from their early plantations to nice hybrid clonal plantations has been quite spectacular. And in eucalypts, not only the visual appearance, but the transformation in productivity, especially during the 1990s, I went from these old seed-based plantations of maybe inappropriate species, but when they went to hybrid clones, as well as improved fertilizer practice, it led to a very marked increase in productivity. And then since then, there have been increases in productivity, but also, I suppose, the variation in productivity, which is not shown here, has also increased. And it must be stated that even over recent years, the ongoing success really has been very fortunate. The Chinese government has been very supportive of forestry R&D, and this is going to research institutes and universities to enable them to continue their work. So very good basis for the R&D. And the outcome of all these efforts to date, you can see on the left, eucalypt plantations have increased very quickly in the last 15, 20 years, now up to 5.4 million hectares. Really a major resource and a major industry dependent on this. And acacias, it's much harder to get data on acacia plantations, hence the scatter of data points, because they're not very well counted in the National Forest Resource Inventory. But it has certainly seemed to have declined over the last 10 years or so, with an exception of maybe the last 2 or 3 years, because people, they've lost out for various reasons, which I'll go into in a minute. And just to show you where this substantial resource of eucalypts is, so I'm based in Guangxi, dark green down the bottom, and Guangxi has almost half of China's eucalypt plantations. So it's a real center for plantation eucalypts and the industries processing the wood that they get from them. And also some of the other coastal plantations, Guangdong, Fujian, on Hainan, have substantial areas, as well as inland Yunnan. And the factors that have led to this increase in eucalypt plantations really have been that there has been huge demand for wood by the Chinese economy of all species, of all genera. So you can see in this graph that domestic production, while China produces a lot of wood, it's nowhere near enough. And the total imports are much greater than the domestic production. So more than half of China's wood requirement relies on imports. So any log you produce in China can find a ready market. But as well as the demand for wood fueling the growth in eucalypt plantations, there has also been reasonably good state policies. The government has been encouraging development of plantations and plantation industries. Now, I've already mentioned that there has been very good scientific support with very good funding to state R&D institutions and universities for doing R&D. And most importantly, has been very good prices for the logs, eucalypt logs coming out of plantations. And up till about 2005, the main market for eucalypt logs really was pulpwood. China had quite a significant export market, or exported a lot of eucalypt wood chips to Korea, to Japan, primarily. And it was seen as a very good revenue source and really a very good market for eucalypt growers. And this provided some market pull. But then beyond 2005, the same logs became highly sought after to produce veneer. These are logs as small as 6 centimeters. Without changing the silviculture or the species, these mills started buying up what was previously pulpwood, and they started paying much higher prices than those producing export wood chips would pay. And as you can see here, so small diameter logs started fetching very high prices at local veneer mills, which sprung up across the countryside. By some estimates, there are now more than 20,000 small veneer mills just producing air-dried veneer scattered across southern China, and particularly here in Guangxi. And this created a huge market pool for plantation growers, because you could grow eucalypts here on a 5 or 6 year rotation if you can deliver them to a local veneer mill and get over $100 for many of the logs per cubic meter. But the same veneer mills are not interested in acacia logs. And the reason for this is their inferior stem straightness. And just to provide an insight on this market for veneer logs, it is almost, well, it has almost been insatiable. And this is because the increased production and demand for plywood. So this shows the increase in engineered wood boards, most of which is plywood, over the time period from 1999 up to 2015. So in 2015, China produced 290 million cubic meters of wood panels or wood engineered boards, and that has increased further. It's now well over 300 million cubic meters per year. And a lot of this production has been fueled by China's enormous construction boom, that if you go past any construction project in China, you will see mountains of formwork ply or construction ply in use at these sites, because the primary method of construction in China here is concrete formwork. And this has created a huge demand for construction grade ply. But in all this, that's created a challenge for acacia, because typical acacia plantations, which have been established here with either moderately or unimproved stock essentially, have poor stem straightness. And the only value for logs from these is for basically pulpwood or for MDF feed. So their main market is really pulpwood. They've also suffered problems in coastal China with typhoons, the tropical acacias. We have very high frequency of typhoons in this area. Eucalypts and certainly some selected eucalypt clones have much better tolerance. Now, as soon as you go inland away from where you get typhoons, then they're subject to occasional cold and frost. Now, even though that is not insurmountable, it's been a deterrent to some growers and has been a real deterrent to them. And the big factor really limiting acacias also has been very limited availability of improved planting stock. At present in China, with the exception of now Acacia melanoxylon, there are no proven selected clones, and there is no seed orchard seed available. Despite the prior R&D effort, things got dropped and forgotten about. And unfortunately, the domestication and seed orchard programs were really let lapse and deteriorate to the point where we don't have improved stock available. So looking to the future, well, here in China, people, I always say my colleagues are very optimistic, and I think generally they have good reasons to be. This graph on the left shows the wood supply, again from domestic and imported wood. And as you can see, with imported wood, more than 100 million cubic meters of wood has to be imported into China every year. So if you can increase your plantation area and or productivity, there is ready market here for every log you can produce. And recently on the right, there is also very big optimism about the market for certain types of pulp and particularly paper board products. This shows the planned expansion of pulp capacity in China. As you can see in Guangxi, some companies are very optimistic, planning over 10 million to 14 million tons per year of pulp capacity. This is what is planned, and some of it is already under construction. So, as well as a very big market for veneer logs, there's going to be an increasing market for pulpwood from all sources.
Excuse me, Roger.
Demand keeps increasing. Yep.
You have one more minute.
Yep, I've just about finished. So there's a need, but there's a problem with acacias, we need to increase the diversity and start producing improved material, because a number of companies, Stora Enso, APP, have to plant some areas of acacia for various reasons, which I expand. But one of the big interests at the moment is really in acacia melanoxylon of the acacias. And you can see on the right, some very nice furniture made from 10-year-old acacia melanoxylon grown. And there are now improved clones of acacia melanoxylon available for purchase here. And that has been transformational. But we still need to increase in China in general, the investment in providing improved acacias. And that is now happening, I think. And just to wrap up, so there's a lot of information, a lot of detail about all this. And this really is just a very brief summary of 2 journal papers myself and co-authors have published on this subject last year in the International Journal of Forestry, or the International Forestry Review. And anyone wanting more information, I can recommend either of these, well, both of these papers. They both provide really interesting perspectives. Yes, and with that, I'd just like to finish and say many thanks to Sarawak Forestry for organising this excellent conference. Even though we can't meet in person, it's still great to be able to share information and see many old friends.
Thank you very much, Roger, for the very informative presentation. Any questions from the audience? If none, actually, I will ask one question. What do you foresee for the acacia species in China? The perspective of it, since that although research has been done for numbers of years, but now their performance is not so good.
Yes, I think they have a very bright future as complements to eucalypts, because here in China, many companies have an obligation to plant some of their estate with non-eucalypts.
Oh.
So 20% for Stora Enso, we have to have 20% of our estate in species other than eucalyptus. And the best alternative to eucalyptus for many reasons is acacia. And so, yes, there's really big demand, and there's, for various other reasons, there are other people interested in planting melanoxylon or blackwood to produce high quality timber. Yeah, so I think acacias will have an increasing role and be increasingly important so long as we can provide people with improved planting stock.
Okay, thank you. Next question from Enya at the chat. You have been working in Sarawak as well. What do you see the prospect of eucalyptus here in Sarawak?
Well, the prospect is I think the prospect is very bright, but it still needs a lot more R&D, a very sustained effort. So we have really highly, good improved material, and we understand the silviculture better, because the challenge in Sarawak is the very high rainfall, which leads to very prolific weed growth. We have to be able to control the weeds, and we have to really understand the fertilizer requirements. But get it right, that was the big thing in China that led to improved productivity. It was both a combination of improved silviculture and improved germplasm together. And that work was done back in the 1980s and has been ongoing since then. But yeah, it was a key to having those two together, not just focusing on genetics or silviculture. They have to go hand in hand.
Okay, any more questions from audience? If none, thank you very much, Roger, for very informative presentations. I believe that there will be more questions probably at the chat. Probably later you can chat and also reply to them. Thank you very much.
Okay, thanks.
We move to the final presenter this, not morning, now it's noontime. It's actually from India, Dr. Maheshwar Pesh is currently based in the Arid Forest Research Institute, Jaipur, Rajasthan, India, working as a scientist. So previously he worked as at the Institute of Forest Genetic and Tree Breeding for 20 years before moving to the current institution, which is Arid Forest Research Institute. During the last 23 years, he been working on genetic improvement of various forestry species, and also developed first and second generation seed orchard for Acacia auricaiformis and Acacia mangian. So far, he has been published a lot of research articles in the International Journal and also co-authored a few books. So without further ado, Dr. Ash, the floor is yours.
Yeah. Good morning to everybody. Thank you for a nice introduction. Excuse me. Yeah. Yeah, my slides are not clearly visible.
Yes. Please.
Yeah. One minute. Sorry.
Yes.
Yeah. My topic is variation in growth rates and wood density among 14-year-old Acacia mangium hardship families. This work was carried out when I was there in the Institute of Forest Genetics and Tree Breeding at Coimbatore. At the outset, I thank the organizers of this conference, the Forest Department of Sarawak, Malaysia, and IUFRO, for giving me an opportunity to present this work in front of august audience of the international research community. The next slide, please. Yeah. The Acacia mangium, of course, it is one of the fastest growing species among the tropical tree species native to Australia, Papua New Guinea, and Indonesia. But it was introduced to India in the early 1980s by one Archbishop Gregorius of Trivandrum. He brought a few seeds from maybe Australia and planted in his backyard. By seeing the fast growth, people got attracted and farmers started growing it. And there was a huge demand for the seeds during 1990s. From this limited introduction, the mangium spread to the farmland. They started growing in the as a pure crop as well as along with the other crops also. And there was a lot of interest among the farmers. But later, this present that kind of interest is not there among the farmers due to various reasons. Coming to the use of this Acacia mangium, in other countries it is being used for paper, fuel wood, building, for furniture, and also particle boards. But in India, it is being used only for pulpwood, currently at 6 to 7 years rotation, mostly by paper mills, the forest government departments, forest development corporations, and forest departments in high rainfall areas, especially Kerala, Karnataka, and northeastern states. These two states, Western Ghat and other northeastern states. And the early introduction was sourced from very few, maybe few trees, maybe 1 or 2 trees. And it was the early cultivation was from these few introductions. But later, the government agencies like institutes like IUFRO, then Mysore Paper Mill started the provenance trials. And Institute of Forest Genetics and Tree Breeding at Coimbatore also started a comprehensive tree improvement program of this mangium during 1997. They received some 80 families, seed lots from the ATSC, Australia, CSIRO, with the assistance of World Bank project funding. And it is used as the base population, and it was converted into SSO, and seeds started supplying from this trials. Next one. Next slide, please. Coming to the Acacia mangium planting region, it is not planted throughout India, and it is planted in the Western Ghat region, especially the west coast and the hill areas of Western Ghat up to Maharashtra. And one more reason is the Middle East, that is the Orissa, West Bengal, Bihar, part of Bihar and part of Madhya Pradesh. it is the central region, and the northeastern region. These regions, they receive more than 1,000 mm rainfall, and maybe soil also is suited to the cultivation of Acacia meyngium. Mostly these are the states: Kerala, Tamil Nadu, Karnataka, Maharashtra, Orissa, Jharkhand. These are the states where these Australian acacias are being grown. But as such, Acacia meyngium is grown only in Kerala, Karnataka, Orissa, and also some northeastern region. In other region, maybe the soil may not be suited, and the rainfall is low, dry region, so it is not suited to acacias. But in some parts of Tamil Nadu, that is the east coast, Acacia auricularis is being grown, but not Acacia meyngium, and even Gujarat also on the western side. But Acacia meyngium is not grown because maybe the soil is not suited, and also the low rainfall areas. Next one, please. Next slide, please. Yeah, this the seedlot supplied by the ATSC Australia during 1997. It consisted of 72 families, which were from natural populations across Australia, PNG, Indonesia, and Indonesia, and also it consisted of superior trees selected in SSO, seedling seed orchards established in several countries, and these seedlots were supplied by the CSIRO. So it was of a broad genetic base, and also some already some kind of improvement which has taken place in other countries. That advantage was there in these seedlots. And these seedlots were planted in 2 locations. There is a Karunya, that's in Tamil Nadu, and another one is Nilambur in southern India during 1997. These families were evaluated for growth traits at 14 years of age, that's 2011. And wood density also we have taken for evaluation, because earlier our observations revealed that there is some relationship between wood density and the heart rot, because Acacia meyngium is highly prone to heart rot, where the tree looks very normal, but when you cut the trees or take the wood samples through the increment borers, you'll see inside the tree is hollow, and sometimes completely hollow, and it cannot be used at all. So there is high incidence of heart rot, especially in high rainfall areas in Acacia meyngium plantations. When we started taking the wood samples, what we found was the higher density trees were normal, and heart rot incidence was less. And also Acacia auricularis, which is having higher wood density, is relatively free from this heart rot incidence in these areas. Therefore, we thought if we try to see whether some families which have higher wood density, we can use it in the advanced generation seed orchard, where we can improve for the wood density, and which may reduce the heart rot incidence also, and even the for wood quantity also it may increase because of higher wood weightage. So the final objective of the study was to develop advanced generation seed orchard using the superior trees in the family, superior families, and also Provenance trials, and later establish the progeny trial, which can be converted into advanced generation SSO. Next one, please. Yeah, this is the details about the trial. The one trial was the Nilambur in Kerala, that is in the western side of the Kerala, where it is near to the coast. It consists of 71 families. The rainfall is around 2,500 mm, and it's a brown and low altitude, highly suited for the Acacia meyngium and brown loam area. And Karunya, that was consists of 79 families, and it is 1,000 or less mm rainfall. It's a little dry area, and the soil is also a little bit blackish clay. And of course, both the trials consist of fire application. 4 tree plot was there. And next one, please. Next slide, please. Yeah. Yeah. This is a seed lot details where CSIRO seed lot numbers are also given. And there were native single trees of 7 seed lots. It consists of Tule Mission, which is 4 seed lots, and others 1 or 2 seed lots. And SSO selections were maximum 54 seed lots were there of different SSOs. And the native bulk was 5 seed lots, each one from different provinces. And there were 2 controls. One was a local control. This is a Mysore paper mill. It's a local paper mill plantations they had. From that seed lot we had taken. And Acacia auriculaformis was also taken as the control to see how Acacia auriculaformis performs compared to the Mangium. And there were 3 Indonesian bulk, Seso bulk seed lots from the Indonesian. Yeah, total 71 seed lots were there. In Karunia, some of seed lots, 79 seed lots were there. And totally here, including the, yeah, next one, please. This is the mean performance of family trials at 14 years. You can clearly see the trials were measured for total height in meters and clear wall height, girth at the side, stem straightness that was measured into 1 to 5 scale qualitatively, and number of primary branches, mean survival, and wood density. Wood density we could measure only in one trial, because other trial there was a lot of damage and only 3 replications we could take in the Karunia. We could not take the wood density, and the data could not be analyzed, the wood density data, so we have taken only one, there's a Nilambur for wood density variation. Coming to the total height, you can see clearly in the dry area, it was just 12.71 meters at 14 years, but whereas in Nilambur, it was 34 meters mean height. And even the clear wall height also, and girth was also better in the Nilambur. And stem straightness was also a little better in the Nilambur, which is high rainfall. But the trees here in Karunia and drier areas, there is some problem of cell pruning, and they were more branchy. The branches were more, and the survival percentage was also better in Nilambur, almost 70%. Here it was around 50%. And wood density, the mean wood density was 0.19, and it ranged from 0.446 to 0.60, the highest being the Acacia auriculaformis. Next one, please. Yeah, with the nested analysis, the seed source. The seed source was used, 18 seed source, the mean, and we can clearly see some of the SSO selections of Kuranda from PNG, the Queensland, and one native bulk. The seed source comparatively better, and the SSO Kuranda and the Queensland, Kumawil, PNG, they also perform better in terms of clear ball height also. But Acacia auriculaformis, when it was planted along with the Mangium, maybe it could not compete with the Mangium during early growth, and performance was very poor compared to the Mangium and in this high rainfall area. But it had high wood density. And coming to wood density, as such, these Indonesian seed lots were having a better wood density, and also this one SSO selection from Kuranda, almost 0.56. And NPM, the local seed lot, was also having a better wood density, and Acacia auriculaformis was having around 0.6. And compared to the seed sources, overall performance of the SSO selections were better compared to the native bulk or native single trees or even the local seed lots. Next one, please. Yeah. The tule emission beach compared to the other seed sources, this tule emission beach Queensland was performing lower in all most of the characters. Yeah. Next one, please. This I already explained. Next one. Yeah. To see which seed lots performed among the 72 total, including the control. So the Kuranda PNG, most of the Kuranda PNG seed lots of 46 to 62 numbers, they were performing better, and we could shortlist some of the better seed lots here in this source. And among the native tree selections, only one seed lot, that was Kumawil, performed better. And for wood density, of course, the all 3 Indonesian bulk and also MPM performed better. And of course, Acacia acaciformis performance was poor. Next one. The next, another.
Excuse me, Dr. Hesh. You have another 2 minutes to complete your presentation.
Yeah, I will take 5 minutes. Yeah.
2 minutes, please.
Okay. In the Caronia, which is a drier areas, there was not much difference among the family statistically, but still the previous one, Nilambur, the SSO selection of Karunda was better. Next one, please. And Acacia acaciformis was performing better here in drier side compared to the Mangium. So, and here only for some straightness there was some statistical significance. Otherwise, most of the trees were in the dry area, but not much difference. But still, the Commonwealth PNG performance was better. Next one. Yeah, this is the heritability values. For total height, there was a moderate heritability 0.43, but for other characters, there was moderate 0.36, but whereas for wood density, there was only 0.29, which means that we have to take care of not only individual selection, also family mean while selecting the trees for wood density. Next one, please. Yeah, this is the in the Nilambur. Next one, please. Yeah, this we had taken the wood samples through the increment borers, and yeah, what are the displacement method we use for the wood density measurement. Next one, please. And this is the Caronia, where you can see the trees were branchy and some families were performing very poor in the dry side. Next slide, please. Yeah, I summarize this selection process where this main aim was to select the superior families for developing advanced generation seed orchard, and we were able to select some of the superior performing families. And for wood density is also some families we were able to select the seed lots, and overall performance was better. The Mangium performance was better at high rainfall area, not the low rainfall area, but Acacia acaciformis was performing better in the drier side. Next one. Yeah, we could for the next generation we could select some of the around 100 trees in these family trials, and also for comparison we did some few selection in the local plantations also around 28 trees, and progeny trial was raised of 125 trees in Paleta, which is high rainfall area, which was very much suited for Mangium growth. And here also up to 2 years we measured the growth traits and form traits. Here what we found that the SSO families which were performing better in Nilambur and Caronia, which were of ATC, CSIRO supplied seed lots, they were performing better, that pedigree, compared to these local selections. Next one, please. Yeah, this is the performance of the progeny trial, where we can clearly see the overall performance was better, and there was a good variation among the 125 families in the early growth traits, for early growth traits. Next one, and also form traits. Yeah, this is the heritability values. This heritability was moderate for most of the characters. Next one, please. Yeah, this is the second year growth. You can see some of the families were performing very good, that growth wise, also form wise. Next one.
Dr. Maheshwar, please complete your presentation.
Yeah. So through indirect, so using this histograph, we could measure the wood density in the family trial at 2 years age. And next one, please. And we could get good.
I need to stop you, Doctor. Sorry, Doctor. We are now running out of time.
Yeah. Thank you.
Any question to these presentations regarding the 14 years old provenient trial experiment from India. I allow one question because we actually over the time just now. Any questions on the floor? It's very interesting. He's actually doing testing a lot of different seed lot. Probably can work with other country like Vietnam, Indonesia, Malaysia, even in China. If no questions, thank you very much, Doctor. I'll pass back to our MC for today. Thank you.
Thank you.
Thank you so much, Dr. Ong. We will definitely see you again in the afternoon to continue our sessions on genetic and breeding. A special thanks and congratulations to all speakers of these sessions. It's good to see again Dr. Arif, Dr. Jeremy Bronner. Thank you to Dr. Ken, Dr. Roger Arnold, and Dr. Maheshwar. Ladies and gentlemen, we will be having our lunch break here, and we will see you again at 2 p.m. Malaysia, or about approximately 1 hour and 10 minutes from now. Thank you so much.
dekat memang.
Hello, Mohammad, how are you? Unmute, unmute. Unmute.
Sir, are you able to hear, sir?
Good morning.
Sir, how are you, sir?
Was it audible?
Yes, sir, it's audible, sir. How are you, sir?
Hello, you are not audible.
Sir, is it audible?
No.
It's not audible, sir.
Yeah, my presentation was audible.
Yes, sir, your presentation is audible, sir.
Ayla.
Hello சொன்னா கேட்பீங்களா?
பேசுங்க சார், கேட்குங்க உங்களுக்கு.
கமல்ஜி, கமல்ஜி, கமல் கேக்குதுங்களா?
SG, you're audible.
Okay, thank you.
Yes. See, finally we are meeting. Finally we are meeting.
Yes. Ekde sir just now spoken through this, but it's not audible. His voice is audible, but my written voice is not audible. That's only I want to check.
Oh, good. You are very well audible.
Now you are audible.
Sir, how are you, sir?
Fine.
Yes, sir.
Very nice.
உள்ள வந்துச்சு. உங்களுக்கு ஃபர்ஸ்ட் தேடி
கமல் சார் உங்க மைக் ஆன் இருக்கா?
எஸ்.
இருக்காங்களா?
யாரும் இல்ல, நான் மட்டும் தான் இருக்கேன்.
ஓகே.
என்னோட ரெண்டு ஐடி காமிக்கிடுச்சு, என்னன்னு தெரியல.
ரெண்டு டைம் லாகின் பண்றீங்களா?
இல்ல, லிங்க் வேற ஃபார்வர்ட் பண்ணீங்கன்னா அவர் நேம் இருக்கும்.
இல்ல வேற யாராவது பண்றாங்களா மட்டும்?
Yeah, it's gone now. It's there. Someone is muted also.
Belum. Fellow participants, ladies and gentlemen, I would like to apologize for the delay of 2 minutes. Sorry. We will now resume our sessions on genetic and breeding again. I would like to invite our good Dr. Ong to continue his role as the moderator for this session. Please, Dr. Ong.
Yeah, thank you very much, Ms. MC. Welcome back to our sessions. So our next speaker will be Dr. Annamalai Maavel from India. Allow me to read his CV. He's currently based in Institute of Forest Genetics and Tree Breeding in Tamil Nadu, India. His position is scientist. He's been involved in tree improvement program of Acacia auricaliformis and few other fast-growing species. He also developed high clones for enhancing productivity in farm industry, also associated with domestication of Casuarina clones in southern India. Without further ado, I would like to invite Dr. Maavel to present his presentation.
Am I audible, sir?
Yes.
Respected moderator, delegates, and scientific fraternity across the globe, ladies and gentlemen, good afternoon to one and all person here. First of all, I would like to thank the organizer to providing this opportunity to present the topic on evaluation of provenance of Acacia mangium for survival, early growth in Karnataka and southern India in this generous gathering. I have divided my presentation into 5 different subtopics. First, we will discuss about the introduction. In the introduction, we will see about the background of the demand and supply in India, as well as the importance of Acacia mangium in India. And subsequently, we will discuss about the international provenance trial program in different countries and materials and methods, result and conclusions. In introductions, India, one of the most important wood consuming country. The demand of the wood and wood-based product is increasing, particularly in the construction, furniture, wood panel, and paper industries. India alone having more than 800 paper mills. It is the wood requirement is expected to cross more than 40 million by 2030, with the annual growth percentage of 7 to 8%. Other wood industries like panel product, ply, particle boards also require 8 million cubic meter of wood, against which we are producing only 3.4 million cubic meter wood. The demand of the furniture industry also rising 12 to 15% annually. Our demand is 153 million meter cube wood, against which we are producing 88.7 million meter cube. We are still in the wood deficient country. We are importing the wood for our domestic needs and construction needs. In addition to the deficiencies, the higher population explosion, increasing income, urbanization, adopting Western culture, growth of the real industry, particularly in the modular kitchen, designing the wall, floor, wall and ceiling by the wood, and growth in the railway and defense sector, the government schemes like Housing for All 2020 and development of smart city, tourism, and consumption for the papers in the e-marketing also put additional pressures for the demand of the wood in India. So our national forest policy also emphasizes the wood-based industry. They have to depend on the raw material from the tree outside the forest. The Indian forest has a very low productivity when compared to the world average. There is a significant rise in the wood and wood for the industrial demand in 2050. So to meet this challenging situation, the short rotation forestry is the only viable solution to meet the emerging wood demand in the future. The growing of the trees in the farm forestry, in the block plantation, agroforestry is help us to meet the emerging demand in the country. It will also support the livelihood of the millions of the rural populations. Out of our wood productions, the maximum amount of the wood produced from the tree outside the forest, followed by import of the wood. So among the different species, Acacia is one of the most important fast-growing leguminous tree species native to Australia, Papua New Guinea. It is a potential agroforestry trees grown in the farmland and forest land. In Kerala, this is prevalent for growing the pepper in the Acacia mangium trees. In India, it is introduced in 1980 for the paper and pulp productions. In India, it is particularly cultivated in Kerala, Karnataka, Maharashtra, Odisha. More than 50,000 million hectares were cultivated until up to 2016. After 2016, some social and political issues, the area under the cultivation of Acacia mangum was reduced due to the various reasons. Still, the paper mills and Forest Development Corporation and Forest Department are also growing the Acacia mangum. So Acacia mangum has a very fast-growing tree species. It provides higher yield. It is the wood is used for furniture, paper, pulp, particle board, carving industries. It's a short rotation tree species. The pulp industries, you can harvest the trees within 4 to 5 years. The trees is very well suited for the acidic soil. The pH less than 4.5 also it can come. It will enrich the soil with adding the nutrients and fixing the soil nitrogens for improving the degraded soil. So considering the importance of this Acacia mangum, the Acacia breeding program at the Institute of Forest Genetics and Tree Breeding was implemented by my previous speaker, Dr. Hegde, was instrumental for the improvement of the tree breeding in Acacia mangum, in particular in the southern part of the country. He has run the systemized program in the country by receiving the seed lots. He already explained about this improvement program in India about Acacia mangum. He received the breeding population of 80 families from the CSIRO Australia, and subsequent thinning, we were established the first generation orchard. From the first generation orchard, we have also supplied the seeds to the stakeholder for improving the productivity. In subsequent thinning, we are also established the second generation orchards. From the second generation orchard up to 2006, we have supplied the seed to the various forest department and paper industries for meeting this establishing the plantations. So International Provincial Program was initiated by the Australian Tree Seed Center by CSIRO Australia. Due to the provinces already having the acacia growing conditions as highly affected by the Ganoderma and Saifu. So in order to enhance genetic base of this Acacia mangum breeding populations, the fresh infusion need to be included in the breeding populations. So CSIRO Australia has collected the new provenances from the original center of the origin and shared to the different country. India also is one of the partner for implementing the international Provincial program by CSIRO Australia. So with the seed lot received from the CSIRO Australia, we have conducted the studies to assess the variation in tree morphometric and the seedling characters of Acacia mangum, and to evaluate the new set of provenances for Acacia mangum for the survival, growth, and seeds. These are the seed lots were collected by the totally 16 seed lots were we have received from the CSIRO Australia, of which 14 has the very good germinations. This 14 seed lot we used for the studies. The seeds were collected from the different seedling seed orchard, seed production area, CSO, and natural populations. We have also collected the seeds from our Nilambur seedling seed orchards to compare the performance. These are the geographical locations of the seeds collected by the CSIRO. The seeds were raised in we have raised in the nursery in the model nursery of Institute of Forest Genetics and Tree Breeding Coimbatore, Tamil Nadu. About 600 seeds provenances, 600 seeds per provenance were sown in the polybag containing vermicompost, soil, and organic manure. We have observed the variations. We have recorded the variations by the seed characters such as seed area, seed length, seed perimeter, 100 seed weight. In seedling characters such as percentage of germination, seedling length, basal diameter, number of loads. These are the characters we have observed in the seeds and seedling traits. This is the establishing the nursery in the for raising the international provenance trial. So we have raised the international provenance trials in 2 different locations, one in Ramnagar, Karnataka, Uttar Karnataka. This area receives more than 2,800 mm of rainfall, with the temperature varies from 16 to 70 degrees Celsius. We are out with the row column designs. 15 provenances were planted in 4 replications at a 3 into 3 meter spacing. Each plots we have maintained the 16 tree plots. Each provenance we have maintained 16 tree plots. This is the present status of the international provenance trial at Uttar Karnataka. We have raised the second trial at Sakleshpur, Hassan district in Karnataka. Here also the temperatures varies from 17 to 35 degrees Celsius. We adopted the row column designs, and 15 provenances were planted in 4 replication at 3 into 3 meter spacing, and 16 tree plots were maintained. So this is the present status of the Acacia Mangium International Province Trial at Horsens. So we recorded the basal diameter, breast height, total height, number of branches, stem tightness, and branch diameter 2 years after planting. It's the yearly observations. So regarding the mean variation between the seed morphometric character, the seed area is varied from 0.08 to 0.18. Seed length is varied from ranged from 0.40 to 0.61 centimeter. Seed breadth is ranged from 0.26 to 0.38 centimeter. Perimeter of the seeds is ranged from 1.6 to 1.70 centimeter. Among the different seed lots, the Papua New Guinea natural province had the higher seed morphometric characters, whereas the germination percentage, higher germination percentage was recorded in the Queensland provinces. Regarding the seedling parameters, the percentage of germination is varied from 33.83 to 86.17. The average seedling height is ranged from 16.44 to 29.09. The basal diameter is ranged from 1.84 to 2.50 centimeter. The number of nodes also ranged from 3.40 to 5. So among the different provinces, the IFGTV SSO seedlings have the higher germination percentage, which is followed by the Papua New Guinea natural provinces. The average seedling height also higher height was recorded in Papua New Guinea natural provinces, and higher basal diameter also higher in Papua New Guinea. If the correlations, the seed area is positively correlated with the seed length, seed breadth, seed perimeter. The seed length is positively correlated with seed breadth and perimeter. Seed breadth is correlated with the seed perimeter. The survival percentage at the age of 24 months after planting in the two locations. The highest survival percentage was recorded in SSO originated from the SSO seed lots from IFGTP, 90.63%, which is followed by Papua New Guinea and Queensland provinces. Philippines seed lots collected from the Philippine SSO also had the higher percentage of survival in Uttar Kannada. Whereas in the Hosen, in the other location, the higher percentage of survival was recorded in the Queensland provinces, which is followed by the IUFRO provinces. So the basal diameter of among the different provinces in the first trial, the Uttar Kannada is varied from 11.6 to 15.4. The average GBH is varied from 21.28 to 15.84. The average total height is varied from 3.9 meter to 3.25 meter to 3.92 meter. So number of branches also varied from 9.90 to 14.5. The average stem straightness is varied from 3.3 to 4.5. The average branch diameter is varied from 3.6 to 4.5. So among the different provinces, the higher height was recorded in the IFGTP SSO originated seedling, which is followed by the Vietnam CSO. The second trial also similar trends was observed. It is varied from the basal diameter varies from 10.46 to 12.51, and the average GBH is ranged from 17.48 to 21.98 centimeter. Average height is ranged from 3.9 to 5.20 centimeter. The number of branches is ranged from 10.85 to 13.85. The stem tightness also similar trends, 4.0 to 4.73. This is the graphical representation of the growth parameters, the height and GBH in two different locations. In conclusion, there is a wide variations which occur on the seed morphometric characters. The highest germination percentage was recorded in the seedling seed orchard, first generation seedling seed orchard established by the IFGTP, followed by the Papua New Guinea natural provinces. The maximum plant survival rate was recorded in the CSO seed lots received from the CSO Vietnam, which is followed by the IFGTP SSOs. There is no statistical difference, significantly differences growth on the growth parameter in the early age. The early observation revealed that the seed lots received from the Vietnam CSO and IFGTP first generation seed orchard showed the commendable growth among the provinces in International Province Trial 1 and 2. So further studies need to be carried at the age of 4 and 5 years after planting for the growth stem from proper general for funding support to establishing these international province trials. I record the heartfelt thanks to Australian Tree Seed Center, CSRO Australia, for sharing the new set of provenances to widen the genetic base of this Acacia mangium and in India. I acknowledge the effort of Dr. Maheshwar Hegde in the Acacia Tree Improvement Breeder for the guidance and providing the guidance and support, and also express a Director Institute of Phylogenetics and Tree Breeding for commendable support. Thank you very much for the
Thank you very much, Dr. Well, any question from the participant to ask question regarding provenance performance of the fused Acacia mangium species? If not, the questions, just want to ask, any correlation between, because your side, mostly the rainfall is less than 2000 ml.
Yes, sir.
So is there any correlation from the best performance from Papua New Guinea is related to the similar rainfall distribution from the natural area?
Yes, sir. One location in Dondali, it is receiving more than 2,800 mm. It is similar situation. The provinces are performing. The Papua New Guinea provinces is performing in the third place, sir. First is Vietnam, followed by Papua New Guinea, then AGTB seed lot in the particular location, sir. Whereas other lots, the Papua New Guinea provinces comes for the second places, sir.
Thank you for the information. Thank you for the presentation. Any other questions from the participants or from the floor? No, and then thank you very much. If any questions, please post it. Probably the presenter will be able to respond in the chat group or the Q&A group. Thank you very much, Dr. Marvel.
Thank you.
We move to the second presenter. It's actually from Dr. Julian Marano Chan. He's currently principal scientist at the Institute of Commercial Forestry Research. He will present on the genetic variation in frost hardiness, rust resistant, and growth in a cold-tolerant population of Acacia mangia. Allow me to read his CV or biodata. His experience in forest maturation, tree improvement, and wood quality of wide range of forest species in Mexico, Australia, and South Africa. He is currently, as I mentioned, group leader for the tree improvement at the Institute of Commercial Forestry Research. Main responsibility is actually both for Acacia mangia and also Eucalyptus is actually doing the breeding program. He had PhD in forestry science in 2007 from University of Canterbury, New Zealand, Bachelor of Forestry in 1993 from Mexico. So without further ado, I pass this floor to Julian, please. Julian, can you hear?
Yes, I'm busy sharing my screen. Please tell me if you can see.
Yes, we can see it.
Okay. All right. All right. Let me just minimize this thing here. Okay, can you all hear me and see my screen, please?
Yes, both again. Yes, please.
Okay, thank you. All right, thank you very much for your words and for your introduction. As you mentioned, I'm based in South Africa at the Institute for Commercial Forestry Research. I'd like to acknowledge my co-author, Professor Fikret Isaac from North Carolina State University in the US. Fikret is a genetic quantitativist, and he's an expert on genetic analysis of disease data. Okay, so this study has been recently published in Forest Science, as you can see there. Right. Okay, let's start. So black wattle, Acacia meonsi, is naturally distributed in southeastern Australia, and it's an economically important species in South Africa with about 110,000 hectares planted, of which about 30% are under risk of frost damage. Okay, the bulk of the plantation tree resource is the local land races, which were introduced to the country in the 1800s, and these are not frost tolerant. The current planting stock cannot tolerate temperatures below -3 or -4 degrees Celsius. An additional challenge in frost areas, on frost affected areas, is the emergency of the wattle rust disease caused by the fungus or Eucalyptus acacia. So there is an urgent need to develop seed sources and clones, both tolerant to frost and resistant to rust, for deployment in frost affected areas in the country. Currently, there is a lack of knowledge about the level of genetic variation for frost tolerance in the species. All the previous studies have focused mainly on provenance variation. It's also important to mention there is a lack of information on the genetic relationships between frost tolerance, wattle rust disease, and other economically important traits for this species. So the overall objective of the study was to investigate genetic variation in black wattle seed sources for economically important traits and use that information for a breeding strategy. Okay, so the study included a total of 110 open pollinated families. 61 of them originated from mid to high altitude provenances in New South Wales and Victoria, and from 3 Tasmanian provenances, and another 49 South African first generation families, which were collected in a trial established in 2002 with seed from 2 hardy or cold hardy Australian provenances, which are Lake George and Mittagong in New South Wales, together with seed collected or seed from wild trees collected growing at very high elevations in the Drakensberg Mountains in South Africa. Okay, so we established 5 trials during 2014 and 15 in sites affected by severe frost in northern KwaZulu-Natal and southeastern Mpumalanga in South Africa. The number of families tested in each trial ranged from 33 to 107. Experimental design was randomized complete blocks with line plots of 5 or 6 trees and 4 to 7 reps. The trees were planted at 3 by 2 or 3 by 1.5 meters spacing. One of the trials, the trial at Inwe, consisted of seedlings placed in trays during winter in a farm affected by frost. Okay, so this is a picture of one of the trials. This picture was taken before the start of the winter. We measure survival. I mean, just for us to identify any dead tree before the occurrence of frost, and we measure also height before winter as an indicator of tree hardiness. We measure temperatures at 60-minute intervals using miniature sensors from April to the date of frost damage assessment. Okay, in this particular trial, we had in April several light frost with temperatures ranging from -1 to -2.1 degrees Celsius, followed by several frosts during May with temperatures going down to -5. And then in June, we had this trial had heavy frost events with minimum temperatures reaching -8.7 degrees Celsius. So this site in particular had a total of 27 frost events. Okay, we employed a frost damage score based on changes in the foliage, changes in the color and texture, as well as the strength of frost damage. In a categorical scale ranging from 0 to 7. So the picture, this picture here shows a seedling showing a extreme frost damage, whereas this other picture is of a seedling showing some frost tolerance. Okay, okay. This is a picture of another trial in after frost damage. So the plot on the left is showing extreme frost damage, while the plot on the right is showing some frost tolerance. This site had a total of 30 frost events with minimum temperatures reaching minus 6.5 degrees Celsius. Okay, this is another trial in which the trees at the front are showing some moderate frost damage. The trees are bigger than the other trials, as you can see, because we planted this trial early in the season. Okay, so this site had a total of 42 frost events, and with minimum temperatures reaching minus 6.1 degrees Celsius. Okay, right. Now, regarding rust, we measure rust at 14 months of age using a score with a categorical scale representing approximate percentage of the foliage covered with tilia, and we assessed rust in two opposite sides of the tree. From this assessment, we derived, rust incidence, we basically means presence or absence of the rust in the tree. We also assess merit insect damage with a severity scale, as well as merit incidence. Okay. We evaluated tree height, diameter, breast height, stem form at 39 months of age, and together with gammosis incidence, which is this picture on the bottom. Gammosis is an old disease affecting black wattle, and it's caused by a complex of fungi, including Fusarium, Diplodia, and Phytophthora, plus it's associated to physical damage on the trees and some environmental factors. All right. So for data analysis, we ran a combined site analysis to estimate variance components and genetic parameters using ASREML version 4.1. We used the generalized linear mixed model for binary traits. The binary versions of rust and merit produced better estimates or heritability estimates than the categorical versions. These other traits, frost score, DBH, height, and stem form, were analyzed with linear mixed models. And for all the traits, model selection included model convergence in best fit using the AIC criterion. The genotype by environment interaction was estimated as the average additive genetic correlation between pairs of sites for those models who provide all this information, or just a traditional method using the variance components of family and the interaction family by site. ASREML produces blobs of family effects, which are equivalent to GCA values, and we use multivariate models to estimate additive genetic correlations between traits. We also ran individual tree models for the estimation of tree blobs. And finally, we were using the predictive reading values of frost score, rust, and height. We scale them or standardize them to a mean of 100, and using 3 weights for for a selection index. Okay, right. This plot, let me just explain what the bars are. The bar in dark orange is Lake George, LG, and the one here in dark blue is MIT Michigan. These two are well-known coal-hardy Australian provenances. The light orange one is first generation from Lake George grown in Australia, and mid F1 is first generation from Michigan. These two first generations, as I mentioned before, are families grown in a local site in South Africa, in a local warm site. These other 3 graphs are the progeny, or are families from the progeny of these wild trees growing in high altitudes in the Drakensberg Mountains. As you can see in the graph, Lake George was significantly different to the others and was frost hardier than the other ones. It was interesting to note that the first generation families from Lake George grown in South Africa were significantly less frost hardy than the provenance of origin. Okay, right. This graph is this shows family variation in frost damage. Okay, so as you can see, there was a wide range in frost damage, ranging from 1 to 3.9. There were 9 families from the provenances Lake George and Kuma showing distinctly less frost damage than the others. Okay, this graph is of the probability of rust incidence of all the families tested, and as you can see, there was also a very wide range in rust incidence, with the number of families showing high resistance on the left. Okay, and also many others showing high incidence. Okay. These are the narrow sense heritabilities in family, in the repeatability of family means, as well as the G by E interaction. Okay, frost damage showed a moderate narrow sense heritability and high repeatability of family means, suggesting that this trait is partially under genetic or additive genetic control. Rust incidence was under a strong genetic control, as indicated by both a very high narrow sense heritability and high repeatability of family means. There was moderate genetic control for DVH height in gamosis, but low for merit in stem form. Genotype by environment interaction was low for frost damage, rust incidence in growth traits, and it was moderate for merit, stem form, and gamosis.
Excuse me, Julian, you have 2 more minutes.
No problem. Yep, getting there. So in terms of genetic correlations between traits, frost damage had very weak relationships with the others. Rust incidence also had low or weak correlations with the other traits. But there was the 2 more important things here. Predicted gain from selection index. Okay, using a breeding population, 135 traits from the best families produce a 14% gain in frost tolerance, 15% in rust, and no gain in heart. The highest genetic gains were produced by clone selection, with 30% gain in frost tolerance, 24% in rust resistance, and no gain in height. So in the short term, the highest genetic gain can be produced by clones. I'm gonna jump this slide so I can go to the final one, okay? Conclusions. All right, so there was considerable genetic variation among seed sources and families within seed sources for economically important traits in the population study. So recurrent selection will be successful in improving frost tolerance and rust resistance. However, and very importantly, the current population comprises very limited germplasm that is both tolerant to rust, tolerant to frost and resistant to rust. So therefore, it's important to infuse new germplasm from non-cold hardy Australian provenances into the current population. It's also recommended to use artificial screening methods so to reduce the breeding cycles. I think that will be the most important conclusions. Yes, that's the end of my presentation.
Thank you very much, Julian. Any questions? I hope that everybody is awake. Although this is afternoon sessions, I'm not very sure. Julian, you actually live from South Africa now?
Correct, yes.
What time is this in South Africa now?
It's we have six hours difference. So here is 8:38 in the morning.
Okay. In the morning, okay.
Yeah.
Thank you for joining us from South Africa.
So yeah, I'm just waking up while you guys have after lunch. Yeah.
Okay. I just want to ask you a question. You presented just now a lot of provinces, but most of them is actually susceptible to rush infections. Correct? Am I correct?
Sorry, can you repeat your question, please?
Most of the provinces that you try is actually susceptible to rush infections.
Mm-hmm. Okay.
Is that correct?
What happened is, what we found is that most of the frost-tolerant provenances, okay, showed poor growth or below average growth and were rust susceptible. So we have some sort of adverse correlations at the seed source level or the provenance level. That's what we found.
Oh, okay. So that's why you propose in your conclusions that more new materials is being introduced to South Africa, so that increase the genetic variations there.
Yes, that's right. So this is the second part of the conclusions. And well, basically what I just said to you is the second bullet point. And it's actually quite interesting and quite important. But yeah.
Okay, thank you very much. I don't see any question from the chat or Q&A. So thank you very much for your presentations. I enjoy your sharing. Thank you very much, Julian. So we move papers. The paper will be on eucalyptus alternative to Acacia mengium in tropical wet climate. This presentation will be presented by Dr. Arno Brunner. He is senior forest geneticist from GP Pusaka based in Bintulu, Sarawak, Malaysia. Allow me to read his short CV or biodata. He was born in Germany, graduated in forestry in Brazil in 1967, master in forestry from University of Washington, USA in 1970, the year that I born. PhD in forest genetics and physiology from University of Florida, USA in 1973. I have been lectured on forest genetics for a long time in Brazil. 20 years with German technical corporations in Paraguay, Argentina, and China, and also working few years in Africa, in Mozambique and Ghana. I have more than 60 scientific publications currently based in Malaysia. Now I invite Arno to present. Please, Arno, the floor is yours.
Can you hear me?
Yes, yes. Hi, we meet again.
I first would like to thank the organizing committee for allowing me to present this paper to you. And then I also thank GP Pusaka for letting me represent the company at this Congress. And finally, I want to congratulate the organization for a fantastic organization and very good papers which I have seen so far presented. So, can you see my slides? Can you see that?
Yes, yes, we can.
Okay, my topic is eucalypt alternatives to Acacia mangium in tropical rainforest. That is called the AF climate according to the Köppen classification. Just to go through that quickly, the tropical rainforest, AF is a climate without any dry season. Then we have AM, which has a monsoonal dry season. We also will talk a little bit about the CWA, which is usually the subtropical areas where eucalypts grow very well in Brazil and also South Africa, although there are other climates. And then maybe I mention very shortly the temperate and cold and dry summer, CS climate, which is the Mediterranean climate. Now, I would like to mention that the forest area in the world is huge, and very small part is only the plantation forests. But when we look at the production of the plantation forests, we see quite something different. We find that the majority of the products really come from plantations and not from the natural population. So the planted forests in the world, with only 7% of the area, produce about 70% of the world's forest products. This is very important for us to know, because especially when we work in exotic species, we're always confronted with the question, why don't you just work with native forests and instead of all these exotics? Well, exotics and the plantation forests really are the ones which produce the material which we use, and we want to save the rest for nature. Now, when we look at the natural forest again, we find that all over the world, it increases only from 1 to 5 cubic meter per hectare per year. While the planted forests, they produce something between 15 to 40 cubic meter per hectare per year at age 6 to 7 years. Now, looking at the plantations in Brazil, where I come from, that the eucalyptus plantations in Brazil produce something like 30 to 60 cubic meter per hectare per year at age 6 to 7 years. That is a fantastic productivity, but not in the climate we have here. In the Sarawak, we have mainly AF climate. This is CWA climate. So AF climate has not only a higher temperature, but a very high precipitation and generally poor soils. Now, looking at Amangium, it has some advantages: very fast growth, wide adaptability in AF climate, not very demanding on soil and fertilizer, and it's nitrogen fixing. The disadvantages: high susceptibility to several diseases. And I want to remark here that in 1998, Dr. Harwood in Kuching already, when saying yes, mangium would be okay according to the data available at that time, but many diseases would be expected. So in 1998, he already said that. There is low genetic variation for disease resistance. Although we heard yesterday from Mr. Lapamo that yes, there is some disease resistant which can be used. It's very hard to hybridize except for auriculiformis. It hybridizes with very few other acacias, and it's difficult in vegetative propagation. So what's the way out? We can use the hybrid A. mengiiformis, or we can try different acacias, like Crassicarpa is being very popular now. There are some more, also Peregrina, which I did not put here, and Acacia coa, which is hardly known, but it comes from Hawaii, from a wide range of altitudes, and the low altitude could do well in this climate. So if somebody still wants to try some new acacia species, this is what I would recommend highly, to put this one also. We could plant a mosaic. We could alternate rotations. We don't know so much about that because it hasn't been done so much that I know of. And we could consider eucalyptus species and hybrids as an alternative to manju. Okay, now what's the advantages of eucalyptus? We have many species to choose from. They're easy to hybridize, mostly easy for vegetative propagation. Most species have a wide genetic variability to choose from. Much experience in the subtropics, high productivity achieved in the subtropics. The disadvantages are there are few species adapted to AF climate, to our climate. They are more demanding in soil and fertilization than acacias are. They are sensitive to weed competition. There's not so much eucalyptus experience in the AF climate, except usually for Paleta. And there are many pests and diseases also. So here, very quickly, I go through the main, this is from Harwood to 2011, where he looked at the range of temperatures of many species. We see that Paleta is the highest one here, but not bad is also Camaldulensis from the northern provenances in Australia, which means subspecies Acuta, Simulata, and Obtusa. There are 7 subspecies in Camaldulensis. Then you see that Pteridicicornis is fairly high, Europhila also, but some of these species demand a dry season in between the rainy season, so not always convenient for our climate. Now, looking at our soils are poor. I will not go into the details of this here, but I just want to call your attention at the available phosphorus. It is 1 ppm or trace. And this is a good site for eucalyptus here, which I'm showing you. Okay, Eucalyptus Paleta does fairly well in this climate with a little bit of fertilization in the beginning. You can also look at the clay content down there, which increases with depth. Clay content fixes phosphorus. It also is fairly impermeable. That means little oxygenation to the roots, which is a bad situation, really. Now, if we look at the nutrient in the leaves, which tell us much more about the availability of what the plants really can extract from the soil, that soil which you have just seen, gives us the foliar analysis like here. You see that phosphorus is very low, but it doesn't tell us much if we don't know what is the ideal levels. What should be the ideal levels in eucalyptus if we have a totally well-nourished plant, healthy plant with all the nutrients available. There you see that we are low in nitrogen, phosphorus, potassium, especially. Then phosphorus, terribly low, and boron, copper, and iron especially. These are the ones where we really lack in our soils. So we have a lot of work to do in the soils. Now, the species adapted to the tropical rainforest come from climates similar to what we have here. And here you see that Paleta, which I call Paleta mediterranea. Why do I call it that like that? Because it has been separated by Hill and Johnson in 2000, the Biterrania from Pelita. And that what we have here is not Pelita, is Biterrania, but it's not everywhere accepted and everybody knows it as Pelita. So in this work, I'll just speak about Pelita Biterrania. But the tropical, for AF climate and for AM climate, it is Pelita. It's not really Pelita, it's Biterrania from Papua New Guinea and northern York Peninsula, north of 15 degrees. We also have the Glupta, which we know comes from all the way from New Britain and Sulawesi Island, Seram Island, and Mindanao Island in the Philippines. It's the only eucalypt which naturally crosses the equator. Then we have Eucalyptus brasiliana, which is very interesting for us, especially the Papua New Guinea provenance, if we can get these provenances, and Tereticornis also from Papua New Guinea. These two species, I'll speak a little bit about them because they are of the subsection Excertaria, which is very well adapted to poor soils and to very impermeable soils like we have here very often. Then there is a possibility with Eucalyptus leptophleba. I don't believe too much in it because it's a medium-sized species, and I don't know of any trial for plantation with it. But anyway, I name it also because it would also be a species adapted to to our climate. Now, all of these four species in the beginning, Pelita biterrania, Deglupta, brasiliana, Tereticornis, they can cross with each other and give very vigorous hybrids. As a matter of fact, the Filipinos in the 90s with the Glupta and Pelita or Biterrania, they made very good hybrids, and also with Europhila. I will not go into this now. This is just a classification of the eucalypts of those which are mentioned. They will be in the paper if in case this paper is published by the journal. Now here we have a picture of Pelita or Pelita biterrania at 6 years in our area, and you have a mean annual increment from 10 to 20 cubic meters per hectare per year at age 6 to 7. And the wood density is very high, 650 kilograms per cubic meter on average. This is very good. So this growth here is not fantastic. You see that the weeds are still a problem for us, although they have been killed at this moment. But weed and fertilization is a big problem for us in Sarawak. And here you see also the Glupta. The Glupta goes far higher. The Glupta goes to even 47 in one of our plots, 25 to 47 cubic meter per hectare per year, but the density is much lower. When the Filipinos crossed the two species, they had even more growth from the hybrid and a density in between these two species. Now the hybrids, you can do the hybrids between all these species here. We don't know very much about the possibility of hybridizing leptophleba if it came into consideration. But these eucalypts can be crossed among themselves. As I said, Pelita biterrania and Deglupta give a very good hybrid, but also brasiliana. We have a few hybrids of these, and they are always better than the surrounding Pelita around them. Tereticornis has not so much been tried, at least not the one from the tropical environment. And finally, we can cross all these eucalypts with the subtropical ones, Europhila, which demands a dry season. Grandis, Saligna, Camaldulensis, they don't grow here, but we could import the pollen. And then we can also cross them with the section Maidenaria, which is usually the cold climate adapted eucalypts, with some with very good pulping characteristics like Danii and Globulus and Nitens. So these can all be crossed into that. So if we have these growing here and producing flowers, we could import the pollen from these here from areas where they occur. We can make two-way hybrids. We can cross a hybrid with a third species. So we have three-way hybrids. It can be two hybrids, different hybrids in a four-way process, and we can do back process. So the possibilities are immense. And for AF climate, for our climate here in Sarawak, we should start with the species adapted to this climate and then import the pollen to widen the gene pool. Now, what's the course of action? First, we need introductions mainly from Papua New Guinea. We really need this. We need it from Raciana, from Tereticornis, possibly Leptophleba, but also more from Paleta. From Paleta bitirrhania, we already know that that is the best provenance. The rest will also certainly be the best provenance. Now, the Glupta has a whole gap of provenances. I have never seen any Deglupta planted from Sarawak Island, from Seram Island and Sulawesi Island. Sulawesi Island is very close to us here, and that's where it crosses the equator. So it should be interesting to get these Deglupta from there before they disappear. We have to test all these species in many locations. We have to produce the land races of them and start breeding programs with equatorial species. As soon as possible, hybridize them. And there is no need to wait until 20 years. Whenever there is a promising clone, we can start propagating it. But we need a very, very wide genetic base to start really a good program with cloning and hybridizing to overcome the constant disease threats which we have here. Now I'll go into Corymbia. Corymbia is not so much talked about, and I don't believe in any of the species in here except possibly Torreliana. Torreliana might grow, but will not probably be the best. But there are some Corymbia which come from Papua New Guinea also. And these are the ones we should concentrate on. And then the hybrids, especially the hybrids. Torreliana crossed with spotted gums, which are Citriodora, Variegata, Maculata, and Henriette. They give excellent hybrids. And some of these hybrids are growing in very tropical areas like the Amazon area already, and also in Congo, but not very much. But I'll give you another example from very close by soon. Now, the difficulties with Corymbia, they are not so easy to vegetatively propagate. So we can use mini tunnels for mother plants, and I'll show you a picture of that shortly. We can use the cuttings from lignotubers, and we can use Torreliana as the mother plant in the hybrids for maternal inheritance, because Torreliana roots, while Citriodora, for instance, Henria, and so forth, they don't root very easily. Here, this, I don't want to go too much in this. Here they cross Torreliana with Torreliana and compared when using the pollen from very different species in the Corymbia. And you see the two sections, Blacella B and Corymbia section C, and they are spread all over. I expect that the classification of the Corymbia will change still. It's a very interesting paper, but we cannot go into it in detail here. Now, this is a mini tunnel where you keep the mother plants of, in this case, Citriodora, which is very, very difficult to root normally. And you put them in these mini tunnels, you keep this hermetically closed. And if you do it by the proper way, the usual way, you hardly get any roots, if at all. While from the mini tunnel, you get normal rooting, very good rooting. By the way, this mini tunnels, that also works for other difficult to root eucalyptus. It has the same effect on them also. So it's a very interesting technique to be used. This was done by my student Teotonio Assis, who was my master's student and my undergraduate student in Brazil, and he is very famous nowadays. I'm not, but he is, and I'm very proud of that. Here is Citriodora from the cuttings, from the mini tunnels. You see everything rooted, very, very good rooting. So the mini tunnels work very well. Here you have Corymbia torreliana times Citriodora clones in Brazil at almost 1 year of age. Very healthy, very productive. The high density of the wood and the low splitting of the wood is really a fantastic combination. Here you have the same plantation at year 7 years. So this is a clonal plantation of Corymbia torreliana times Corymbia citriodora at 7 years. And here I want to show you a torreliana citriodora, which I sent the seed to Kalimantan. And there, this tree in the middle is the one growing there, growing very well, much better than the Paleta clones, which are also selected material in the background. This was what I had. I think as conclusions, we don't want to avoid, if we want to avoid the mistakes of the past, planting one species on large areas. There still are hopes in acacia, hybridization, different species. There is genetic variability offered in the genera Corymbia and Eucalyptus, which has not been used hardly at all. There are still many provenance gaps of equatorial eucalyptus here, especially when it comes to Sulawesi Island for the Glupta and also for Papua New Guinea for all the other eucalyptus species I mentioned. We need to research much more in nutrition in this climate. Hybridization and vegetative propagation are very important assets that has been extremely successful for the subtropical eucalyptus, and the same can be done here because I showed you already that you can get 47 cubic meter per hectare per year under special conditions here. And we have to find a way to import pollen because that is not an easy story. If you import seed, they have to be treated with chemicals. Pollen you cannot do like that. So I think there is not much information on how to import pollen if we want to make hybrids. This was really what I wanted to present to you. Thank you.
Thank you, Arno. Very well presented. There is 2 questions from you to you actually, and now it's 3. First questions from Doringo. Instead of eucalyptus as alternative planting material for plantation, won't it be better to focus more on indigenous species with known growth and wood properties?
Sorry, the question was there is Eucalyptus Paleta, and if there isn't.
No. It is actually instead of you promoting eucalyptus as the alternative source for plantation.
Yes.
The suggestion is that we consider indigenous species instead.
Okay, my reasoning goes like this. If you have an indigenous species which gives you the productivity of the eucalyptus, well, why not? So first we have to have them, because as I showed in the beginning, the plantations are really producing all the wood, practically 70% of the wood in the world. So it comes from plantations. But yes, if you do have an indigenous species, I will not argue it would be better. Probably they will have to be planted in monocultures as well. So they might have their own problems. I have nothing against them as long as they produce what you can get from other species also. Why not?
Yeah. From Kin, from Vietnam, he actually asked you, can you please explain more about the mini tunnel, how it is different from normal propagation technique?
Yes, the mini tunnel, in the mini tunnel you have a small tunnel like I showed in one of the last slides, which is kept at no more than about 50 centimeters of height, completely closed with plastic and hermetically closed. You keep the plants in there. You can open it once a day and irrigate whatever has to be done. And that is the way they are kept. So the morphology of the leaves changes a little bit. They get a little bit more narrow. They get a little bit, the color changes a little bit, but the rooting is fantastic. And the same technique, as I said, works for hard to root eucalyptus, like Louisiana, for instance. It works for them as well.
There is a third question, Andrea. Actually asking you, do you know any trials with genetic material of Eucalyptus teriticornis from Papua New Guinea?
No, I don't. As a matter of fact, it's very difficult to get this material, any material from Papua New Guinea. But I would leave my suggestion here that for our climate, for Indonesia, and for Malaysia, possibly Vietnam, possibly Thailand, it is very important to get this material. So if there was a concerted effort to obtain this material from there, possibly with the help of the Australians who have some of it, that would be very important, yes. But I don't know of any teriticornis from Papua New Guinea installed anywhere around here. But it should be.
Thank you very much for the presentation. Thank you for the answer. I believe that everybody actually get a lot of information from your presentations. So without further ado, we move to the fourth presenter for this afternoon. Again, I will invite Dr. Hesh to present his paper, this time entitled Evaluation of Early Growth Performance of Acacia auricularis clones across constructing sites in southern India. Please, the floor is yours. Mahendra? Are you, okay, thank you. Please unmute your mic.
Okay.
We seem to have little technical issues here. Stop sharing again, or this one, organizing committee, do you have Dr. slide?
Yes, we can share from our side.
Okay, Dr. Hesh, please stop sharing. Hesh, what? Hello? 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 Are you there?
So I think our speaker temporarily lost connection. Do give him some times.
Is that he's trying to log in again?
Dr. Ong, maybe
Yes.
we proceed to the next speaker first.
Yes, okay. I would like to, Dr. Kamal, are you around? Are you ready? Dr. Kamala?
Yes, I'm ready.
Okay, I will invite you first to present your paper on conversion of a progeny trial of Acacia mengens to a seed orchard considering gain and fertility. Dr. Kamal is actually a scientist at the ITC paper box and specialty paper divisions in India. Allow me to read his CV. He's completed his PhD in forest genetics from Forest Research Institute University in India, having 22 years of research experience in pulpwood tree improvement program and eucalyptus seed orchard. Published a lot of peer-reviewed papers. He also established eucalyptus and casuarina species with the objective to produce high-quality seed. Recently developed high wood and pulp yielding clone and deploy them commercially. Please, the floor is yours. Dr. Ratinan.
Yeah, thank you, moderator. Good afternoon to all. I'm audible?
Yes, please continue. Are you sharing? Yes, okay.
Is my slide visible?
Yes. Please share the slide. Yeah, okay, thank you.
Yes, good afternoon to all. Thank you, moderator, for your introduction to the forum. And also I extend my sincere thanks to the organizing committee to permit me to present the work to this conference. So here I would like to explain the work we have done in Acacia mangium species. And this species actually grown in India, introduced to India in 1980s. Our previous speakers introduced about the species a lot about, so I'm not going to details. The species introduced to India 1980s. That time the source was not unknown. That the growth also very poor and stem form is not excellent. So with the CSRO consultant Dr. Chris Harwood, the support, we have introduced the material from Papua New Guinea and Queensland. This has established the trials in the western part of the country and subcontinent. So the breeder's requirement is seed, immediate seed production. We started the seedling seed orchard from the first generation progeny trials. That is the easiest way for the breeders in the short-root species like Acacia, Acacia, and Eucalyptus. So in this Acacia, we have introduced the material, and the first generation material was converted into seedling seed orchards. And the seeds is the supposed to be superior from seedling seed orchards because the so many families introduced from the resource. Generally, before going for the seed orchard establishment, we have to see the methods to convert the progeny into seedling seed orchard, and that gain is very important. Gains beyond the first generation would be depend on the accuracy of the selection procedures, selection of the genotypes, and the management in the inbreeding should be avoided. So gains will be cumulative in the first and the subsequent generations. For that, we have used two different methodologies, like a truncation and the phenotype selections. In the methodologies really help us to get the especially for the tree breeders, help us to get the gain as well as the diversity. In addition to the selection methods, we have to consider the fertility of the trees. See, after selecting the tree is not fertile, so we are not able to get the quality seeds. So ultimately, fertility is also very important. So we consider the fertility of the individuals in the first generation material. So that will transfer the genes to the next generation crop. So in this study, we aim to predict the impact of the selection methods. Two selection methods we deployed. So that is impact on the gain and as well as the diversity in the first generation project trial at the age of 7. Coming to the materials are introduced from Queensland and Papua New Guinea. The tulimicin and the pesca ore material from the Queensland source introduced to the western part of the subcontinent. So these trials are established so many places, but the orchard study taken from one place called Nilambur. So that is a material planted in the high rainfall area. And this same Papua New Guinea sources also, altogether 20 families we have introduced. And this was replicated 4 times. Each plot has a 8-tree plot. The spacing was 3 into 1.5 meter. So this is the material we used for the study. So that side, about the site, that is a high rainfall area. And the average, the total annual rainfall was 300 mm. It's on par with our Papua New Guinea source. The temperature, average temperature, mean annual temperature was 29 degrees. So the wettest month is the June, the driest month was February. So here the flowering starts in the month of May, June. After 4 months, we have recorded the fruit set, the pod production. So this also actually good for the trees growth, as well as the seed set was not as encouraged because of the high rainfall that conditions. Then assessment, actually we have evaluated the trial was evaluated every year, but at the age of 7th, we taken the data for the conversion of the progenitor into seedling seed orchards. Also, we recorded the pod production in the per tree at the age of 7. So if that is very difficult part, actually we used a pair of binoculars. We just counted the branches and the fruits in the branches. Sometimes when we face the difficulties, we engage a climber and cut the branches in the middle part of the tree and just counted the pods per tertiary branch, number of tertiary branch with pods present in the secondary branch, and a number of secondary branches present in the primary branch. So also to have the pods. So like that, we have recorded the data, and that the data was extrapolated using this method, like a Bilang et al. Professor Kang and Lindgren developed a method to extrapolate the fertility variations. So we have used the parameters like a fertility variation, relative population size, group ancestry. These are the parameters help us to understand the orchard dynamic, and these parameters values help us to understand the variation in the fertility. Generally, the sibling coefficient value, probability of 2 genes originate from the same plant, was used to quantify the fertility differences between the orchards. Actually, this can be estimated the sibling coefficient value, the number of trees present in the population with the flower production, so or for pod set. Then this value you can get it. This, if it is the 1, the sibling coefficient value is 1, is the orchard is equally contributing. So again, the relative population size. The relative population size gives the idea about the genetic, the diversity in the populations. So number of effective trees contributing from the strands, and as well as the random mating with the actual number of trees in the orchard. So this get an idea. The method developed by Professor Lindgren in 1996. We used this theory to develop this relative population size. Also, the group ancestry value, formula developed by Lindgren and Mullin, Professor Sweden. So this also brought up 2 genes taken randomly from the gene pool of the expected seed crop will be the identical result. This given the relationship between the individuals. So coming to the results, when we study the growth of the provenance introduced from the Australia and Papua New Guinea, so the growth at the age of 7 in terms of height is not much varying. When the diameter breast height was higher in the Papua New Guinea material than the Queensland material. Similarly, the pod production as well as survival percent also higher in the Papua New Guinea materials. So generally the trials average survival was 64% at the age of 7. It was ranging from 34 to 85%. Here we use this DBH parameter for selecting our trees to convert the progenitor into seedling seed orchard. Just we want to see the correlation between the phenotype and the fertility of the tree. When we see the growth between this height and DBH, we are having the positive correlation, but it's not statistically significant. But same way, the pod with the height and the DBH is 0 as well as a slightly positive side, but it's not positive correlation. This is also one way good, and we selected based on the growth of the tree. See, all the trees are having fruit production in the selected populations. When we saw the percent flowering trees in the families, when we studied the 20 families, the percentage varies from 31 to 84. Trees which is introduced from Papua New Guinea shows good fertility compared to the Queensland provinces. But in general, all the families are having the fertility, having the fertile trees. And coming to the fruit production in the tree, it varies from 2% to 11%. Here also the fruit production is not significant the growth. So we use this parameter to just count the fertility and seed production capacity of the tree. So overall, all the families in the trial were fertile and produced seeds. Coming to the parameters studied, so number of trees actually before thinning the orchard, after 60% survival, we had 405 trees, and we used a truncation selection. Then the truncation selection was select families only based on the merit. Above the trial average, what are the families having the trial average mean value in the growth? We have selected. We retained 270 trees. But the phenotype selection, we didn't consider the family merit, but individuals' value were taken up. There are individuals represented from the inferior families. Then the fertility value is the very important, and actually before thinning it was 3.7. The truncation is not much varying, again on par with 3.7 to 3.4. The phenotype value selection gave 3.1. And the relative population size in terms of diversity, it gives 0.27 in the existing trial. So after thinning, after the truncation selection thinning, it was 2.9. But the phenotype selection gives more percent, 32% higher we got it. Group consistency also on par with the trial. Actually, the existing trial has 0.033, but the phenotype selection got 0.035. But the truncation got more because there we lost a lot of families because of the inferiority. Growth already I explained. Actually, growth was 19.1 centimeter DBH in the truncation selection. The phenotype selection we got 21%. That is 16% higher gain we got it compared to the truncation selections. When we retain the families, before thinning we got 20 families the introduced trial. So the truncation selections we thinned the inferior families, we were able to retain only 15 families. But in the phenotype selections, we retained all the 20 families, but the number of trees varying, it's a 14 to 27 trees are there. So this we able to get all the families in this selection, and we able to get the more gain as well as the fertility sibling coefficient value also on lesser than the existing trial. Coming to the breeding value of the selected trees. So this number of trees having the low breeding value in the before thinning strategy, but the truncation selections all are above in the average, above average only it's retained. But in the case of phenotype selections, we have few trees coming inside the low breeding value. Since the trees selected from the inferior family, the value is very low. But most of the trees are more than the 197 trees, around 150 trees are falling in this positive breeding value category. So even that it is a negative, but all the trees are fertile. So this is helping us to get the gain and the next generation. The cumulative contribution curve explains the relative proportion of the individuals accumulated gametic contribution in the selected populations. So in an ideal situation, this is expecting an equal contribution of all the individuals in the selected populations. If it is so, the sibling coefficient value is 1. That time the line should be straight. But in our case, in the before thinning, it was deviating from the 1, but it's showing around 80% of the trees having pod and fruit production. But in the truncation selection, we got slight improvement. The sibling coefficient value was 3.4. But after phenotype selection, it is 3.1. So still we are deviating from the equal line. But the thumb rule actually, according to the Professor Kang and Lindgren, ceiling seed orchard sibling coefficient value supposed to be 2. But this is not far away from the 2, it's 3. So this can be improved, the mixing of 2-year seeds for further improvement program. In conclusion, actually, compared to the both provenance materials, PNG seedlets having better growth, survival, and fruit production. And there was no significant correlation between the growth and fertility. So then we taken the growth phenotype selection for the converting the progenitor into seedling seed orchard. We got 16% gain in terms of growth, and expected the diversity was 32%. So these are the results we obtained. That's all from my presentation. Thank you.
Thank you very much, Dr. Kamal. Any questions from audience, from our participants? I hope that you can pose some questions regarding the conversion of progenitor trial of Acacia mentioned to a seedling seed orchard. So explaining some gains and fertility of the species that they were able to get from converting to seedling seed orchard. Any questions? If no, we will wait for them to post into our chat or Q&A. Later, Dr. Kamal can actually look at it and respond accordingly. Okay, thank you very much for your presentation.
Thank you, sir.
Kamal. Again, I would ask organizing committee, is Dr. Hesh is ready? Dr. Hesh is now?
Hello? Not yet. He's
Not yet.
Yeah, not yet.
So we move to the last presentation for today. Let me see. It's actually, I was informed that it's actually yesterday, but anyway, he will present on assessment of the incidence and severity of ants bleeding in plantation grown Eucalyptus Paleta in North Borneo. Let me read his CV. I think Mr. Manuel SP is actually from Germany, currently working at Forest Solutions Malaysia Sdn Bhd as the logistic manager. He obtained his bachelor degree in forestry in Germany. Currently registered as a master student with the University of Putra, Malaysia, studying the ant splitting in this one, Eucalyptus Paleta logs. He have 23 years of working experience, with 20 years in Malaysia, mostly involved in harvesting and log yard operation, plantation establishment, nursery plant productions, and R&D. Without further ado, Manuel, the floor is yours. Are you around? Yes.
Hello, can you hear me?
Yes, yes.
Yeah, I have some technical issues here, same as yesterday. My Zoom connection usually breaks off, so I'm not sure if I actually can deliver this today. I have some problems here.
Yeah, I can see you.
Yeah, okay, good.
Now,
yeah, so I hope. Yeah.
Please continue.
Yeah, I hope I can deliver this now because I'm experiencing some technical issues here. The line quite frequently breaks off. Okay, I can't see my slides at the moment.
Organizing committee, can you help to share?
Sure, sure.
Yeah, okay. Can you see the slide?
Okay, yeah.
Right. Please continue. What happened?
Hello?
Yes, yes. Please continue.
Okay, as said,
Probably because the line is not stable over there. Are you in Kota Marudu? Hello? Hello? Are we losing the connections? Organizing committee?
I think his line is not stable.
yeah, okay, I think
Organizing committee?
okay, so I'm sorry, I think I can't do it today. Maybe
Okay.
next.
Sorry about that. I think you are in Kota Marudu. Probably the line is not so good.
No, I'm in Germany. I'm in Germany.
Oh, you are in Germany. Okay, I thought you are in Sabah now. Organizing committee. Since both of the last two presenters are not able, I pass back to you, MC.
Mr. Manuel, can you off your video? Mr. Manuel, are you still there?
He can't do it.
He can't do it.
Yes. So I pass back to this one, our MC for today.
Okay. Thank you, Dr. Ong. Thank you very much for your kind contribution to the conference as the moderator for today. So as we all know, sorry. Ladies and gentlemen, on behalf of the organizing committee, we would like to apologize for the technical hiccup that we experienced with Dr. Manuel as well with Dr. Maheshwar. But I would like again to thank Dr. Ong for facilitating these quite heavy sessions. It's on genetic and breeding and it's quite technical. Even for us here, it's something that a difficult thing to grab, but to all speakers, a big thank you and appreciation to Dr. Anna Malai, Dr. Julian Moreno, Dr. Arno from Bintulu, thank you very much. Dr. Maheswar, Dr. Kamalakan, and Mr. Manuel, although you could not present, we hope that we can see you in other event here in Kuching for a very accelerating research insight and funding. So now it's still 3:36 p.m. Malaysia time. We are supposed to have a poster sessions at 4 p.m. Poster. Can we have poster now or rest? Poster. Okay, we will be resuming this conference with the poster presentations. So. There is exciting information that we received that Dr. Maheshwar will be joining us later, but we will continue first with poster presentations. So each poster presentations will be given 5 minutes to share their research findings. We will not be having any questions and answer session. However, we hope that you can correspond with the poster presenters through their email, which can be sourced from the digital program book that we sent earlier on. I believe all poster presented here today have a very interesting finding indeed. Give me another 1 minute. Sorry. Okay, first we have Ms. Nadira Mohammad Yunus, a postgraduate student from Faculty of Science and Natural Resources, University Malaysia, Sabah, Malaysia, with a poster titled Identifications and Characterizations of Fungal Pathogens, Ceratosis Species on Acacia menjum in Ulu Kukut, Sabah.
Hello everyone, my name is Nazira binti Muhammad Yunus. I'm a UMS postgrad student. My research is identification and characterization of fungal pathogen, Stratocystis species on Acacia menjum in Ulu Kukut, Sabah. Acacia menjum is known to have major fast-growing, tropical greening, good wood efficiency, and less selectivity on environment to grow. However, such a huge monoculture, there is emergence of some pests and diseases that are now posing a big challenge to plantation industry. And one of the challenges is wilting phenomenon that are related to Stratocystis. The first significant incidence in Malaysia was reported in Tawau, Sabah, about 40%. Signs and symptoms of Stratocystis. For early stage, there is presence of cracked or sunken bulb near the cankers. Advanced stage show presence of blue black patches on the cambium, gamosis, and fermented exudate. And lastly, if the tree is severely disturbed, it will eventually cause fatal. I collected wood cambium, roots, leaves, and soil underneath the symptomatic acacia tree as my samples to isolate the fungal pathogen. The growth diameter of the culture are taken for 14 days, and the characteristic and morphology of the culture are observed by its macro and microscopic features. As for identification through molecular markers, the fungal DNA was extracted, amplified into several copies of specific DNA segment by using markers, and lastly was analyzed using MegaX software against the NCBI gene bank database to identify the species. From my collected samples, I found 4 isolates with different macroscopic features, which is isolate 1 has mated pale olivaceous gray and the reverse side show dark brown to black. Isolate 4 has circular grayish that turn darker gray with age and the reverse side show circular brown to black. Isolate 5 has white colored colony that turns to grayish brown with age and the reverse side show dark brown to black. And isolate 6 develop dark gray olivaceous colony with a brownish to black reverse side. As for microscopic features, it has more or less the same shape, which it has globus or opiriform bases with long neck, ended with divergent or non-divergent osteolar hyphae tips, and it also has conical spine base. Isolate 1 globus, isolate 4 globus, isolate 5 opiriform base, isolate 6 globus base. Next, this figure right down here show the average diameter growth between the 4 isolates within 14 days. As we can see here, isolate 4 and 5 have more or less the same growth, which isolate 4 reach up to 8 cm and isolate 5 7.9 cm. As for isolate 1 has the slowest growth among these 4 isolates. So based on this phylogenetic tree for ITS primer, we can see that Isolate 1 is closely related to Ceratomeganicans and is more distantly related to Ceratofimbriata. As for these two species here, isolate 5 and 6 are closely related to each other and is more distantly related to isolate 4. And for the outlier species down here is the least related among the isolates that's gonna be the Aspergillus niger. According to phylogenetic tree for beta-tubulin primer, isolate 1 is closely related to Ceratofimbriata and is more distantly related to isolate 4. Isolate 4 is more distantly related to isolate 6. Isolate 6 is more distantly related to isolate 5. And isolate 5 is more distantly related to Ceratomeganicans. Aspergillus niger as the outliers. My conclusion, so far, molecular identification for all isolates are still not conclusive and will be resolved by PCR and sequencing with third primer MS204.Cerato-B to confirm the findings. Acknowledgement to University Malaysia Sabah, Sabah Forestry Development Authority, SAFODA, and my grant research from UNS. Thank you.
Thank you, Ms. Nazira. The second poster presentation is from Mr. Agustin Alwi, plantation manager and silviculturist from Borneo Forestry Cooperative Malaysia, with the title of Near Infrared Spectroscopy for Rapid Assessment for Foliar Nitrogen and Phosphorus.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Hope you all are doing great and well. Thanks to IUFRO for giving me this opportunity to share the knowledge of research and collaboration between Borneo Forestry Cooperative and University Putra Malaysia. The title of my poster is Near Infrared Spectroscopy for Rapid Assessment of Foliar Nitrogen and Phosphorus. As we know, site preparation and early fertilizer application of nitrogen and phosphorus on Eucalyptus Paleta is essential when planting tree seedlings in commercial forest plantations. To monitor the response of fertilizer application, foliar samples are often collected from trees in designated fertilizer response trials to provide feedback on the availability of the nutrients. Foliar analysis is traditionally conducted using chemical method of analysis, which are costly and labor-intensive, destructive, and while high-throughput elemental analyzers are used, the sample throughput is limited. Near-infrared potentially provide detailed data in longitudinal studies. It is therefore desirable to implement a technology that is non-destructive to foliage and could be used for repeated measurements of individual leaves of a tree. The parable of near-infrared can be illustrated as an example, the red color. We're able to see the red color because green and blue light is absorbed and red is reflected to our eyes. Usually it was measured in wavelength or sometimes in a reciprocal wavelength. In fact, near-infrared spectroscopy is already used in the forestry and wood product sector for rapidly and non-destructively predicting wood quality and wood properties. In this study, leaf sampling is divided into two stages, namely nursery stage at 10 weeks and field stage at 3, 6, and 9 months after field planting. Each stage was derived from fertilizer trial, consists of 4 treatments as shown in table 1. All treatments were designed based on standard operational practice, reduced to 50%, increased to 50%, and control, whereby no fertilizer application at all. Figure 1 shows that the process flow of calibration, development, and foliar sampling at nursery, field stage, and sample scanning using micro NER 1700 produced by VIV solution. NER spectra were acquired both fresh on the tree and again after air drying and grinding and sometimes the data transformation are required. Young fully expanded leaf was sampled to standardize the selection of sampling. Foliar nitrogen and phosphorus were determined on a subsample of foliage following the methods of Vidal and Bretu respectively. Partial least square regression analysis of the NR spectra and the nutrient values was performed using the unscrambler. In the result, like all fresh biological samples, the NR spectrum of foliage is dominated by the water absorbent band near 1160 and 1452 nanometer. The dominance of this band frequently degrades the overall performance of calibrations developed using NR spectra from fresh sample, so that drying and preparing sample often improve calibration performance. Nonetheless, calibrations of foliar nitrogen and maybe phosphorus are possible using fresh NR spectra of the foliage acquired in situ on the tree. In this study, calibrations developed using combined sample from the 10-week-old seedlings in the nursery and from trees in the field at 3 months and 6 months post-planting were used to predict the foliar nutrition using spectra acquired on the same trees at 9 months of age, as shown in table 2. As a conclusion, calibration of foliar nitrogen and phosphorus on fresh leaves was successful for nitrogen and slightly problematic for phosphorus, which is consistent with NR foliar analysis in other crops. Using this method could provide a step change in the ability of foresters and agronomists to evaluate, control fertilizer trials, and optimize the application of fertilizer to operational areas by assessing the availability and demand for nutrients at local scale. Last but not least, we will continuously improve to develop the robust model for nutrients on Eucalyptus Paleta across Sabah under collaborative program. Thank you. That's all from me.
Thank you, Mr. Agustin Alwi. Next, we have Mr. Megat Najib bin Megat Mohammad Nazir, a GIS Senior Executive from Borneo Forestry Cooperative, Malaysia, with a poster presentation titled Early Monitoring of Tree Health Status via Visible Spectrum Imaging of Tree Foliage using Unmanned Aerial Vehicles.
The title of my poster is Early Monitoring of Tree Health Status via Visible Spectrum Imaging of Tree Foliage using Unmanned Aerial Vehicle. As we know, field surveys are important for pest and disease detection. However, they are labor-intensive, time-consuming, and are not practical in areas with a particularly steep terrain. Therefore, precision agriculture technique using the high-resolution remote sensing from unmanned aerial vehicle with a variety of different sensors, or even the conventional one, red, green, and blue camera, will lead to cheaper and more practical monitoring of forest health. So in this study, an intentional decision to explore the capability of a ready, available, and affordable system without the need for expensive or sophisticated equipment such as a hyperspectral or manispectral camera to monitor the tree health status in the forest plantation. There are 3 objectives in this study. First one is to investigate tree health status of young Eucalyptus Paleta using the unmanned aerial vehicle. The second one is to develop an index classification based on the Pedigree algorithm in the young Eucalyptus Paleta plantations. Last but not least, to investigate the difference between Pedigree and normalized digital vegetation index in terms of index value signature relative to the tree health state. This study was undertaken in the industrial tree plantations of Brumas Estate, Sabah Soful Purhat, and the high-resolution aerial image were acquired using UAV, namely a Phantom 4 Pro, equipped with the RGB camera. The aerial survey work was undertaken on 27 November 2019 with an altitude above the canopy is 129 meters. After the data acquisition process, images were processed using the adhesive software to generate the orthomosaic. Then the image analysis was performed using the ArcGIS software. The variegram index is a vegetation index produced entirely the visible region of spectrum and using the algorithm of green minus red divided by green plus red minus blue. This index will be generate a greenness level from which tree health can be determined. The higher the level of the index, the healthier the tree. Figure 2 show the procedure to generate varigreen plot from the raw data. Varigreen output is produced the value from -2 to 2. From this data, the classification of tree health status was created based on the percentage of red in the varigreen tree crown. In block 42H, a total of 11,069 Paleta trees were recorded, and 7 were classified as dead with the varigreen value -2 to 0, and 5 were severely infected with the varigreen value 0 to 0.05, and 967 trees were mildly infected with the varigreen value of 0.06 to 0.1. Last but not least, around 10,000 were considered healthy with a varigreen value 0.17 to 2. The resulting correlation between NDVI and varigreen shows slightly difference by plot with the mean correlation value for the trial plot of 0.73. Besides that, we also do the accuracy classification assessment. We adopt a confusion metric and the kappa coefficients. The overall accuracy succeeded in identifying with more than 90% accuracy. And as a conclusion, without the need for more expensive hyperspectral camera, simple RGB image processed using the varigreen algorithm were able to assess pest and disease early in the growth stage. The result of this study has shown that the infestation and infection of unhealthy trees in the industrial tree plantation could be detected with a varigreen image obtained from a low-cost drone across the large area, 22.78 hectares. And that's all from me. Thank you very much.
Thank you very much, Mr. Magat. Next, we will have Mr. Hamzat Fahmi, R&D Officer from Borneo Forestry Cooperative as well, Malaysia, with the title of Near-Infrared Spectroscopy of Plantation Forest Soil Nutrients in Sabah, Malaysia, and the Potential for Microsite.
Assalamualaikum and good day to everyone. I wish you all are well and staying safe and healthy. I am Hamzat Fahmi Ahmadjani, representing Borneo Forestry Cooperative. First of all, I would like to express my gratitude to IUFRO for accepting my participants in the 2021 IUFRO Conference poster presentation. Soil is principally a medium for plant growth, and soil fertility is the capacity of soil to provide essential plant nutrients to ensure optimum plant productivity. In other words, soil fertility represents the quality of a soil. This information can be obtained by analyzing a soil sample for its physical and chemical properties. So knowledge of soil physical and chemical properties is vital to the optimal growing performance of agricultural crops, including plantation forest trees. Near-infrared spectroscopy has been shown to be a tool that enables rapid and low-cost assessment of soils. However, its use in forest plantations has been slow to develop. This study shows the development of calibration for total organic carbon, total nitrogen, and soil pH, using a handheld NIL spectrometer for soils at 3 sites in Sabah, Malaysia. Methodology. As you can see in the diagram, this is the series of steps that has been taken to select the best model for this study. It starts from soil sampling, where we have collected samples from 3 sites within Sabah. And then we prepare the soil samples, and then we acquire the NIR spectra using the near-infrared spectroscopy. And the samples that has been scanned are sent to an ISO certified laboratory for compositional analysis. Once we have the data, we will run a multivariate data analysis that is performed using the unscrambler version 10.5. Once we run the data analysis, then we will do the calibration and validation, as well evaluating the model performance in order to select the best model for this study. Now let's go to the results. Based on the figure 1, based on the laboratory result, and as expected, total nitrogen and total organic carbon from A horizon are higher or more concentrated than the B horizon samples across all 3 sites. The correlations between organic carbon and total nitrogen at each site are moderate to strong. For the principal component analysis, by using the raw spectra, which you can refer to figure 2, from the calibration set showed that samples were not spectrally distinct for the first 3 principal components, which together explain 99.7% of the total spectral variance. For partially square regression of total organic carbon, total nitrogen, and pH using the spectra from dry soil, as shown in table 1, the results for root mean square error predicted values for organic carbon are similar to the reported calibrations in the neighboring country of Papua New Guinea and also in New South Wales, Australia. In the case of total nitrogen, the root mean square error predicted values is ranging from 0.02 grams to 0.05 grams in the A horizon. While for soil pH, although it was not validated with a test set, the root mean square error calibrations values is in the range of 0.14 to 0.17 pH units, which are comparable to other studies. So from the calibration and also model that has been developed, we try to use it for special mapping of a site, which we can look at the figure 3, which shows the NIR predicted values of TOC, TN, and pH for spectra acquired from A horizon in replicate 4 on the top of the picture, and also in replicate 8 on the bottom picture of A5 Paleta progeny trial using the SNV calibration for TOC and TN, and the first derivative for pH. So from the result, they show there is a variance in between replicate 8 and replicate 4. And the result also shows that concentrations for both organic carbon and total nitrogen in replicate 4 are lower in the A horizon than the B horizon, presumably due to the runoff from A horizon and slow percolation of nutrients into the lower depth soil where they accumulate. So this study shows the ability of NIR spectroscopy to provide high spatial soil data along with spatial analysis of variance of growth. As for conclusion, the result shows the practical use of a handheld NIR spectrometer to predict total nitrogen, total organic carbon, and soil pH in soils across plantation forest sites in Sabah. And the results for organic carbon are similar to other reported calibrations as we speak before to the neighboring country, and is acceptable for total nitrogen results. While pH was not validated with test set, but the results are comparable to other recent studies. And that's all from me. Thank you and have a good day.
Thank you very much, Mr. Hamzat Fahmi. Ladies and gentlemen, fellow participants, we will be having a tea break time here, Malaysia time. It's 4 p.m. here. So we will come back in 15 minutes time and we will continue with another 7 poster presentations. For your kind info as well, we are trying to get back Dr. Maheswaran to present his presentation. So we pray that we can have him back again here in the conference. So I will see you again in approximately 15 minutes from now. Thank you very much.
tadi kita tengok kan list tu kan. Kegiatan open untuk kemah. Arahan untuk kita ke arahan untuk orang? Jawapan tu nak bentuk dalam mereka apa? Baik seminggu je. Kalau Dr. Mandy stay dengan kau 3 minggu, tak payahlah aku. Woi, nak refer apa ni woi? Ni malah aku nak tanya pada Masna. But wait, ni Kalau aku balik ni kan, balik rumah ni kan, banyak bertanda tu. Sebab kucing, si kucing.
Ladies and gentlemen, fellow participants, thank you for still being with us here today. So next we will continue with the poster presentations sessions. I would like to invite Ms. Sabrina Aulak, R&D Assistant Manager at Borneo Forestry Cooperative, Malaysia, with the title of Development of Synthetic Seed from Selected Genotypes of Eucalyptus Paleta FML.
And very good day to dearest viewers. Today I will be presenting my poster presentation on development of synthetic seeds for preservation of selected genotypes of Eucalyptus Paleta. So a little bit of introductions regarding E. Paleta is that this species is one of the most promising belonging for the rapid characteristic that can produce valuable products for both pulp and wood industry. This species has the best growth of and skin characteristic, which immune to plague, adaptability to range of environmental situations, and have the ability to produce multi-purpose wood. Tissue culture of Eucalyptus Paleta has become a reliable technique for rapid, high quality, and large-scale clonal propagations. However, information on preserving the elite genotype is still lacking. So with such information, it can be useful for preserving elite genotypes, preventing aging during the incubation period. So to our knowledge, this is the first report on developing synthetic seeds for Eucalyptus Paleta. Even though other has report on 3 species regarding synthetic seeds, but not encounter with E. Paleta has been detailed. So in order to study more detail into this research, we came out with an objective to develop successful and efficient method of creating synthetic seeds using various concentrations of sodium alginate and calcium chloride for encapsulations, and to examine the temporal effect of storing the synthetic seeds on germination and the survival. So as for the raw materials, the copies of the E. Paleta were taken from mini cutting in hedges, and the explant were surface sterilized using commercial Clorox, commercial sodium hypochlorite within 50%, and the explant were inoculated into MS medium to induce the shoot, which this shoot from the microshoot will be used as the main source for encapsulation purposes. The microshoot were encapsulated using different range of sodium alginate and calcium chloride, which started from 2% until 4%, and then stored for 30 and 60 days. And after that, the encapsulated microshoot were then regenerated back into the MS medium to examine the germination rate. So as for the result, different combinations of sodium alginate and calcium chloride has been employed to efficiently optimize the conversion ability of the encapsulated microshoots. And the maximum encapsulated was seen by treating the microshoot with 3% of sodium alginate and 100 micromolar calcium chloride by Huang and Truman. It was also recommended that suitable combination of nutrient growth regulators and protectants were added to alginate to produce better growth yield in explant. It was also observed that high percentage of sodium alginate form hard beads that have comparatively low conversion capacity, which also reported by Mohammad. Different genotypes do not grow at the same rate when placed in the culture, and this induces risk of selections when plants are placed under stress conditions, such as low growth. The germination rate, shoot length, and the number of shoot elongated per synthetic seeds of E. Paleta was measured by the storage duration period, and it was found that the day storage duration give 55% germination rate. The mean of harvestable shoot is 7.75 with the mean of shoot length of 1.76 centimeter per synthetic seeds after 4 weeks germination in MS medium. In the present study, synthetic seed shows highest frequency of conversion after 30 days of storage, which was however reduced when the encapsulated microshoot was kept for more than 60 days. Particularly at 60 days of storage, encapsulated propagules has low germinations, which is shown in figure 3. So as for the conclusion, this study demonstrates that the potential using synthetic seeds to preserve the genotype in vitro was successfully achieved. And it also proven that encapsulated elite genotype of E. Paleta microshoot could be an alternative to preserve the clonal propagations. And this technology can benefit the world wood industry by addressing clonal plant demand. Thank you.
Thank you, Ms. Sabrina. Yes, sorry. Next, we have Ms. Sandra Sherry, a lecturer from La Plata University, Rio Negro University, Argentina, with the title of In Vitro Propagations of Bachellia cavern.
Hello, my name is Sandra Sherry, and I am a professor at the National University of La Plata and the National University in Rio Negro in Patagonia, Argentina. First of all, I would like to thank the organizer for offering this space for the exchange of knowledge about acacias. I am going to present a part of our work, in this case about the in vitro propagation of Espinilio or Roman cassie, which we do with Sebastián Galarco, Diego Ramilo, Marina Dema, and Blanca Villarreal. Bachellia cavern, ex Acacia cavern, is a native to Argentina, Bolivia, Chile, Paraguay, and Uruguay. It has ornamental, industrial, and medicinal uses. Tannin from the seed pod is used to tan skin. Wood is used as fuel and make fence posts. The main current human use is in charcoal production. It is very important for erosion control in our country. Since the 90s, we have worked on in vitro tissue culture of these species with the aim of propagating, conserving, and producing it in a nursery for the restoration of ecosystems. We have generated some publication in both embryogenesis and organogenesis in order to micropropagation. This work shows one of the possible pathways of micropropagation. The objective of the work was to adjust the in vitro propagation of Bachellia cavern via somatic embryogenesis and microcapsids. Methodology explains where cotyledon obtained from immature seeds to induce somatic embryogenesis. The Murashigan Cook complete basal medium was used, containing combination of tidiazuron or benzylaminopurin, indolacetic acid, or 2,4-dichlorophenoxy acid. In exploratory assays, we used other plant regulators in different combinations. On the other hand, microcuttings were grown in vitro in Murashige's Cook half-strength medium with different concentration of sucrose. The cultures were incubated at 25 plus minus 2 Celsius degrees and 16 light hours. For each treatment, we use 30 explants. Some results. In all concentration of 2,4-D-induced pro-embryogenic cultures. At the beginning of the culture, somatic embryogenesis occurs directly on the cotyledons. Subsequently, the somatic embryos appear from cultures. Approximately 10 days after the culture begins, globular embryos appear, always on the adaxial face of the cotyledon. Somatic embryos at globular stage were obtained in Murashige's medium with 2,4-D at 1 part per million, or with benzylaminopurin at 0.1 part per million, or in Murashige and Scoop free of plant regulators medium. A greater number of somatic embryos were observed in the medium free of growth regulators, and a remarkable differentiation of embryos was observed in the medium with 1 part per million of 2,4-D without the addition of any synethine. Somatic embryos were subcultured in the medium Murashige medium without plant growth regulators, or with 0.5 part per million of the gibberellic acid. Germination and conversion into whole plants was successful but was low, 30%. On the other hand, nodal section for in vitro plants culture on Murashevsky medium as half strength plus 40 or 90 grams per liter of sucrose formed new shoots, and after that routine was obtained. The West result was with 70 to 19 grams per liter of sucrose. In conclusion, somatic embryogenesis from cotyledons and in vitro routine of microcations were adjusted. Of the cotyledonary stage, somatic embryos, 30% germinate into seedling that could be successfully transferred to pods. Microcation is influenced by the sucrose concentration, and whole plants through type was cultivated in the field. As you can see here, we show the plants, the callus, embryogenic callus, the embryos formed in different stage, the embryos germination, and the complete plants. In this side, we can see the nodal section, shoots, and the complete plants in pots. Sun.
Thank you very much, Dr. Sandra. Next, we have Dr. Arunachalan Shanti, a researcher from Institute of Forest Genetics and Tree Breeding, India, with the title of Estimations of Outcrossing Rate in the First and Second Generations Orchards of Acacia auriculiformis.
Good evening to all. I want to share my research experience in Acacia auriculiformis. 2 decades before the Institute initiated the tree food program on Acacia auriculiformis with the help of CSIRO Australia. They have the base populations, and from the base populations, they have raised the second generation's populations. So almost the first and second generations populations of Acacia in different families were assembled in the different locations of Tamil Nadu as well as Kerala. The breeders, they have selected some of the high-yielding families were shortlisted. So another aspect among the orchards, the one orchard having a problem of seed setting as well as the low germinations. So we want to address the problem using the DNA marker for matching system analysis in different orchards populations. So we have selected different families in both generation orchards, collected seeds, and raised individual family beds in the nursery, and DNA were isolated from almost 300 individual progenies for both the generations, and 10 microsatellite primers. They were already developed and characterized by Dr. Vicky and team in the Acacia hybrids. Therefore, these primers were amplified with Acacia auriculiformis progenies, and we have got a very good segregation pattern of alleles, homozygous and heterozygous forms. These alleles were subjected to special software, that is MLTR software, to analyze crossing rate estimates. So with the help of this software, we have got different genotypes, and we have got allele genotype frequencies, and we have got the maternal genotypes in both orchards, and we have got the estimation outcrossing rate of single locus and multi-locus outcrossing rate. So Overall, in both the generations, we have got a high outcrossing rate that expressed in the population. So 0.91, almost very good outcrossing rate estimate. So when we study the seed aspect of these seed different parameters of both generations, we have found a very good mean of value in second generation seed, improved seed. So based on these studies, we have found a very good outcast genotypes. It helps the breeder for going further decision to advanced breeding program. So, and also what we found as the low seed set archer, we have found a very low generation value and the seeds setting also very low. So when we did for the mapping analysis, including the populations having a very the value is very low. So the breeding maybe due to breeding depressions. For single seed archer, we can't consider that the archer will be for seed collections. So we can eliminate for the families the application itself. So from this mapping analysis, we found massive first genotypes in Acacia forms. This is a small work what we have done in our lab presenting. So I would like to my sincere and heartfelt thanks to the organizing secretary for organizers for giving this opportunity to present my work. I'm very grateful and sincere thanks to my director, IUFRO, and also my director general for giving the financial support. So thank you so much.
Thank you very much, Dr. Arun Nachalan Shanti. Next, we have Ms. Fiona Evelyn Anthony, a research officer from Sabah Forestry Development Authority, Malaysia, with the title of Incidence and Severity of Wilt in Acacia Manjum Plantations in Ulu Kakut, Sabah, Malaysia.
Good day, everyone. I would like to introduce myself. I'm Fiona Evelyn Anthony and currently attached to Sabah Forestry Development Authority, in short, SAFODA. I'm currently pursuing my postgraduate study at University Malaysia Sabah. The title of my poster is Incidences and Severity of Vascular Wilt in Acacia Manjum Plantation at SAFODA Ulu Kakut, Sabah, Malaysia. Acacia manjum is a leguminosae fixing nitrogen, easy to plant, superior growth, and supports lack of serious pest problem. It was first introduced in Sabah in 1966 and planted as a fibrate. As on June 2021, only about 43,589 hectares of Acacia manjum covers in Sabah. As of SAFODA, it has 1,500 hectares planted with Acacia manjum at Ulu Kakut Plantation. The alarming emergence of a fatal situation of rate of mortality more than 50% certainly warranted studies to further explore about the incidence and severity of wilt disease situation in acacia stands in SAFODA Plantation. I will go direct to the methods and materials. The study site is at SAFODA Plantation at Ulu Kakut, which is situated between Kota Belud and Kota Marudu. Prior to conducting survey, all scientific data such as silviculture regimes, plantation size, and other relevant information of the plantation obtained from the regional office. Field staff involved were trained to familiarize symptoms of wilt. There were 7 plots established with 7 age class planted from year 2011 to 2017. The size of each plot is 50 meter by 50 meter, and it is complete randomized block design. 2 observations were conducted with 3 months interval. The survey and assessment of disease and symptom score were adopted from FRAME. Based on the results obtained, there were high incidences of wilting on trees planted in year 2016 and 2017. There were also significant correlation on the 2 observation between trees age and disease incidences and symptom severity index. In conclusion, the results show a high incidence of wilt on acacia trees at younger stands at Ulukukut, Safoda. So with that, I would like to take this opportunity to thank Safoda to provide a venue for the study and supporting this study all the way. And I acknowledge and thank you to University Malaysia Sabah too for providing me grant to conduct this study. All the references on the poster being used for this study. And with that, I end my presentation. Thank you very much.
Thank you very much, Ms. Fiona Evelyn. Next, we have Ms. Sulimawati Supuf, R&D Officer from Borneo Forestry Cooperative Malaysia, with the title of Improving Efficiency in Micropropagations of Eucalyptus Paleta.
Eucalyptus is one of the most common tropical tree plantation species in the world. It is recognized as a greater potential hardwood forest plantation genus. In Malaysia, eucalyptus has been planted in several areas in Peninsular Malaysia, Sabah and Sarawak. Eucalyptus comprise more than 700 varieties of species around the world. However, the varieties that can adapt to severe climate condition and disease resistance are limited, and Eucalyptus paleta offering the possibility of could adapt to climate changing and more resistant to attack by pathogenic fungi and insects rather than other eucalyptus. Propagation of eucalyptus has been improvised and advanced. Besides using seeds, micropropagation using direct organogenesis method is an alternative way of producing large number of new clonal plants within shorter period of times. However, Eucalyptus paleta micropropagation response among genotypes are variable according to culture medium, concentration of plant regulators or PGR, and also affected by carbon source. Therefore, in this study, 2 genotypes were selected for the refinements of existing method and to determine applicable strength of culture medium with suitable concentration of hormone or PGR for increasing in vitro culturing of Eucalyptus paleta for regenerate many more shoot and encourage shoot to grow or elongate. The aim also to determine the effect of various sucrose concentration on root development in vitro and plantlet acclimatization survival. For micropropagation, explants were initially collected in the hedges and then introduced to culture medium for shoot induction.
In multiplication, shoot explants from the introduction then were tested with half and full strength MS culture medium and different growth regulators, which is naphthalene acetic acid NAA and 6-benzyl aminopyrin BAP, to encourage shoot to multiply and grow. From the multiplication, the elongated shoot then were transferred to medium containing 10, 20, 30, and 40 grams per liter medium sucrose during the rooting phase to test its effect, the shoot and root development, growth and survival after the flush. After 4 weeks in rooting phase, rooted plants were planted into soil and acclimatized in nursery for 21 days. From the experiment being conducted on 2 genetics of Eucalyptus Paleta, the result indicate that full strength MS medium with combination of 0.1 mg per liter NAA and 0.25 mg per liter medium BAP increased elongated shoot productivity from the shoot expand, is shown in Table 1 and Figure 2. In rooting phase, high sucrose concentration induced good formation of root system with greater root number and root length, is shown in Table 2. However, was 4 grams per liter sucrose better for root system development in vitro, acclimatization potential was higher using 2 grams per liter sucrose, which is giving the highest survival after hardening and transferring to protein media, which 96% of survival recorded. It can be concluded that refinement of micropropagation method of Eucalyptus Paleta has increased the efficiency of plantlet production and significantly improved the survival during acclimatization. That's all. Thank you.
Thank you very much, Ms. Sulimawati. Next, we have Ms. Zahidah Safian, Research Officer from Forest Research Institute Malaysia, FRIM, Malaysia, with assessment of kiln-dry acacia medium for productions of quality value-added products.
Hi, and a very good day to all. My name is Zahidah binti Zafian, and I come from Forest Research Institute Malaysia, which is also known as FRIM. My presentation today entitled Assessment of Kiln-dry Acacia Medium for Production of Quality Value-Added Products. In this project, FRIM has started a collaboration with STIA, which is Sambah Timber Industry Association, in order to optimize the quality of the kiln-dry acacia timber produce, which can be subsequently used in the production of laminated truck flooring and other wooden products. As we all know, acacia faces a lot of drying problem. One of the major problems is the occurrence of the moisture wet pockets in the lumber. This is mainly due to the inherent characteristic of the lumber. Wet pocket may lead to uneven moisture content within lumber and subsequently result in collapse and internal check. Furthermore, the acacia also experience wood defects such as check, cut, spring, and this defect will increase after drying. Under this project, a series of commercial drying trials were conducted in selected timber processing mills in Sabah, Malaysia. The drying trials include the preparation of the sample boards in order for monitoring of the kiln drying activities, and also to determine the rate of drying and also to assess any physical changes or defects during drying. Furthermore, the sample board were also inserted with thermocouple in order to monitor the temperature of the wood during drying. This is the optimized drying schedule that was successfully developed from the commercial drying trial. By using this schedule, the drying time for acacia was able to be reduced down to 50% as compared to the existing kiln process. By using this schedule, the acacia medium was able to dry uniformly throughout the timber, and the variation of MC between the inner and also the outer layer of the timber was 2%, which is within permissible range. Furthermore, the occurrence of the wet pockets was able to be eliminated after drying. After drying, the dry acacia timber were tested for their mechanical properties such as bending, hardness, and shear properties. From the result, the modulus of rupture and the modulus of elasticity of kiln-dried Acacia zone were 137.48 and 30,842.3 Newton per millimeter square, whereas the mean value for hardness was 5.18 kilonewton, and the Acacia timber obtained a mean shear stress value of 17.12 Newton per millimeter square. The dried sawn Acacia sample were further processed and fabricated into finger-jointed components and laminated board for delamination testing. The fabrication of the finger joint were started in wood lamination lab in frame and also at Kilang Papan KK Hasan in Kota Marudu, Sabah. After that, the delamination test was carried out at the laboratory in frame and also in Singapore. The testing were carried out under the JASO standard, which is the standard for wooden parts for cargo bed of motor truck. From the result, all test pieces have met the criteria for delamination of finger joint. The Acacia finger joint test pieces also met the criteria for Young's modulus in bending, with an average bending strength value of 70 MPa. In addition, matched finger joint sample that was sent to the accredited lab in Singapore also fulfilled the test criteria for both delamination and bending under the same standard. So, as a conclusion, the finding from the study showed that all samples met the test criteria for delamination properties. The finger joint products is found suitable to be used for production of the laminated truck flooring and other wooden products. With that, I thank you.
Okay, sorry. Thank you. So thank you very much. And now we would like to invite Ms. Noor Fadila Wook, Research Officer from Forest Research Institute Malaysia frame, with the title of Growth Variations in the Clonal Tests of Acacia Hybrid at Segamat, Johor and Bintulu, Sarawak, Malaysia.
Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everyone. My name is Noor Fadila. I am from Forest Research Institute Malaysia. Today I will be presenting my poster entitled Growth Variations in the Clonal Test of Acacia Hybrid at Segamat, Johor and Bintulu, Sarawak. Okay, as we know, the desirable characteristic of Acacia Hybrid make it a viable candidate for forest plantations. However, in Malaysia, there is very little information on Acacia Hybrid clones, making Acacia mangium more preferable among the industrial planters. Therefore, this study was initiated to develop clones of Acacia Hybrid that are suitable to be planted in forest plantation programs. In this project, Acacia Hybrids was produced via controlled pollination technique using two parent trees, Acacia mangium and Acacia auriculiformis. The selection of the parent trees were made based on the wood density and fiber length. Okay, after we got the hybrid seeds, the seedling verifications was made using a loci marker. The self-seedlings were discarded. And then after we get the progenies, mass propagation were made via tissue culture. Upon the maturity of the seedlings, we established clonal trial plots at Segamat, Johor and Bintulu, Sarawak. They were in 2009 and 2012 respectively. So the maintenance activities and collection of growth data were conducted annually. Okay, upon this study, we find that there are 4 potential high-performing Acacia hybrid clones, namely F104, F175, F176 and F177. Based on the analysis of variance, we observe that there are significant variations among the 329 clones tested in the trial. And then we observe that there are significant interactions between the sites and the clones. And we also observe a significant variation between the two sites. In general, Acacia hybrid clones grown at Bintulu are much better in terms of growth performance as compared to clones that were grown in Segamat, Johor. Okay, if we take a look at the mean annual increment of the diameter at breast height and total height, range of the DBH were from 4.6 to 5.1, whereas as for the MAI for height, range from 4.5 to 5.6. This is in accordance to the previous study by Sean and Mitlohner. The values of the MAI for DBH and total height were in accordance to the expected value for Acacia hybrid. Okay, before I end, considering that Acacia wilt disease is currently an imminent threat towards the Acacia plantation, so we are considering to find Acacia hybrid clones that are at least tolerant, or hopefully we get the resistant clones towards the wilt disease. I think with that, I thank you.
Thank you very much, Ms. Nur Fadilawuk. Thank you to all poster presenters. Distinguished participants, ladies and gentlemen, we will be having the closing ceremony event in just a few moments. A very good afternoon to Yang Berbahagia Datuk Hamdan bin Haji Mohammad, Director of Forest Department Sarawak, Yang Berusaha Tuan Jack Liam, Deputy Director of Forest Conservation and Development, Professor Dr. Wiknaswari Ratnam, Coordinator of IUFRO Working Party 2.0807, and Ms. Zarina Shelby, Assistant Director, Restorations and Industrial Forest Division. Distinguished participants, ladies and gentlemen, welcome to the closing ceremony of the third IUFRO Acacia Webinar Conference 2021, live from Kuching, Sarawak, Malaysia. This year's IUFRO Acacia Conference features 40 oral and 11 posters, papers, presentations attended by more than 600 participants from 28 countries. We truly hope that you have a fruitful experience of learning, sharing, and networking. However, all good things must come to an end. With that, I would like to invite Yang Berbahagia Datuk Hamdan bin Haji Mohammad, Director of Forest Department Sarawak, to deliver the closing remarks and to officiate the closing ceremony of the third IUFRO Acacia Webinar Conference 2021.
Thank you, Madam Anya. The Honorable Professor Dr. Wiknaswari, Coordinators of IUFRO Working Parties, Yang Berbahagia Tuan Jack Liam, Deputy Director of Forest Department of Sarawak, Yang Berusaha Cik Zarina Shelby, Assistant Director, Restorations and Industrial Forest Division, dear speakers, moderators, participants, ladies and gentlemen. We have now coming to the end of this third IUFRO conference on embracing transformation for sustainable management of industrial forest plantations. It is a privilege and an honor to be entrusted to give a summary and closing remark at a virtual gathering of such eminent people from the international renowned research center, government agencies, universities, and industry. COVID-19 has brought unprecedented and unforeseen transformations in nearly every aspect of our life. This pandemic has stimulated digitalization process and across sectors, popularized work from home as a new norm, and highlighted importance of a resilient global supply chains in order to withstand black swans events like COVID-19. These new norms is forcing us, Forest Department of Sarawak, to rapidly adjust and build the future as we go. We have conducted quite a number of talks, seminars, and conferences in hybrid or virtual mode, but to conduct an international conference in a full virtual mode, this third IUFRO Acacia Conference 2021 is our first step to embrace this new norms transformation. Ladies and gentlemen, the theme of this conference, Embracing the Transformations for Sustainable Management of Industrial Forest Plantations, was set in year 2019 before the outbreak of the pandemic to answer to the Sarawak state government's call on the applications of technologies and innovations in upstream and downstreams of R&D. In a keynote address by Dr. Sananandan Nambiaya, he mentions that to reimage and transform plantations forestry in Asia, 4 main challenges should be addressed. Number 1, increase wood supply. Number 2, restore landscapes. Number 3, reduce the poverty. And number 4 is mitigate and adapt to climate change. In order to ensure Sarawak to able to embark on a full-fledged transformation, capitalizing on the mega trends around the world, all these 4 main challenges are well addressed in different strategic thrusts that focus on the transformations on economy competitiveness, social inclusiveness, optimizing the use of assets and human capital, digital and executions, and sustainable environment in the Sarawak post-COVID-19 Development Strategy 2030. For Sarawak, we already have a well-planned framework toward the transformations in all sectors, which include forest plantations too, as this is a very important sector that support the economic growth of the state. The questions now is how we are going to implement this planning. Ladies and gentlemen, as we all such event, this conference has been an outstanding example where our mind have been assailed by torrents of ideas, informations, statistics, interpretations, and visions. There is indeed plenty to reflect upon, and if this is the way enhance our individual and collective contributions to meeting the industry needs and challenges, then this conference can be truly be just a success. In this 3 days virtual conference, we have heard excellent presentations and sharing of 40 oral and 11 poster paper from 5 sessions that covered R&D, plantations and risk management, timber product and policies. We managed to virtually gather researcher, the industry, the scientists from the prominent research institutes from the different countries, as well as university students. In the first sessions, on industrial forest plantations policies, there were 3 speakers in these sessions from Malaysia, Tuan Haji Kamurazaman Osman from MTIB, Professor Ahmad Mayudi from Indonesia, and Dr. Wu Tan Phuon from Vietnam. Each speaker has vast experience and in-depth involvements on government's policies at their respective place. Policy can be one of the areas that we need to emphasize in order to sustainably manage our forest plantation. Countries like Vietnam and Indonesia can be the role model for Sarawak, especially their policy in overlooking the smallholder or cooperative, where we can further the rural community in eradicating the rural poverty. Definitely, this will be an area of interest for Sarawak to work together with our counterparts in Indonesia and Vietnam. The decline in natural timber has prompted the need to develop industrial forest plantations to produce fast-growing material to bridge the timber supply gaps and to boost the economy. Therefore, in sessions 2, entitled Plantations Management for Sustainable Wood Productions, a few issues affecting the productivities of timber were addressed. Dr. Chris Howard, in his presentations, discussed the 2 main species, Acacia and Eucalyptus, in terms of productivity, pest and disease, plus other threats involved. However, I would like the R&D community to help us in developing the potential of our own native species to support the balance of our ecological biodiversity system. The sessions of risk management was quite a heavy and important topic to us, as it covered the most pressing issues on pest and disease management that affect the vitalities and productivities of our forest plantation. The important in implementing an effective targeted biosecurity measures in the Southeast Asia region to protect the regions from forest health, from invasive pests brought by the movements of broad trade link with and outside, within and outside our regions was also discussed. Ladies and gentlemen, I understand that currently the forest plantations are planting more eucalyptus species such as Paleta, the hybrid, and these new findings will bring new headache to the planters, the breeders, and the researcher, as we are still struggling to mitigate the threat of ceratopsitis and root rot disease as well. From the presentations shared in session 5 of the genetic and breeding, we clearly notice that Indonesia, Vietnam, and China are far ahead in R&D on eucalyptus and acacia, backed by at least 50 years of research efforts. R&D has greatly facilitated expansion and proliferation of all parts of China eucalyptus industry per se. Compared to them, our current R&D is actually still at the infant stage. There is still a long way for us to go to achieve our aims. Dr. Jeremy has taught us an excellent idea in the beginning of his presentations. He mentions the importance of the cooperations for the long-term tree improvement activities, pooling of resources, sharing of knowledge and information, promoting partnership between public and corporate, industry and governments, and etc. Ladies and gentlemen, we do not wish to work in silo. We wish to work together with other stakeholders, academia, and neighboring countries who share the same interests. As the saying goes, alone we can do so little. Together we can do so much. So we should encourage collaborations for the growth and benefit of all relevant parties. I believe all the researchers in Asia understand that R&D is not a magic show. This is particularly clear in the effort of genetic improvement of tree species, which generally take more than 20 years of continual research effort. I believe deeply we cannot solve the issues and challenges of our times unless we perfect our collaborations by understanding that we may have a different story, but we hold a common hope and aims that we may have not the same principle, but we all want to move in the same directions towards a better future for our industrial forests. Forest Department of Sarawak welcome strategic collaborations and partnership. Do contact us or our researcher here. There are many people to thank in making this conference a success, including the speakers, posters, presenters, and moderators. The success of any seminar lies ultimately with the participant. I would like to thank the organizing committee for their enthusiasm and dedicated work in the preparations for the third IUFRO Acacia conference. This group of young researchers is brave enough to take challenges and put their heart and soul to make these events happen. Ladies and gentlemen, last but not least, I would like to thank IUFRO Working Party on Acacia Genetic and Silviculture for giving us this opportunity to organize this meaningful conference. We hope there will be more chances for us to work together with an organizations like IUFRO in the future. I'm extremely pleased that this conference was well attended by scientists, governments, officials, policy makers, and industry practitioners from different countries. Lastly, thanks for joining us in this conference. Thank you very much.
We have now come to the end of the third IUFRO Webinar Conference 2021 in the land of the Hornbill, Sarawak. On behalf of the organizing committee, we would like first to express our deepest gratitude to Yang Berbahagia Dato' Hamdan for your endless support in making this conference a reality. To Professor Dr. Wignaswari and IUFRO Working Party, thank you for the trust to bring this international conference here in Kuching, Sarawak. To all fellow participants, moderators, speakers, poster presenter, thank you again for your great contribution in this conference, especially to the world of research and developments creating a vigorous and resilient forest plantation industry globally. And to all my colleagues, we have made this conference a success. Let us congratulate ourselves for all our blood, sweat, and tears in making this conference a good, memorable one. I end my duty as Master of Ceremony for today's event. Hope to see all of you again in the next event. Thank you very much. Thank you to all fellow delegates and participants of the third UFRO Acacia Conference 2021. I hope to see you all again here in the next event. Please welcome to Kuching, Sarawak, Malaysia. Thank you very much again.
Thank you. Thank you, Dr. Nambia. Thank you, Dr. Wiki. Pak Eko.
Thanks
Yeah,
very
see you
much.
next time.
Indeed.
Bye-bye.
All the best. Well done.
Yep.
Fantastic job.
All the best to you too.
Yeah, fantastic job. Well done. Terrific. Yeah. Echo. Cheers.
Thank you very much.
Yes. Thank you. Wonderful.
Thanks.
See you, Vicky. Thank you. Cheers. Cheers. Goodbye, Sarawak. Thank you very much.
See you around.
Yeah, see you.
Yeah.
Okay, Pak Eko.
Thank you, Bu Yani.
Ya, sama.
Well done.
Yeah.
Congratulations.
Okay, jumpa in the next IUFRO conference.
Yeah, see you. Yeah, looking forward to.